now that we've said our goodbyes.
What's up, man?
Yeah, good man. How are you?
Oh, just about to head into the gym and start working out. I'm a little late today because my kid forgot his school ID card. Go home and get that.
Oh, awesome stuff.
Hey, Indy, can I get back to you with that airplane thing that we were talking about?
Yeah, of course. Let's go back to that.
Sorry for disturbing you guys, interrupting you. So I was saying that, as you said, why it needs to catch up, right? But the thing is, when you talk about inertia, the rotational acceleration that the Earth has when it's rotating is passed on to the airplane as well. And
How?
since you know about the law of inertia,
Okay, but when the aircraft leaves one airport, how does
hmm,
it gain the inertia of the Earth as it's not attached to the Earth anymore?
well, as I said, if I throw the ball towards you, even though it's not attached to the train, it will move towards in the direction of train as well. No,
It depends if me and you are running together, but I'm moving faster than you, as in I'm on the equator and you're 45 degrees, you're going to have to aim in
coming,
front of me.
and I'm trying to explain why that is, because even though the equator is faster, tangential
Mm.
velocity of the equator is faster, but the acceleration that they are rotating at is same, right? Right? Can you agree on that?
Yeah, it's the same. The Earth's not
Hmm.
changing its rotation, but we're talking about rim velocity as opposed to rotational angular velocity.
I'm coming back to that. So the rotational acceleration at the north, at New York, let's say, is also the same as that. So the tangential acceleration, which is directly proportional to rotational acceleration, as we know, which defines the velocity at tangent, is also same. So since the airplane has an acceleration tangential to the Earth's surface, it doesn't need to catch up to the mm, surface at equator because it already has an acceleration in that direction.
That
Or the
doesn't.
Earth is just
That's not
stationary.
correct. None of that's
What?
correct. None of that is correct, dude.
Why?
None of it.
Okay, what's
Okay,
wrong
let's
with
say I'm standing at the North Pole. How fast am I rotating?
what? Do I have
How
to do
fast?
calculations here?
I'm at the North Pole. How
Hmm,
fast am I rotating?
I don't know the number, the speed.
Zero, bro.
Okay,
Zero.
fair. At the North Pole, exactly. Okay, fair. Yeah, right.
My tangential velocity is zero. Now I walk south. Doo, 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 and I land at the equator. How fast am I moving now?
You're
Zero?
completely ignoring
Or
the
more than that?
acceleration
You're
there.
confusing a rotating reference frame with a non-rotating reference frame. Okay?
No, I'm not.
The plane
Hmm.
is not on the surface of the Earth, right? It's not where we
But
put
it
planes.
still has the inertial acceleration
Yeah,
that is
it has
rotation of the
500 miles
Earth.
per hour. That's right, 500 miles per hour in New York.
It's speed. I'm talking about acceleration.
Yeah, 500 miles an
Yes,
hour.
500 miles per hour. It's going in a circle, right?
That's
Why?
the speed of
It's
the Earth at
That's
New York.
speed. Miles per hour is speed. I'm talking about acceleration there. The acceleration of the rotating Earth is what defines the um fact that we are not catching up to the equator.
What's
Okay.
the rotate? What's the acceleration at 45?
Acceleration is same all throughout the
What
Earth.
is on the equator?
That's
Yeah,
not
the
possible.
acceleration is same on the equator.
Same at the North Pole.
Yes. The velocity on North Pole is zero because the radius is zero. Since there is no radius, the tangential acceleration will be zero because, as I said,
Okay.
tangential acceleration is directly proportional to centrifugal and radius of the and the distance from the axis that it's rotating on. So that's why the velocity on North Pole is zero, and it's highest on the equator of the Earth, and it's in between the equator
Haven't
and
you
other poles.
okay. Haven't you ever heard that if you weigh something at the North Pole and weigh something at the equator, it'll weigh less at the equator? Have you ever heard that before?
Wait, let me see. Maybe I have heard that. I don't quite remember. But yeah, continue. What were you saying about that?
If you take something that weighs 1 kilo and you weigh it at the North Pole and then you go to the equator, they say it weighs less. Right?
Mm-hmm.
Acceleration would have to be different. That would be a non-uniform acceleration, right? But we're not talking about the acceleration. We're talking about
That's
the
gravitational
tangential
explanation that you're talking about. When I was talking about the
gravity.
airplane
No.
moving to the 9.8 thing is gravity, isn't it?
Yeah, but that's an acceleration, right?
Yeah,
It's
it
the
is.
difference. But so you have the centripetal versus the centrifugal force. Okay. And the centrifugal force at the equator would be greater than at the poles. The centripetal force is the inward. Anyway, that's not the important part. This is all smoke and mirrors. The important part is we're talking about tangential velocity. We're talking about the guys trying to land a plane on a runway that's going 500 miles per hour. The ground underneath his airplane is going 500 miles per hour in his reference frame. Let's talk about the reference frame of the airplane.
Mm-hmm.
Okay. So from within the reference frame of the airplane, the ground is going 500 miles per hour faster. Yeah, sure. He has the inertia. He has the inertia from New York City. He has its tangential velocity, its acceleration, whatever you want. But think about the Earth as like, say it was a giant spinning disc, and if you were in the center, try to walk to the edge in a straight line, right? What's going to happen? Can you walk to the edge in a straight line? From your reference frame, you can walk to the edge in a straight line. But from above it, you would have to take a curved path. Now, to take a curved path, you have to have an acceleration. So for some reason, the plane would have to accelerate to catch up in the absolute reference frame. From the external reference frame, the plane would have to accelerate to get to the edge.
Can I just say that? I think that you're actually assuming, or I don't know, but the plane is also accelerating in that direction with the same acceleration of the Earth, rotational acceleration of the Earth.
The same in New York as it
Where's
is.
this energy coming from?
That's inertia. Inertia just doesn't just entails velocity.
Okay. That's why I don't know what you're not understanding. How fast? If you had a radar speedometer, speed gun, right? You know, one of the how do I call it? Tachyometer. If you had a laser tachyometer, and you're in outer space, and you shot it at someone in New York, their speed would read 500 miles per hour. And then if you did the same thing, a radar gun, they would be 1,000 miles per hour.
Well, that's because still measuring the speed from an inertial
Yeah.
frame of reference.
Exactly.
So it doesn't.
Yes.
So
What's wrong with
are
that?
we not saying
When
the
you're
same
in
thing
the
then?
airplane, you are not in the rotating reference frame anymore.
We are still at the rotating reference frame, aren't we?
Oh,
We are
you're
on
not
Earth.
connected to it.
Are we taking this, or are we measuring the speed from the space?
Oh,
Why are you?
okay. Why
Or
is that
maybe I
different?
misunderstood something there. I
Why is
think
that
I omitted
different?
some.
The airplane is in the sky, right?
Mm-hmm.
Okay, so it's not on the surface of the Earth.
Mm-hmm.
So how does anything the Earth doing influence the plane? What the plane's doing?
Because it carried the inertial force of the rotation of Earth.
Yeah, and at the New York City, it's different than at the
No,
equator.
that's what I'm trying to say. It's not different. The acceleration
It
is
has to be.
same.
It is.
The speed is different, but the acceleration is same.
The acceleration has to be different. Okay.
The
The
rotational
size of the
acceleration of
circle, the
Earth is
size of the
not.
circle is like say in
Mm-hmm.
24 hours, in 24 hours,
Mm-hmm.
right? In New York
Mm-hmm.
City, you're going to take a circular path, right?
Mm-hmm.
Is the size of that circle the same size as at the equator?
No.
Okay. So how do you traverse a larger distance at the equator without having a greater acceleration?
From what I understand is that the airplane
Yeah,
carries
now you
on the
see.
inertial force, which is the rotational movement of Earth, which
When it was
when
attached
And what we're
at
telling you,
500 mile
that's
an hour,
yeah,
bullshit.
when it was attached and then it accelerates in that direction
how?
because of that.
It's on the Earth and then it takes off at 500 miles an hour when it's on the Earth. So I give it to you there. Where does it gain the extra energy from to accelerate and match the equatorial speed?
Yes, I'll have to read more about that.
It's a bigger circle. Okay, so if we drew like if you had a a little circle and a big circle for them to make a 360-degree rotation, right? The bigger circle, whatever, has to go farther. Like the arc length is a longer distance. So to stay in line with a smaller circle, like say you had like a spoke on a wheel on a tire, right? You have your inner hub and then the outer tire. If you drew a line on each, like a mark, a chalk on each one of them, and you wanted to keep them lined up, the outer tire has to spin faster. Not faster in the rotational as in like rotations per minute,
Mhm.
not in that sense, but it has to travel across a further distance, right? Its arc length is greater. That would just be the measured length around its circumference, right?
Mhm.
So if the circumference of the circle at the equator is larger than the circumference of the latitude circle, right? Then you have to travel a greater distance. You have to have a greater acceleration. You'd have to accelerate to catch up to the equator. There's no doubt about it. And we know what the standard answer is. We've heard 100 times, but it doesn't fly. It doesn't make sense. It can't possibly be correct. It's just a bunch of word games. There's no substance to it. And like I said, I was trying to tell you guys, CERN, if you know what CERN is like the Large Hadron Collider, right? They smash protons together. They discovered the Higgs boson or whatever the crap that is. Okay, so a physicist from CERN has tried to defend this, and he can't, because there's no way you can make it work. You can't have a plane on a rotating ball land, fly north to south, because the actual path they take would have to be a curved path, right? Like, you know what? I'm gonna post in the chat a video of it.
Mm.
Of how,
Sure.
it's like it's just an animation of a plane and what a plane would have to do to stay over the same line of longitude on something that's rotating. That the path of the plane would have to be curved. So now you have a longer distance, right?
Mm.
So there has to be an acceleration because it's actually longer distance than the straight line path. But hold on, I'll get it. Jedi, if you want to talk, then go for it.
I do have one quick question myself, if you don't mind.
No, I don't
RK.
mind. Go ahead.
Yeah.
So if you're talking about the Earth and the sky being in the same inertial frame, right?
Mm.
And you can't tell that you're moving, then how do you know you're moving?
Because can you ask that question again?
Yeah, you're saying that the sky and the Earth move as one unit, right?
Mm-hmm.
So if you can't tell that you're moving, how do you know you're moving?
We can't tell that we are moving. I never said that.
Well, you're assuming that the Earth is spinning and rotating around the sun, right?
Mm-hmm.
How do you know that if you can't tell that you are?
Well, I can't know from my personal experience, but that explains, well, that just explains things because
No,
gravity works and stuff like that.
no one has a personal experience that
No one
puts
can ever have
the
an
Earth in
experience. Yeah, I agree.
that puts the Earth into motion. So it's a huge assumption, right? And then what
Yes,
happens is they build a story based on that huge assumption.
I think it's not a story actually. I think it's more proven than what
Well, if there's no evidence for it, then it's just a story, right?
there is theoretical evidence if that counts.
All right, let's say I tell you that I have a big fish. So I caught this huge fish, the
Mm-hmm.
biggest fish that was ever seen in the entire world, and
Mm-hmm.
it was up in the Arctic Circle, right? No one's ever seen this fish except for me. And then I build this entire story around the idea of this big fish, right? You see what I'm
We
saying?
know, at least we know there's a force that exists that is causing the things to fall down on the earth, and we can make a story around that, that it's
No,
gravity, and then maybe we
we don't
can.
know there's a force. We don't know there's a
We,
force.
uh, that's just denying physics again, I think,
No,
because
it's
there
not
has to
denying
be a
physics.
force for something to move.
There's no. How do you know there's a force? If there was a force, you'd be able to manipulate it.
Well, I can't manipulate the mass of earth, can I?
Well, then you don't have a force. You're just assuming it.
So how are things falling down then?
No one knows. Not even the greatest physicists in the world know. They're like, we don't know why this happens. We can calculate it, we
I
can
think that's
observe it, but we don't know why.
I think that's just ad hoc bandages that we're applying on it to justify something else.
That's not an ad hom. I'm directly attacking the claim. I'm not attacking a single person.
I think gravity explains a lot of things. So I think it
It
should be
doesn't.
true if it's not.
It
It does
doesn't
explain
explain
why things
anything.
fall down, at least.
No, it doesn't.
We
There's
have
no
no other
explanation for
explanation.
why it falls down.
There is, because Earth
Do
attracts
you
substances.
want
That's what gravity is.
do you want their
We
words?
don't.
Do you want me to post a video of them saying it?
What? Who's them?
The scientists.
Well, all the scientists in the world, then yes.
Sure, yeah, several scientists, okay? Hold on.
Several. Okay, fair. I think gravity explains at least this very basic observation that we do every day. So
Look, gravity
if
is
we don't have
all
if we
at
don't have
best,
any other, continue. Yeah, sure. Go on.
Sorry?
at best, all gravity explains is that you lifted something up and the heavier thing went through the lighter thing.
And we don't have any other explanation.
Wait, what are we
I
trying to
don't need an
explain?
extra.
How
He
the
thinks
aircraft
gravity.
matches up with the equator? You're saying the
No,
gravity. Okay, sorry.
we move past that for a moment because
Oh,
I asked him if you can't tell you're moving, how do you know you're moving?
okay. Do apologise then.
No, you're all right.
I went off to make a
So
cup of coffee. But yeah, do apologise.
yeah, if you want to continue on that, we can. I
No,
just had that simple question and it jumped off to it. So, well,
no.
gravity explains everything.
Okay. What do you mean
Gravity
by that?
explains. I mean, from the at the start of the conversation, probably some of you saw the stream as well. When DJ was talking to me, my question was not that Earth is flat or not. I was looking into what the flat Earth has to say, that how Earth works and stuff. So many of the questions that were popped at me was that then what's gravity? How does gravity work if there's no round Earth? So
Oh, we
I
don't know.
tried to explain that phenomena, why the things are falling down, and I couldn't. So that's why I came.
Yeah, same
And
phenomena.
I think
But
that's the only explanation that we have. The
within the
gravity.
explanation of things going down, the Earth is a sphere with mass. Whether that mass in the old idea is attracting the mass of the object that you dropped because that had mass, or because the mass is sitting in some kind of four-dimensional mathematical space-time fabric, like in gravitational wells, right? These are different ideas to explain the same phenomena. But within both ideas, everything's a sphere. The Earth isn't a sphere, right? So these explanations as to how things operate on a sphere are only applicable to that idea. And you can come up with all types of mathematical concepts to explain the phenomena. I've given you two. Newton's idea of mass attracting mass and Einstein's idea. If we look into it a little bit more deeper, there's about 20 different ideas of gravity, whatever that is. Right? And
We'll look
scientists
into
today
that as
still
well.
really don't know, do they?
Let me ask you a quick question, RK.
Hmm.
Could gravity work on a flat Earth?
It could, but then it wasn't allow the Earth to be flat. If it had to.
Well, if gravity can work on a flat Earth, then what's the next step that we have to do in order to determine whether the surface is curving or not?
What's your question again?
The surface, like if you have a table or a floor, your wall, the roof of
Mm-hmm.
your house, these are all surfaces, right? The seat on a bicycle,
Mm-hmm.
maybe a plumbing line where you run water through, right? These are all surfaces
Mm-hmm.
that can be measured curving or flat, right?
Right.
So how do we go about measuring the surface of the Earth if gravity, therefore, can also exist on a flat Earth?
We can't measure the curvature of the Earth, right?
Welcome to Flat Earth.
Is that what we're going at? Got it. But still
Well, I
doesn't
mean,
explain a lot of things. It does.
how tall are you?
I'm 5'10".
5'10". So the horizon, if you're standing at the edge of water, the horizon is
Well, we
roughly
have
about.
discussed that, and I already agreed that I'm defeated in that argument. I
Okay,
couldn't
all
prove
right.
that
Well,
the ship is sinking down or anything. But as I said, out of curiosity, when I was looking into it yesterday,
do, do
that's
you
what
know how
popped up, the gravity thing.
do you know how far away the horizon is from your eyes?
No, I don't. I'm sure there are calculations to find out.
Yeah, so you're 5'10", so it's roughly about 4.7 to 4.8 kilometers, which is about 3 miles.
Mm.
All right.
Mm.
So have you ever been out to a large body of water and seen things really far away?
I have.
Yeah. You know you've seen a lot further than 4.7 kilometers, right?
I'd like to believe so.
Yeah. Well, that would be impossible if the Earth was a ball. Because after 4.7 kilometers, things would start to fall behind the curvature of the Earth. Like when you say boats go over the curve, other things would also be going behind the curve based on how much further you get away from 4.7 kilometers. But yeah, we can get back to tangential speed, right?
No. Why?
No, no, why?
I think we all are dying to end this conversation. I think I should go now.
You are welcome back anytime, my friend. Any other
Yeah,
questions?
I'll
come
look
back on.
into the gravity, Newtonian, and Einstein's gravity. Then I'll probably come back here. Fine?
Yeah,
Is that fine with you guys?
no worries, dude. Like I said, welcome back anytime.
Yeah.
We're
Thanks,
ready for you.
guys. Okay, sure. Bye bye.
Catch you later, RK. It was good chatting with you, man.
What's up, DJ?
What's up, Jedi?
Good to see you, man. How's your day going?
Yeah, good. Just eating some healthy fruits and vegetables right now, actually.
Oh, okay, of course. It's still January.
Yep, still January on my health kick. Haven't had anything unhealthy since in 2026.
Good, man. Well done. I'll speak to you again in February.
I'll take that
like,
as a
I
even,
challenge.
missed
my,
that boat. I'm gonna have to wait till next year.
everybody's on some kind of health kick at the moment. My kids, my youngest is doing press ups, and he's like going to be 14 in a couple of months. Bloody hell, he's doing press ups and like sit ups every morning and shit. And he's got he's trying to keep up with the amount of steps that he has every day. My taxi driver's on some kind of fucking health kick as well. Everybody, dude. Not me though. I've seen all of this before. All right, let's have a look down this list, see if there's anybody new. Names that I don't recognize. Cafe, right at the top, right underneath the bots. We got 2 bots in the room, YouTube bots, by the way. That means we're live streaming. So welcome to our 24/7 live stream. It's on YouTube. I think it's on X and other places like Rumble, maybe. I don't know, but all over the place you'll find us. So right from the top, we've got Cafe. Got a nice PFP of a gentleman adjusting that tie there. I like that one. Who else we got? We got Ciderfiler, DJs we've just heard. Dr. Yoda's in the house. Good morning, my friend. Effie, Alaskan Malamute. Effie Batman's in the house. What's up, brother? Injelli has graced us with his presence. Mark J's in the house. That's the music bot. Not going to talk to them. Plain and Truth is in the house. We've got Quiet Noob. Good to see you, brother. Slamon. Am I pronouncing your name right? I do hope so, my friend, but welcome to our channel anyway. Someone But Who has joined us as well. Hello, my friend. Good to see you. Swole Dog is in the house. T-Dub has joined us. And that is it. I couldn't scroll any further. So welcome to the channel, everyone. If anyone's got any questions regarding the topic of the room, which is the Earth, and its overall surface description, whether it's curved upon the surface or whether it's flat upon the surface over distances. So welcome to the channel. Like I said, if you have got a point of query, comment, or question, please feel free to unmute yourself, tell us who you are, say hi, and then bring forth your point for discussion. Welcome, everybody. I hope you're all doing well today. It's far too energetic for the afternoon. Not now.
Yeah, I apologize for my background noise. I'll stay on mute as much as I can.
Yeah, it's fucking terrible.
Hey, I'm getting swole, bro.
You lift things up and put them.
I'm actually defying gravity.
What, you're shaking your fists at stuff? Like the weights? Damn you. I defy you. You mean nothing to me.
That's about the extent of it.
Yeah, I get it. So has anybody come across anything interesting recently? Whilst there's a bit of dead air and no one's really asking about the flat earth. Any new discoveries? Anything exciting? Anything at all?
Yeah, it's all speculation Sunday stuff, though, as you know, stuff
Yeah,
I've
man.
been watching. But that Jason Jack video I sent you the other day on the continental drift, yeah, I found a whole bunch more videos from him on that topic, which I've been watching. They've been awesome. About 4 or 5 different ones.
Really?
Pretty
Okay.
mind blowing stuff.
That was exactly as you said. I'd watch it for 5 minutes, it wouldn't stop. And yeah, that's pretty much the size of it, dude.
Yeah.
It's fascinating stuff, man. I mean, it's with that idea, it's just me getting the time frame right. According to that type of narrative, that's billions and like millions of years for these types of continents to drift in the way that we're told. But I guess really it could be a short space of time, some kind of cataclysmic event that moved things rather suddenly, I guess.
Yeah, he goes over his biblical theory as well, and he shows you the verses, I think from Revelation about where it literally says that's what happens. Like all of the continents that get spread really far apart and things like that. It pretty
Yeah.
much says it. Yeah, crazy stuff.
Has that got anything to do with um, pouring out his wrath, as in like vile judgments and trumpets and all of that type of stuff? When God's
It's
pouring out his judgment upon the earth, this is the destruction or the reshaping or the changing of the environment.
yeah, he's saying this. No, I don't know that much about the Bible, but this video's title is Revelation Seventh Vial Judgment interlinked with continental drift theory. I'll post it in the side chat if anyone wants to check it out.
It's a shame that you weren't around, man. I had an interesting conversation with AJ and Larry. Who else did I speak to? T Dub was around. There was somebody else. Oh, Matthew Learns. Interesting. I was basically started off by asking Matthew like a few questions about, all right, not flat Earth then, but what other things can we reach an agreement on? Like his viewpoint on Christianity and his viewpoint on the world and how it's changed, and all of those things, but not related to flat Earth. And we reached some common ground, but then we kind of started like going a little bit deeper into like the mud flood idea. I spoke about the candles again, as I always do with like the chandeliers and shit. But yeah, it was a really, really interesting conversation I had with some people. AJ had apparently been in conversations with his wife. And they're both Christian and so on, but he and his wife had started changing their Christianity also as well recently. They'd started, questioning things that they've been taught and coming across new and similar ideas to, what we'd been discussing and so on, which again, made my curiosity burn because I've noticed this with a lot of people, and AJ was just another one of those people. So that was kind of interesting as well. Matthew's slightly changed his Christianity, but not overall in a dramatic way. I need to speak to Larry again. I think he was. I think he's in maybe in a position or so on that he wasn't necessarily picking up what was putting down. It was a little bit defensive, and I love Larry, man. He's awesome. I definitely want to give him the time to have that conversation again, maybe. But the conversation overall was really, really good, dude. That's why I text you and shit. Like, I think there's a lot of people that have come into like similar conclusions and changing the way that they might have had a faith in the past to a new one, which is along the same lines that you've been looking at with your wife and so on. I found it really, really. This isn't just happening to me. This is happening to a lot of people.
Yeah, yep, I've noticed the same thing.
I was actually worried about speaking to AJ about it. Don't know why. He had similar kind of Christianity to me within a kind of dispensationalism framework. Now, for me, dispensationalism doesn't get thrown out with this type of idea with regards to like what's called Satan's little season and so. The time frames of, say, the Age of Grace is just a lot smaller. It's not 2,000 years. It's about 40, which is like a generation, depending how you define generations in the Bible. But yeah, I was really, it was really interesting talking to AJ because he'd started seeing like similar things as well. I spoke to AJ about 2.5 years ago, maybe, like a couple of private conversations about the Bible and so on. And he taught me an awful lot. He has like Bible, like home study classes and stuff. So I learned an awful lot from him. So I knew that. I believed that speaking to him, there would be some kind of pushback on it, maybe, but there wasn't at all. So that was really cool. And I was speaking to Amish about it as well, Dr. Yoda. I've had loads of conversations with him recently, speaking about, God, the words escaped me now. Orthodox Christianity, like Eastern Orthodoxy, and separation of like East and West, blah, blah, blah. He's an absolute wealth of information. So the conversation is interesting too.
Yeah, awesome. Yep. Soon we'll line up a chat about it with a bunch of people. Should be fun.
That's kind of what you were saying this the other day, is like what you want to be doing with your server.
Yeah, I'm gonna switch it to like a 2-in-1. It's flat Earth library as well as old world stuff of all kinds.
All right, Slammon's on the bus. Someone but who hasn't responded yet. Who else is in the chat that I don't recognise?
Yo, sorry, did anyone say my name?
What is your name?
Someone but who?
Hello, someone but who. All of a sudden, I was going to turn around and tell you to, like, fuck you, but that's an old meme that I keep seeing on YouTube. I didn't want to do that, but it's funny. But hello, my friend, how are you? Are you good?
I'm good, man. I'm good. How are you?
Yeah, man, really, really well. So what brings you to our channel? How can we help you? We're talking about the flat earth, or trying to, before we talk about other things that are not related.
No, I've been a flat earther for almost 10 years now.
Why?
Mainly because of the Bible. Because of my faith.
Mainly, have we spoken before?
Yeah, I think we have spoken before.
Okay, awesome stuff, dude.
Yeah, for sure, man. I love to get in here and to listen about what everyone has to say, because you guys have such physical. Because I know I read the spiritual aspect, and that's why I believe it. But you guys got all the physical answers that I, don't have. So I love to come in here and learn all that. All the measurements and just everything, all the laser tests, everything in general. All that, personally. I mean, I've never done it myself. I never, so it's pretty good knowledge.
What an honest flat earther? What?
Sorry.
I was like, oh my gosh, an honest flat earther saying I never went out and did the measurements, but I like what y'all have to say, because I understand. I get you, man. I was the same way. I was on the spiritual side for a while, and then I went and made an observation myself. So I know what you're saying, dude.
Oh, nice. Fair enough. Because, I mean, bro, to me, if God tells me it's like that, I don't even care if I can prove otherwise, because God said so. So I just, you know what I mean? It's not about people, really, to me, personally. Now, I love the whole aspect of it, to have fruitful conversations with scientific people about why I believe what I believe, because I can't just tell them, yeah, oh, yeah, it's the Bible. Even though I don't really care about talking about the topic, with people that are not interested, because usually it just gets, you know how it turns out when you tell people you believe in flat Earth and all that. So yeah,
Yeah, no, for sure, man. That was, like, and believe it or not, once I learned the Earth was flat, it literally took me back to the spiritual side of the Bible, and like I go back to Genesis 1. I'm like, wait, you mean to tell me there was light before the sun existed?
there's more than 200 verses, bro. More than 200 verses. There's even a verse in Isaiah 40 that describes how the sun circuits around the surface of the earth. To begin with, the globe model, it's us that's circling around the sun. So that verse alone destroys the whole globe.
Okay.
Just the fact that the sun rotates around the earth.
What does it mean?
That's just one verse out of 200. That's just one.
in your mind, when it describes the sun circuits, what does that mean to you?
It means above in circles.
Above and circles. Okay. Is this one
It's
circle? Is this two circles? Is it many circles?
I don't know, man. Like the only thing it says is it rotates in circles. Now, how does it do that physically with all the details? I don't know. I can only tell you what the Bible tell. Here, let me actually tell you what verse I'm talking about. I'm talking
Yeah.
about Isaiah 40:22.
Yeah.
It says here, the sun sits above the earth, and its inhabitants are like grasshoppers, and nothing is hidden from its warmth.
Cool. So I
So
get.
we know from that verse that also if you just type in Google, just type in Jewish cosmology. Only type in Jewish cosmology. Don't type in flat Earth or shape or whatever. If you just type in Jewish cosmology, you'll get the Torah, how the Jews believed the Earth was.
Yeah.
Exactly how the
It's
whole
got
biblical
Sheol in
concept
it.
of the
It's
Earth.
got some pillars underneath it. It's got. Yeah, I know what you're
Yeah,
talking about,
yeah,
dude. The reason why I brought it
yeah,
up
yeah.
is just because of that one word. That one word being circuits. Now, some people say
Hmm.
that because of this word, that then the sun circles. This is why I asked you how many circles does it do? I Is it
Oh,
one circle?
I mean,
Is does that circle change every day? Does that circle potentially change over the seasons? Because
yeah,
I can
obviously it
I
might.
can
That's
draw.
how you get the eclipse maybe and everything.
Yeah, yeah, and it's just the word circuits. I can draw on a piece of paper and design a racetrack circuit. Now, it'd be very boring if every circuit that I drew was just a circular one. I'm wondering whether the word circuit doesn't necessarily imply a circle or
Right,
just
right.
one circle. That's all.
I apologize, Jedi. I really have to excuse myself, guys. I'm working while listening in. I would love to listen in more, but I really can't really participate. If you guys don't mind me just going back on mute, unless you
Yeah,
got any
no,
other
you're
question
fine,
for
buddy.
me.
Go back to work. I do apologise, but thank you very much.
No, not at all, man. It's a pleasure anytime. I appreciate you guys for everything you do. I'm also in the other Flat Earth servers. I love all that. Anyway, appreciate you guys.
Take
I'm
care,
here.
mate.
I'm listening.
Yeah, yeah.
Good afternoon to everybody. I wasn't able to talk at the same time, but I'm free now. So, but no,
Ah,
remember when I
shalom,
just finished
slalom.
slalom, not shalom,
I'm
slalom.
just
That's
saying.
different.
I'm just saying hi. Welcome, my friend.
All
Eh?
right.
Have you finished your bus trip?
Yes, I did. Yes, I did.
Awesome stuff. And you're free to speak now. Was there anything that you wanted to say? Something that you wanted to ask, perhaps?
Not really.
No.
I already know where I live a long time ago, so I don't have doubts or questions.
Okay.
So
Where do you live, sir? May I ask?
in Portugal, next to you, not
Okay.
too far.
So you are assured of where you live, and that's Portugal. Awesome. That's good.
Yeah. Thank you. Actually, we already spoke a long time ago, but since I don't join Discord that much, so you probably don't recognize me.
Oh, I do apologise, my friend. I've spoken to potentially thousands of people now. So yeah, everybody
Yeah.
kind of blends into one. I recognised some guy earlier, but that's only because I've spoken to him within the previous week or so. But yeah, I do apologise, my
Right.
friend. But if we've spoken before, I appreciate you remembering me. So thank you.
Well, you're welcome. You're welcome.
You got anything interesting planned for the rest of your day?
Actually, I'm waiting for Miguel to not to be with him because he's far away from me, but to talk to him. But not much. Just daily basic stuff. Not much.
Well, I hope you have a pleasant day.
All right, I'm out of the gym now. But yeah, man, earlier, like, I don't know the mathematics when it comes to tangential speed and all that stuff. I understand the terminology, mathematics behind it. But it eats me up whenever somebody says, "Oh, well, it's all the same because we're all locked into the same frame." And I'm like, "Cool, let's go with that." Like, okay, so if you don't know you're moving, right? Because you're resisting motion, you don't know you're moving. So then, how do you know you're moving? That's always been confusing. Oh, well, if we make an assumption here, then we can build an entire story around using math. Great. So if the beginning of the equation is wrong, then the entire story is wrong? Yeah, essentially. What's up, Yoju? How you doing? Yoji Koi Punto?
Hi, I'm fine.
Yeah. Your pronouns are he-man?
Huh?
I was just reading your profile. So what brings you in here, man? Oh, okay. I'm guessing he was just in here to listen. Probably learning a little bit more English. Welcome to the new person. Is that Sean? Welcome, Sean. Looks like you're in intermediate, and he left. But he's part of the debate club, so I wanted to hear his debates. What's up, NP? How are you doing? Abel, how are you? Well, if you have any questions, help conversation.
Hello. Hello everyone. How I open cam? Okay. Okay. Yes, yes.
Yo, what up, gang? Midnight?
Yeah, what's up?
American patriot, gun owner, classical liberal, professional fat person. That's funny. You're a Glober.
Um, yeah, kinda. I mean, not really.
Hmm.
I'm
Seems
not a
like
hard Glover.
it seems like you need a session with one of the professionals here.
Oh, I have been here a bunch. I just usually listen.
Yeah, right. Why are you still on the Globe side?
Uh, I'm not necessarily on either side. Uh, that's why I put a question mark after that.
Mm-hmm.
I like to ask questions and just kind of learn the positions, but I think sometimes they think I'm trying to come off like I'm trying to debate, which I'm not. So,
What are your questions?
oh, I usually if just something relevant to what's going on, like trying to remember the other day we were talking about like AI or something, like
But
asking AI
what
flat
questions
Earth
do you
position.
have about the shape of the Earth?
Um, well,
I didn't think so. It's flat. No.
I don't specifically just have questions off the top of the dome, but like uh I mean I guess like one of the things I was recently inquiring about was because a lot of times when you bring up like measuring the globe or measuring the surface or whatever, you bring up laser tests a lot, and I was asking what other methods are used other than laser tests to look for curvature.
Yeah, I mean, we can brainstorm. I don't know.
Yeah, so there's all sorts of different methods. I mean, you can use radio signal propagation. You could use like infrared uh, lenses or cameras to make long distance observations. Mirror flashes. There's been a bunch of different methods that are being used.
But what is mirror flashes? That sounds interesting.
Yeah, have you ever had someone shine a mirror? Like, you know, at school you would be sitting there and someone would like be sitting in the sun and they'd have a watch on and they'd aim the little they'd try to reflect the light that comes off the watch straight into
Ooh.
your eye, and they have to get it just right to get that line of sight so that that light will blind you for a second. Right?
Mhm.
It's kind of like that. So if you get a mirror and you get someone to go on the other side of a like a say a 10-mile lake or something like that, and they're going to um aim the angle the mirror in such a way that the sunlight will reflect off the mirror and enter the camera lens on the other side of the lake. It requires a direct line of sight for that reflection to make it into the camera lens, basically. So it's a different way of testing. You know, and obviously in between point A and point B, there should be a stack of, you know, Earth curvature.
Yeah. Do we have like a reference of a experiment or direct measurement of this type of measurement?
The mirror flash?
Yeah.
Yeah, there's been some good documented mirror flash tests. I could try to find one if you want. I can put it in the side chat. Oh, there we go. Dr. Yoda has put one in the side chat there.
Nice.
13.23 miles.
Very nice.
It's actually the most economical way of testing for the curvature.
So lasers, we got mirror flash. What other ways can you measure for curvature?
Yeah,
Well,
what did you
just
say? Like,
yep. Go ahead.
oh, you said something. You said some crazy thing like radio spectroscopy or something. I don't know what the hell you said. You said something
Oh, I
crazy.
didn't say that, but yeah, people have
Oh,
used like different types of electromagnetic waves, like shooting signals across long distances, like radio waves and things like
oh,
that. Yeah, I'd have to dig up some of those tests as well. I'm not sure off the top of my head. I don't have any of those ones saved, but I have seen some over the years. Personally, my favorite is just the long distance observations, preferably using infrared,
Mm-hmm.
like over say 10 miles, 20 miles, that kind of thing, in very nice conditions where everything's nice and clear and calm. And then preferably repeating the observation during the daytime and then again at different times, maybe during the night as well, or the following day. Because quite often the Global will say, oh, there was some crazy rare conditions taking place on that day, and you guys cherry picked the perfect day, and all of a sudden you could, somehow the Earth looked flat over 20 miles that day, magically. So it's good if we can have it done on different days just to shut up that bad argument against all that bad rebuttal.
So what do you think about the mirror flash? What do you guys think about the mirror test?
I'm watching it right now. Wow. That's insane from literally ground level. What?
Yep.
That's insane.
From ground level, and the other camera being what, 3 feet, 6 feet at most.
Yeah, but
The
like
horizon should be obstructing the mirror.
60 feet is pretty high.
No, 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 no. What did I say?
Yeah, you said 6 feet, but I'm saying there should be like at least 60 feet of curvature.
I'm making a point about the horizon. The horizon itself is supposed to be obstructing that mirror. The horizon being the leading edge of a sphere. The horizon is supposed to be anywhere from this observation, off the top of my head, no more than 2 miles. That's where the horizon should be obstructing the view of that camera. That's not happening because there is no obstruction. Honestly, like this video should. I mean, this right here is it. Does the trick. Any any one of these videos, our videos, laser videos, whatever videos, like pertaining to direct line of sight. I mean, it's pretty obvious. There's no debating what's obvious. This is a pretty good video. this video? How many views does this? Not a million. Not a billion. Business. This is good content here. So somber.
Hey, what's up? Hello.
Oh, hey, what's going on, man?
Hey, what's up? Are you doing good?
Yeah, I'm doing pretty good. What's going on?
Okay. Yeah, I'm doing well. So, are we discussing something here?
Oh, well, we were just talking about the things that are being posted in the chat. We watched a mirror flash observation.
Oh, yeah, I see there is a screenshot, I guess.
Well, the screenshot is something else. It appears to be uh, seeing a shoreline from 21 miles away.
Oh, yeah, I see. It's flat. Yeah.
Yeah, that's kind of what we've been talking about. Anybody know why Chris is muted?
I mean, yeah, I guess. Yeah, I don't know. I mean, I think he don't wanna talk right now. So yeah, he's saying, can anyone unmute me? Oh yeah. Okay, yeah. So he got muted. Yeah, I guess he was speaking Hindi in the chat. Yeah, he mistakes. He mistakes. He made mistakes. Yeah. He was speaking another language. Yep, not English.
Mm,
Is there anyone can unmute him?
mm. I don't know where the mods are.
Uh, so Great Salt Lake and leisure test. Okay. So yeah, according to this observation, we think that this Earth is flat. Am I right?
Karen Lee Fingerman, candidate in art.
Despite a lifetime of the very best education, students in our classrooms are failing to learn science. Many of these students will graduate from college with the same scientific misconceptions that they had on entering grade school. To test how a lifetime of education affects our understanding of science, we asked these recent graduates some simple questions in astronomy. Consider, for example, that the causes of the seasons is a topic taught in every standard curriculum.
Okay, I think the seasons happen because as the Earth travels around the sun, it gets nearer to the sun, which produces warmer weather, and gets farther away, which produces colder weather, and hence the seasons.
How hot it is or how cold it is at any given time of the year has to do with the closeness of the Earth to the sun during the seasonal periods.
The Earth goes around the sun, and it gets hotter when we get closer to the sun, and it gets colder when we get further away from the sun.
These graduates, like many of us, think of the Earth's orbit as a highly exaggerated ellipse. Even though the Earth's orbit is very nearly circular, with distance producing virtually no effect on the seasons, we carry with us the strong, incorrect belief that changing distance is responsible for the seasons.
The U.S. Global Positioning System, GPS, as well as similar systems from other countries, are collectively known as Global Navigation Satellite Systems, or GNSS. These systems make it possible for us to determine locations extremely accurately. When determining positions with geodetic quality GNSS equipment, you can reduce errors and obtain high-quality data by following best practices. Even small problems in setup and data collection can have big impacts on results. This is equally true for both static and real-time data collection. GNSS equipment works best when it receives unobstructed signals from the satellites. Obstructions such as trees and buildings will impact signal propagation. Signals can also bounce off of surfaces such as billboards, chain link fences, automobiles, and buildings en route to the receiver. This effect, known as multipath, can reduce accuracy. As much as possible, GNSS receivers should be set up with clear access to the open sky and out of the range of potential multipath interference. Satellite geometry, the spatial arrangement of the visible satellites, is important. Several well-spaced satellites covering the entire sky is preferable to satellites grouped together. Often, simply waiting for the satellite constellation, and therefore the geometry, to change will improve positioning accuracy. The position dilution of precision, PDOP, is an indicator of the level of precision achievable for a specific time and location, based on the satellite geometry. The lower your PDOP, the better your results. Your planning software provides information on the PDOP and the best times to collect data. Electrical and solar storms can compromise your data as well. Check with NOAA's Space Weather Prediction Center for geomagnetic storm warnings, alerts, and watches. When collecting data, carefully set up your tripod over your point to minimize centering errors. The antenna should be level, and it must remain stable. To ensure your antenna is level, the bubble should be in the center of the circular level vial. As part of your routine maintenance, make sure your circular level vial is in adjustment. On most fixed-height poles, you can check your adjustment by turning the level vial 180 degrees and verifying that the bubble stays in the center. It is important to know the height of the antenna's reference point, or ARP, above the point you are observing. The ARP is usually the bottom of the antenna body, not including adapters. This is called the true vertical antenna height, and any error in this measurement directly affects your final point elevation. When using a standard tripod, you may need to measure the antenna height from the mark to the edge of the antenna. This measurement, called a slant height, can be a source of error. Slant heights must be corrected to a true vertical antenna height. Some vendor software may do this for you, but confirm this to be sure. Using a fixed-height tripod or range pole can reduce or eliminate height measurement errors by removing the need to physically measure the antenna height. However, the tripod tip should be inspected periodically, and it should be replaced if it is worn or damaged. For optimal accuracy, most antenna manufacturers recommend orienting a specific point on the antenna to the north. Finally, another common error source can occur if an incorrect antenna model is selected when post-processing the data. Choosing the wrong model may result in incorrect electronic phase center variations and offsets. This could introduce a significant error in the height, directly translating to your point elevation. Both the vendor of your equipment and NOAA's National Geodetic Survey website can provide more information about antenna phase center offsets, as well as the antenna reference point and north orientation feature. In general, the longer you observe, the better your accuracy will be. With a longer session, you'll have a better probability of fixing ambiguities and canceling some of the errors in GNSS. The longer the session duration, the lower the root mean square deviation, or RMSD. In other words, the higher the degree of horizontal and vertical accuracy achieved. While it won't directly reduce your error sources, a second independent observation is a helpful way to check your results. Remember, even when doing real-time positioning, you can always verify the accuracy of your equipment and procedures by collecting data on a geodetic control mark. Post-processing tools, such as NOAA's Online Positioning User Service, known as OPUS, will solve for a position. However, these tools will not detect important external errors, such as entering a poor antenna height or selecting the wrong antenna model for processing. Following these simple techniques will allow you to get the most out of your GNSS equipment and position you for success.
Well, our Foucault pendulum has stopped swinging. So, Houston, do we have a problem? Has the Earth suddenly stopped rotating, sending us here in Houston, Texas at about 30 degrees latitude, hurtling towards Florida at about 900 miles per hour? Wait, which way's east? At the equator, it would be about 1,040 miles per hour because rotational physics is fun. So no, our very, very spherical Earth has not stopped rotating, as evidenced by our aliveness. So here's what's going on with our Foucault pendulum and a very trimmed down version of how these pendulums work and why they are important. Since perpetual motion isn't a thing, despite what your IG feed might tell you, every pendulum on Earth needs a little nudge to counteract mechanical friction and air resistance. This nudge, for our pendulum at least, is actually a slight electromagnetic tug on a metal collar at the top of the 61-foot, 7-inch cable itself. The electromagnet is actually a circular ring, triggered at the ends of the 7-ish second total swing, or period, technically. Since it's a ring magnet, it only tugs in the same direction the cable arrives. It does not alter the direction or inertia at all. This mechanism simply maintains the momentum of the 180-pound mass against friction and wind resistance. It's very slight, but it's there. And well, in our case, this mechanism has stopped. Because like all mechanical things, it needs maintenance from time to time, especially after literal decades of virtually non-stop operation. A well-deserved spa day after nearly 50 years of work. Many of us have lifelong memories of it swinging, so it's kind of poignant, if not actually a little bit fascinating, to see it stationary. But I assure you, it will definitely swing again. I mean, right now it's kind of like Hakeem Olajuwon just sitting at half court. Ask your parents about Hakeem Olajuwon. So why are pendulums important? In summary, because when you see the swing change direction throughout the day, evidenced by the pegs being knocked over in a circular perimeter, the pendulum is actually not changing direction. We are. The swing direction does not change. It is the Earth rotating underneath the pendulum. And we are on the Earth, so from our perspective, it looks like it's changing direction. But it isn't. Now I'm gonna knock the rust off of my high school French, which came in very useful in South Texas, by the way. Hi, Miss Lugier. You were wonderful. This experiment, invented by Jean-Bernard Léon Foucault, did I do all right? Any native French speakers want to let me know in the comments? I probably butchered it. It was used to demonstrate way before space travel that our blue sphere was in fact rotating around a wobbling axis. Sphere, ball, globe. Let her rip in the comments. Check the related video, description, or pinned comment for that matter for a much more in-depth video explaining the Foucault pendulum. But with that, y'all are awesome. Take care. Almost ripped my jacket.
You guys catch all that double speak? So the Foucault pendulum alone can't detect anything. That's set in motion, driven electromagnetically. And then he said, well, the magnetic drive motor for the Foucault pendulum, it really doesn't alter the inertia, but it alters the momentum. Don't worry, it's totally not moving the pendulum, but it is. And don't worry that it stopped, because we know that Earth actually moves without it, because we would all be dead if it weren't moving.
And what about all those Foucault pendulums that don't work properly?
Yeah, right?
Didn't they take one in to the South Pole and it spun the wrong way?
Yeah, and that reminds me, that link is floating around somewhere out there in the wild. We need to find it and send it to the web archive and screen capture. I know I did it once upon a time ago. I can't find it though. And I think it wasn't not even just like once. Like they set it up a second time and they still couldn't get it to work. And then they got it working like the third time. And the funny thing is, I think you would experience the most motion at nearest the poles, which means you should probably be messing with it the least. You know, and it wasn't just that they were messing with it and couldn't work. It got it initially working backwards and declared victory. Like, how do you do that? How do you say, hey, we got it going great the first time? First time, it's perfect. Oh wait, shit. It's going backwards. But at least it was going perfectly, just backwards. This whole obsession with pendulums goes back hundreds of years. Like, it wasn't just Foucault and a pendulum. They were using pendulums prior to this guy for divination, for trying to detect the strength of gravity, not even joking.
Yep, but they completely ignore the Tamarack Mines experiment.
That's a funny thing. Like they would take these pendulums and plumb lines, and they come up with all these excuses like, you know, Earth's gravity field is different in places, and that's why we couldn't get perfectly plumb and level. And then they say, oh, it must be due to mountains. And then they go to the Himalayan mountains, and it deflects in the exact opposite direction than they predicted, according to them. So how do you get plumb lines? Like you can't get up consistent plumb lines anywhere on a globe. But even then, like we could completely absorb the plumb line deflections and curving plumb lines. We can completely absorb that because you know what they do? They take that information and then they wrap that around a ball. That's basically what gravimeters are in gravimetry. Swinging pendulums. They got their pendulums, they got their dowsing rods. They're ready to do geological surveys, guys. Someone pack a Ouija board. Got your
Maybe
tarot cards.
Magic 8 Ball.
Yep. Let's go. Let's do some geodesy. We're going to stare at the stars, do a little astrology. We'll get our plumb lines from the stars. We're going to swing these pendulums and we're going to ask the magic 8 ball if Earth is flat. That's what globe surveyors do, man. It's crazy.
Yeah, what's up? Yeah, thank you, man, for unmuting me. Yeah, actually, my English was bad, and I was speaking my language. So yeah, thank you, thank you a lot. It's like, hey guys, let's measure some spherical excess today. Unlike all the other days, today we're actually not going to use any terrestrial refraction. We're just going to pretend that after all this time that it doesn't exist because we're trying to measure spherical excess. All right, guys, get your theodolites out. You see your bubble level? We're going to pretend that that's perfectly level out to about 69 miles.
Okay, and we normally would do a geodetic gravimetric correction here too, but like all the other days we've done it. But today we're not going to do that either because we're trying to measure spherical excess. All right, so let's throw out some refraction. We're not using that. We're not using gravity field corrections, and we're going to pretend that that our bubble level's out to 69 miles. So we got perfectly plumb to horizontal that distance. All right. So now we're ready to measure curvature. And oh wait, shit, we can't do it. All right, well let's do like 300 readings and keep only the best ones. By my calculations, we need to be dipped down at about half a degree. So let's keep all the ones that show about a half a degree dip, guys. All right, there, we just measured spherical excess. Like, you think I'm joking? That's exactly what they do.
Yeah, they probably measure to a standard rather than to an accuracy.
Yeah, it's how they know which of their observations they need to throw out. And then they keep all the others and they do a root mean square. They do an average of what remains. And oh, holy shit, it confirms their bias. Guys, we just affirmed the consequent. That means we proved Earth is a ball. Now let's add back in refraction and curving plumb lines and deflecting verticals, and guess what happens? It's flat.
Yeah, I have to wonder how they're calculating their latitudes during the daytime with those solar filters that they didn't have in the 19th century.
Oh yeah, doing sun observations that way. Yeah.
You stick a stick in the ground and measure that.
Yeah, like Eratosthenes. We have to assume parallel rays, guys, but don't worry. As long as we assume parallel rays, we don't have to measure that the Earth is actually curving. It's funny because the parallel rays assumption basically takes care of that. Once that is out, yeah, then they just rule out a flat Earth.
चल चल पूछो। घुस गया ना मैं।
और किस फ्लैट हुआ गुरुदूत में?
मारा मुझे। मैंने क्या किया? Is everyone here AFK? Hello? Is anyone listening?
Oh, he didn't last long. Took me a second. It's funny how they come in, they say like 2 words and they wait 1 second and they leave. Like TikTok brain.
Oh yeah, man, that TikTok brain's a real thing, isn't it? Like, I can hear them getting frustrated if they ask me a question and then it requires a decently long answer. After 2 or 3 sentences, I can hear them starting to get frustrated quite often.
Right, you can hear that frustration build because the next thing out of their mouth is a non sequitur, which they've been politely holding on to for 3 seconds.
You want to give a quick introduction to your song? Yoda?
So,
Yeah. Your new song. I was going to play your new song. It's awesome.
I am Yoder. I'm a flat earther.
And what's the song about? Like, what's the? I mean, it's kind of obvious by the title, but give us a
Yeah,
bit of info about it.
I got you. It's a real introspective look at an existential crisis that occurs when you've confused the map for the territory your entire life. That the world that you built up inside your brain that you thought was so true actually turns out to be different than you imagined. And now you need to cope. You either need to cope or descend into madness, I guess. Yeah, so the song basically takes you through that journey.
I built a kingdom made of ink to quiet down the noise so I didn't have to think. I drew a line to stop the tide. I built a wall to stay inside. Every mountain was just a shape. Every exit was just an escape. I thought I held the world in a frame, but the wild wind doesn't know my name. The colors bleed, the edges fray, the perfect picture falls away. Tear the paper, touch the stone. We walk a world we cannot own. The map is not the land we see. It's just a cage for you and me. So let it break and let it rain. Let the wild world break the chain. Yeah, the map is not the land. It's just dust inside my hands. Paper show. I found a river where the road ran out. The compass spins, the needle lies. There's a fire here that never dies. We chase the truth in black and white, but lose the colors in the night. The grid is gone, the ground is deep. I'm waking up from a paper sleep. The colors bleed, the edges fray. The perfect picture falls away. Tear the paper, touch the stone. We walk a world.
Well, looks like someone deafened it. Maybe the bot reached its limit usage.
Yeah, I noticed the Musox, it does that like most of the time. It'll cut a song off like way before the end, nearly every time. That's why I was wondering if the Hade bot, like we got the Hade bot in here, it doesn't do that. But I don't know what the commands are for the Hade bot in this server.
Yeah. Yeah, me neither. Yeah, Musox does do that. Like it does it to songs, but you could play like a long form podcast for 2 hours and it's fine.
Yeah, yeah. I've seen you use the Hade bot. You don't remember what the symbol was you put it at the start? Because I know what the commands are, I just don't know what the activation symbol is.
It might be /play, and then you have to select the purple one. And then when you do, it'll automatically put up the word query : and then I think you put in the web link. I think that's it.
Hello.
Hi, welcome to the Flat Earth channel. And he's gone.
Hello. Why is no one
Flat
talking?
Earth chat. Sorry, what? We're waiting for you, Chief. Welcome.
Hello. Yeah, but I wanted to listen to someone debate. I don't want to
Okay.
debate.
Okay, well, there isn't much of a debate. I mean, how can you possibly
How,
debate this, right? I mean, you see a flat Earth, I see a flat Earth.
how come when you're at the North Pole you see the stars going in one direction, but at the South Pole you see the stars going in the opposite direction?
Well, maybe you're looking in opposite directions.
It's almost as if he ignored what you said completely. We're talking about the Earth and the nature of the surface, not what's going on in the sky. The Earth itself is apparently flat, obviously flat, like you observe it that way, you experience that way. So, and if we measure it that way as well, then there is no debate.
And
Would
he's
you
looking in
agree?
the wrong direction, like you said. How funny.
I mean, shouldn't the stars go the same direction, no matter where you aim?
Well, why would they go a different direction? The sky has nothing to do with the ground. Not unless you bake in a bunch of assumptions at the beginning and then don't talk about them. Like in this case, do you think that the Earth is turning or are the stars moving? When you observe the stars moving, even you described it, they are moving in a direction. So the stars move, the Earth is stationary. Would you agree?
Hold on, I have something to do.
Right, so how can the stars be doing that if Earth isn't a globe? Right, so how could Earth be a globe when we measure it flat?
He's on deafen.
Ah, okay.
So if I'm standing on the equator looking up at nighttime, and the moon is at my zenith. What's the orientation of the moon? Yeah, I ask that question all the time to the Globers who keep pushing out that narrative that the moon looks different in the north and the south. No, it's entirely observer dependent. Because if I point myself looking north, I see it exactly the same way as the Australians do.
there is so much people. Flat Earth Discord.
Yeah, but we're all
When
waiting on you.
what?
I said, yeah, there's a lot of us, but we were all waiting on you.
I'm here.
All right, let's get it started.
Started.
Yeah. We were hoping somebody would show
Well,
up and prove to us how they know they live on a globe.
uh-huh. Okay, I
Yeah.
actually trying to improve my English skills, so I will try to explain you, for example, why we are living in globe in the sphere,
Okay.
not on the flat one. Yeah.
Oh,
So
okay.
from I'm not really geometrical scientist, but there is several physical rules that we live in, and for example, when you uh, when you like pushing from the gun something, I don't know, bullet from the gun, the bullet goes down to earth, and it magnets it. Like you can't do that on the flat earth, because on the flat earth there would not be gravitation, like, and I think that's one reason. And the easiest way to find out if we live in the spherical earth is just to go higher and see from the space, and all of that was done by people that have sources for that. Are
Okay.
you really okay? Okay.
Okay. So we'll keep it simple. We'll go slow because you're learning English. You're doing fine, by the way. But so yes, there is no force of gravity or bending or warping of space-time gravity in reality. That's correct. All we have observations of is that depending on the medium, the more dense object will go downward, and the less dense object will go upward, depending on the medium that it's in. That already exists. That's called Archimedes' principle, or specific gravity. That is what we have. And the second thing is, uh, you know, borrowing or referencing someone's claim that they went to a place called outer space, or that they've been far enough away from the surface that the Earth curvature can be seen, is easily debunkable, because when we measure the surface of the Earth itself, it measures flat. There is no curvature to be found. So whatever claims are made or whatever imagery is shown, ipso facto must be fraudulent if the Earth is measured to be flat.
You're right that we have 2D images, but if you go like on the mountain, for example, on Everest, you can see as far as your as lines, like as vectors of your view scope allow you to, that you can't see that far that you have reached, for example, New York. That will be possible in a flat Earth, but on the spherical Earth there is no such opportunity to see New York from Everest. So I think it's also one of proof.
Okay, so when you think about the flat Earth, do you think that there's no air on the Earth as well? Do you think there's no air? no
There
no
is air.
atmosphere.
There is air, but you can see
Okay.
stars. Stars.
So do you? Yeah,
So
I understand. Right. Let's stay with you're looking horizontally across the surface of the Earth. Well, there's going to be a problem because if you're looking in a horizontal direction, the air itself is not completely transparent. In fact, it's opaque. So much so that your limiting factor for how far that you can see across the surface of the Earth is dependent on the air itself. The air will only allow someone to see roughly 250 to 300 miles in any direction. That is what the air will allow. Now, if we factor in the pollen, the dust, the pollution, the humidity, all the other factors, the weather, you're not going to be seeing very far at all. In fact, most viewing limits on the surface of the Earth right now are somewhere in the ballpark of between 10 and 15 miles on a good day for most people. But there are days where it can be clearer and you can see maybe 30 miles. That's about what we get when we look across the surface. There are some anomalies out there, but nobody, as far as I'm concerned, as far as the flat Earth is concerned, is claiming that you can see forever. No one's ever claimed that. The only way that that would be possible is if there were no air on the Earth. So no one's claiming there's no air. That's going to be a problem.
well, your point is that you can see New York through air because of it's cloud-like. It's not
Yep.
fully transparent.
Not fully transparent. No.
Yeah.
It's called
Well,
the
but you can
attenuation of
see,
light, right?
but you
So
can
light will
see
attenuate depending on the medium, right? So if you were to go into the ocean, well, you don't have to go very far down. I don't know, 100 meters, and it gets pretty dark pretty quick. So depending on the medium, light will not penetrate that medium. Now, water is much more dense than air, but air also has a limit to how much it will allow light to pass through it. So the reason we can't see New York from Mount Everest is not just only the air, but the angular size of New York from Mount Everest, right? So the angular size of New York would be much too small to see across that distance.
Yeah, I see what you talking about, but well, why do you think governments not telling us truth? Why are they lying for us?
Oh, I didn't say that anybody was lying. Do you think that they're lying to us about the shape of the Earth?
I just can prove you that Earth is spherical sphere.
Right.
So
It ends up being very difficult to prove that the Earth is a sphere. In fact, when you measure the surface of the Earth, it is measured to be flat. So proving that it's flat is easy. Proving that it's a ball is at this point impossible. So if you're going to conclude that someone is lying to you, well, that's the conclusion that you've come to. I just know that the Earth is measured to be flat. I can't say whether or not someone has lied to me. I'd have to know who it was to ask them and see if what they were saying was false. So, if a government agency like NASA, for instance, who recently has finally been declared what they've always been, is an espionage or spy agency, as decreed or ordered by the President of the United States, and they were telling us that the Earth was a globe, although it isn't, then I suppose that particular agency is responsible for putting out bad information or disinformation. But any one individual, I can't determine whether or not they're lying. The agency itself is putting out disinformation. Why? I don't know.
so are you are you thinking about everything like that? If you didn't prove that for yourself by yourself, you don't believe it, or You have some abstractions you believe in.
I mean, there are certain things in life that I will just never know firsthand, right? Everybody has this problem. So there are things that we trust other individuals for, or we trust information that we receive from other people because it is impossible for us to verify. So we do trust and we do believe. That's part of how we live with one another on the earth. But certain things that we can test, like the measurements of the earth, things that we do or are able to verify or confirm that we can measure, we go ahead and do that. So we've done that. We've measured the earth. We've used lasers. We've used theodolites, surveying equipment. We've used navigation tools like sextants. We've even looked at the data from all of the surveying companies or organizations. Looked at data from things like black boxes on commercial aircraft. All of these data points, all of these sources of information affirm that the Earth is horizontally orientated and measured to be flat. So all of the things that we do in practical everyday life affirms that the Earth is indeed flat and stationary or motionless and contained. These are the things that we can verify. We have firsthand knowledge about that. Everybody does.
Yeah. Well, I think you can also. Do you have some people that actually believe in flat Earth? You can't prove that it's flat because you can't not prove that it's spherical. So you just don't know if it's flat or it's spherical.
Well, see, that would be that's a fallacy. That's called an appeal to ignorance because you don't believe we ultimately can't know one way or the other, or we can't prove the non-existence of something. That's fallacious. So if someone's going to claim the positive claim that the Earth is flat, all they would have to do is measure the surface and see that it is flat, that everything is a deviation from a parallel plane from horizontal. And then once again, you can affirm it through measuring it. Me not being able to ultimately, I don't know how you put it, you can't disprove that the Earth is a globe. No, I can. I can measure the surface and show that it's flat. So the globe is only a concept, mathematical concept with no basis in reality. No one has ever measured any curve. No one has ever seen any curve. It's all just been assumed based on, various optical effects. And then it's been conceptualized or modeled as an idea, and people choose to believe that idea kind of like a religion. But in reality, the Earth is flat, measurably so.
That in geography, historical events, like
what about
for example, Columbus, not Columbus, but there was historical event that showed that it's possible to go through from Europe to India and have the trade pass to just go around the globe. So if we will go theoretically in all possible directions on globe on the Earth, okay, and we will finally in some point of time reach our first destination, like our initial destination. We will prove that that Earth is a globe.
Well, not really, because if you were to go in a straight line, at no point if you go in a straight line can you ever end up back where you started, as far as I know, unless there's some kind of portal that you enter, and then there's some kind of metaphysical process where you're transported or beamed back to your original spot. but I don't think we have anything like that. In reality, circumnavigation, meaning if you go east in perpendicular angular relationship to north, go in a circle, circles are perfectly fine on a flat surface. You can do circumnavigation on a flat earth, no problem. You can end up where you started. But if you want to go straight, you will never end up where you started. In fact, you actually cannot go in a straight line on a globe because what I call the z-axis is always going to have that line curve. So there are no straight lines between points on a globe, and you never end up where you started in that scenario.
If there was no z-axis, then you won't have z-axis on the mountains. So I think there is same concept applicable in that position. Like we can actually go straight, but on that axis we will go just straight in the x-axis and doesn't care about that axis. If we take a flat Earth and we don't have that axis, we will just fall from that flat. If it's not endable, like it's infinite in all axes, then actually we will have all possible places, but we have limited amount of places. We have only one mountain, and that is the highest, and we have only one Burj Khalifa, like, and other stuff. And there is limit to Earth. You can people have built internet around the globe, like, so you can't actually tell that you can't go straight. You can go
That's not
straight.
true.
What's not true? Like you can
They
actually.
built internet around the globe. That's not true.
Why people not falling from the flat Earth?
Bro, you're going to have to stick to one thing, and we'll just talk about each point individually. Number one, nobody here claimed that the limit of the Earth is something that you can fall off of. That sounds like your idea. Do you have an idea or a concept of the flat Earth that you are using to argue with us? That's called a straw man fallacy. You can't create something that you believe the Earth is and then tear that down or argue against that when that is not our position. Nobody here claimed that you're going to be falling off any edges.
I agree with that, but in that case, how the end of the flat Earth would look like, in your
I don't
opinion?
know. I have no idea. That has nothing to do with the
I've been
argument.
there.
The argument is about that the surface of the Earth is flat. The limit of the Earth, no one is making a claim to. So if the Earth itself, the surface of the Earth, measures flat, then all of the other things that you have a problem with are going to be ultimately your problem, because there is no curvature of the Earth that is consistent with the radius of 3,959 miles, which is what we're told the Earth has, a radius of 3,959. That does not exist. That cannot be measured. Only flatness is measured.
I have seen what he's talking about in a cartoon called Mad Jack Pirate. I posted in the side chat. Someone falling off the edge of the earth.
Right. So that's a cartoon, and that's propaganda, essentially. But none of us here are claiming that idea. We're just talking about the surface of the Earth and how it measures. And it measures to be flat, horizontal, level. And all of the topology, the mountains, the hills, the valleys, the ocean trenches, all of those contours are measured against the horizontal plane, which is perpendicular to the parallel with the horizon. Those are all measured according to a flat Earth that is already established by the ocean level itself. The water, as we all know, is always horizontal and level upon its surface. So if 70% allegedly of the Earth's surface is water, and it is flat and level on its surface, that would be 70% of the Earth's surface being flat, level, and horizontal, as we all experience. And so there is no way that the Earth could be a sphere.
Check the second video, guys.
I'm sorry?
I was just saying for people to check the video I posted.
What is it?
Really fun. It's from this cartoon.
Oh. So anyway, that's the only thing that we're really discussing is how does the Earth measure? Well, it measures flat, and everybody treats it and measures it that way every day of their life, 24/7, 365 days out of the year. And no Earth curve measurements have ever been taken. So that's kind of the end of the story.
Do you believe that Earth's not flat if you go in the space by yourself on the rocket ship, go around the Earth and see what's real?
Rocket ship to space? What is space?
Space is, from my perspective, it's space where you have no air, you have vacuum. It's a place for stars and pieces of materials in the universe.
Okay. So this place called space that you believe in, you say it's a vacuum. If it's a vacuum, why is the air on the surface of the Earth not filling the available volume, which is this ever expanding vacuum?
Because of magnetism.
No, magnetism does not hold the gas to the surface of the Earth or the air. There's no experiment that verifies that. That's just a claim. You would have to prove that a magnet or a magnetic field of some kind is holding the gas to the Earth.
Gravitation, then?
A gravitation, what is that?
It's a gravity, like it's a force that forces objects to fall to Earth's ground.
Okay. Okay. So there's your claim. How would you prove that to me? What is this force? You call it gravity and you say it does things. Now, how would we prove that?
You just have to put something in the air and in the surface of Earth, and it will fall to the Earth's bottom, like it on the flat.
So if I grab a helium balloon or a hot air balloon and I let them go, they're going to fall straight to the ground?
Actually, because of their in their own force that is not about the gravity, because the weight of balloon, if it will be enough, if it will have more weight than the power of molecules that not that combined with each other in the balloon go in the air, then balloon with this gas will fall to the earth if it will be weighted enough.
Right, but you told me that if I let go of anything, it will go to the ground. How come the gas itself, the air that we breathe, how come it is not going straight to the ground? In fact, the air that we breathe is moving freely and randomly in all directions, all vectors. So it is not going straight to the ground either. So the gas, the helium balloon, the hot air balloon, all these things are going up. Only the things that are more dense than the gas are going down. So is it more likely that there is a relationship between the density of the object and the medium than there is about this idea of gravity, because gravity, there is no scientific experiment verifying or validating that this thing called gravity, this force that you've appealed to, even exists.
Well, he told us that you drop something. That's how you know that that force is there. But that's circular reasoning because it goes like this. How do we know gravity exists? Because things fall. How do we know what makes things fall? Well, because of gravity. That's circular reasoning.
Exactly. So we can't use circular reasoning with gravity. We actually would have to have some kind of experiment using deductive reasoning to prove that whatever gravity in your mind might be is the cause of an effect. So we would have to pick out a very specific effect that we see in nature and then see if gravity is the cause using an experiment. Now, I have been asking for a while if somebody could show me what gravity looks like, what kind of force it is, if it has a smell to it, if it has a weight to it, it is something that we can hold, that's making this force, or if it's just a concept about a force because we see something occur and we attribute the concept to the thing that we see.
Okay, but if you take an apple and you throw it, why doesn't it just keep flying?
Why would it keep flying?
Why not?
What do you mean? I'm asking you.
When you throw it in the air, why doesn't it just go in the air forever?
Why would it?
Well, I'm asking you because you say gravity doesn't exist. Why does it fall down? What
No,
makes
I'm
it fall
asking you, why would it do that? Is the
down? I
apple
asked you
more
first.
dense than the air? Right. Is the apple more dense than the air?
I don't know.
You don't know? You can't even decide whether or not an apple is more dense than gas? This is how I know that you're not here in good faith, because you won't answer a simple question that you already know the answer to.
No, that doesn't make sense.
It does make sense. Is an apple more
Hold on, my
dense
son, I'll
than
be right.
air? Is an apple more dense than air?
Yeah.
Yes, it is. So the object being more dense than the medium that it's in, this being air, will have a downward vector. An object that is less dense than the air will have an upward vector.
What if I was underwater and I decided to throw the apple? Then what?
It seems our friend is all of a sudden choosing not to answer. Strange.
Well, I saw some video about experiments that actually historically proved that some, I don't know the name of this scientist, but he was on the sale, and I don't know if you heard that he he dropped a ball, or I don't know, he dropped from the machta, like the tree that's on the center of the ship. It falls and somehow they proved that that Earth is spinning, but I don't know if they had the force to move forward. Like they had, I don't know how to tell it. They had some speed, and they had another. In physics, it's a, and yeah, and maybe for this reason, the apple should also be, or objects should also be transferred with the ship together and fall from in the right under the point of dropping this item. But I don't actually remember this, so I can't argue using this argument.
Yeah, you may want to get more details about that. And I appreciate that you are still learning English, but most of what you were describing, I couldn't really figure out what you were claiming. So perhaps do more research on that and then get back with us.
Okay.
Yeah. But with every, and even Einstein said this, that there is no optical experiment that we can perform that will verify or even prove at all that the Earth is moving. As far as anybody can tell and anybody can measure, the Earth is completely motionless, with the exception of when you are in an earthquake and the ground accelerates from one direction to another. You can definitely experience the motion of the ground. Otherwise, everything is being measured according to a stationary Earth. Even the speed of your car is in relation to a stationary Earth. So there is no motion as far as we can detect or that we can measure.
Not true.
Okay, great. Do you
That's
have an
true.
experiment that you can verify that the Earth is in motion? Yeah, Foucault's pendulum is an affirming the consequent fallacy. It's not an
Right.
experiment either.
Any experiment that proves what you set out to either prove or disprove is affirming the consequence, according to you guys.
Well, no, I'll just
No,
give you the
that's pretty
form, right? I'll give you the form, right? So this is affirming the consequent. If the Earth is spinning, then a pendulum hung from apparently the same reference frame as the thing that we say is spinning will deviate or precess 15 degrees per hour. Oh, it deviates 15 degrees per hour, therefore the Earth is moving. So it's an affirming the consequent fallacy. You were ripped off, you just didn't notice it. I don't know why you're talking when I'm talking. That seems rude.
Yeah, fair enough. I should just shut up till you finish. But it deviates differently depending on where you are on the globe. How does that work on a flat Earth? If we could just divert
Sorry,
from the sun.
what globe are you talking about?
What do you mean?
What globe are you talking about? Do you think that the Earth is a globe?
Yeah, you're begging the question now, right?
I don't think the Earth's a globe.
Okay, good. So why would you be, referring to a globe when you don't believe it is? What globe are you talking about?
Sure. So, how does Foucault's pendulum? How can you calculate your latitude using Foucault's pendulum on a flat Earth?
Calculate your latitude using Foucault's pendulum? No one's claiming to do that here. Do you know how to do that? Okay, tell me how you do it.
Look, how fast it rotates, because if you're at the North Pole, it will do.
Sorry, friend, I'm asking you to go ahead and prove the claim that you just made. If you can calculate your latitude using Foucault's pendulum, how do you do that? I asked you a question, you didn't answer it.
Are you not aware of this?
That's why I'm asking you to show me how it's done.
Sure, give me a sec.
Okay.
Google it. I'd like to see the data when he comes back with it. I want to see all the trials and errors that went into producing the data too.
Yeah, that'd be great. I've actually never heard this one. Anybody else?
What they end up doing is they have to.
You're roboting tactical. We can't hear you.
There you go, in the chat.
Problem is, they're extremely inconsistent, and most of the time they don't work properly, if at all. And then
That's if you're not
they
using an adequate pendulum.
well, these are like the highest quality ones. I mean, in museums and things like this, or this is groups of physicists that, for example, went to the South Pole, right, and set up a giant one. And then after a while, they thought it was working, but after a while they realized it was actually going the wrong direction, and then they tried setting it up again, and then it processed twice as fast as what it should, until eventually they kept tweaking it until it did what they wanted it to do. And they're like, "Oh, it's working now." And then we've got a video from Mitchell from Australia, who's a flat earther. He went to the one in Sydney that's supposed to process at a certain rate. Okay, and he sat there watching it for 4 hours, and the pendulum just kept swinging back and forth. It didn't actually process at all over the 4-hour period. These are big, giant devices, like professionally built devices. And
Sure.
what we asked
Can you give me
the globe earthers to do, yeah, I can give. Do you want the video of that one, or?
Yeah, if you could send no, the first one you were talking about where they went to the South Pole and they couldn't get it to work and stuff.
Yeah,
I'd
it's
genuinely
not a
like
video,
to
but
see
there's
that.
like yeah, it's very well known.
Or
It's very famous
papers.
expedition, but yeah, I'll find you the
Yeah, I've never
papers on
heard
that
of it.
one.
About it, I can post it, and I'd like to read a portion of it for the audience.
Thank you.
Okay, this is from southpolestation.com. It says, our first attempt with the pendulum showed the Earth spinning backward from what was expected. We didn't notice this at first because we're all from the northern hemisphere and are accustomed to Earth spinning in an anti-clockwise direction. We then realized that from our frame of reference, the Earth should be spinning clockwise, so we had to modify the pendulum. The opening picture shows the three of us kneeling next to the pendulum with the weight hanging in a vertical configuration. The air resistance against this weight caused the pendulum itself to rotate. This gave us spurious results for our first attempt. Later, we fashioned the weight so that it was hanging horizontally to the plane of the floor, and we got results consistent with what was expected. Our second attempt showed the Earth rotating in the proper direction, but in an angular velocity twice what is expected. We suspected some kind of government conspiracy, but decided to make a further modification and try it again. They were joking there. Our last attempt showed that the Earth spins on its axis once every 24 hours, as expected. So you see, this is the problem with the Foucault pendulum. It is so fraught with error, user error, environmental variables. Nobody can produce consistent results. And I have yet to see a single meta study that has shown that. What happens is people fuss with it until it gets the results that they would expect as if they lived on what they thought is a spinning ball. And then they consider the
Shouldn't need to
confirmation
modify.
bias as proof that they live on a spinning ball.
Exactly. They shouldn't. No modification should be required. You just hang that thing and let it do its thing.
So
You should just have
adjust
to
your
hang it perfectly
experiment.
still, and the energy applied from the actual Earth rotation, if such a thing exists, would cause the pendulum to activate. You shouldn't have to push it. You shouldn't have to start it. They shouldn't need to be motorized. It should be just hang the
Shouldn't need
weight
to start
and
it.
off they go. Interesting how no
Well,
one ever
yeah.
shows that.
Yeah, you put a pendulum on one of your playground merry-go-rounds, right? And then start spinning it. You saying it's just going to stay still unless you start pushing it? No, it's going to start swinging.
How fast are you spinning it? Are you spinning it once every 24 hours?
Doesn't matter.
Doesn't matter. Okay.
If they had decided to make it 35 hours in a day, like day cycle, night cycle together was 35 hours, or if they decided to do it 62 hours, or they decided to do it 4 hours, would you have still made the same claim? Well, how is it once every 24 hours? Is it once every 32 hours? Is it once every 4 hours? It's meaningless to say that.
23 hours and 56 minutes and 4 seconds, I think.
Oh, my Lanta. Yeah, because it's a circle. Circles aren't perfect. They go on.
Yeah, so what I've found with them is that when it's presented as an evidence for the globe, we ask for different results from different places around the earth, showing that the results match up consistently at the different locations depending, on how much it should be processing. And and how much error was there when they were, trying to get that result. And no one's ever able to provide this. 'Cause they're
Sure,
extremely inconsistent. They're more like a parlor trick.
Sure, I'll go looking for stuff. Okay, but
Yep, yep.
if the flat Earth is stationary, why should it move at all?
Well, quite often they don't move at all. Depends. I'm not sure. I think they're designed to in different ways. I'm not sure of the exact mechanism. I do need to look into them a bit more as well. But I mean, I can show you a giant professional setup, and it just swings back and forth for like 4 hours.
Where is it?
Sydney. I think it's Sydney. I'll post the video in the side chat.
Because we have one here in Melbourne. I remember going. I don't know if we still have it. Actually, I'm old enough to say that's actually a really fucking long time ago that I saw it when I was a kid in the museum. I think it's a museum in Melbourne. Can't think where else it would have been if it wasn't the museum. And they had little bullets standing up, and it knocked over the bullets every hour. We didn't, we were on a school excursion, didn't hang around long enough to see it knock over a bullet, but there was a whole bunch of them knocked over.
Yeah, well, that's what this guy did. He went to the one in Sydney. It was a lot bigger than one that would knock bullets over, and he stayed there for 4 hours. I guess most people don't do that, but yeah, he stayed there for 4 hours and filmed it, and it didn't knock any of the little blocks over. Just kept going back and forth. All right, I found the video. Just pop it in the side chat. I mean, at the end of the day, it's a mechanical device, and they're setting it up, and then they're not going to stop tweaking it until it does exactly what it's supposed to be doing. It's kind of almost a bit like reverse engineering in a way. It's not like you just start it, set it up, start it swinging, and then it just does what it's supposed to do at all the different
Fair
rates
enough,
at
though.
different places.
I'm trying to think of what tweaks that you would say they're making that don't just render it a sham. Because anything other than adjusting the weight or the length of the string or the back and forth kick that those bigger ones that last 24 hours do, if you're affecting the flow of that swing at all, it's going to be labelled a sham, just straight up. So what?
Yeah,
How does
I don't
that
know.
affect it?
What tweaks are they?
That's why I said earlier when I was roboting that they have to calibrate it. And in order for it to reflect the latitude, they have to know the latitude to begin with.
That's not how I understand it. And how do you calibrate a pendulum? Serious question. How do you
Well,
calibrate?
they have to maintain momentum for a
I'll
start.
give it to you. Because I looked this up. I found a model of pendulum that you can order and you can have sent to your house, and then I have looked up PDF for the manual, and then it tells you how to set it up.
How big are they? The ones you can order? Because I wouldn't be thinking one you can put in your home's going to do the trick.
Some of the most,
like
adamant anti-flat earthers claim you can do it in your house. You can build it yourself. Just hang a string from the roof. Kosho claims, I measured Earth's rotation with my pendulum in my house that he made. Yep.
If you could create a vacuum for it to swing in, you might get enough time out of it to see some movement. But you'd need to give it a kick every now and then, otherwise.
Yeah, it needs calibrated for sure.
Yeah, they don't keep moving themselves. That's why they have like electromagnetic drive systems in them to keep them moving. Otherwise, they just sit there doing nothing.
Yeah, the magnet's at the base underneath the pendulum, so as it swings over it, it turns on. That way, it keeps its perpetual motion. So it's actually driven. It's not doing it on its own.
Well,
And
their
then
claim makes
the
it even
mechanism
worse.
at the ball joint will affect its swing.
So,
They
yeah,
they
I
also
understand.
claim
Like
they also claim that gravity's stronger and weaker all over the Earth, and it's unpredictable where and how this happens. So this means they could take the same length of pendulum and they can go to one place and it swings faster, or go to another place and it swings slower. This should not happen, but it does. They say it does.
they
And I
measure
would
with
think
different
that this
things from time.
variability would affect the periodicity of the pendulum, don't you?
Yeah, this is why you got your modern
What about
physicists
deflection?
telling
Deflection of
you
the
that you got your modern physicists like Brian Cox who explain science to the layman, and he says that there is no way to detect the motion of the Earth because you're in the same reference frame. It's relative, and then references earlier what I forget who said it,
That's
but
just logic, though.
Einstein says that you don't. It was says who referenced Einstein, and so does Brian Cox when
Yeah, that's
it's
just
claimed
logical, though.
you
You don't need
don't
Einstein to
detect
tell
the
you that
motion of the Earth with an experiment.
you don't need Einstein or Brian Cox to tell you that you can't measure the movement of the reference frame that you're in. That's
Okay,
just
so
logical.
if you can't measure the movement of the reference frame that you're in, then why are you saying that you can show the Earth to be in motion with an experiment?
Well,
You're speaking against yourself right now. Where
yeah.
earlier you said you could, it's called the pendulum.
I
it's
understand. I
relative. I
understand.
thought motion was relative.
Motion is relative. There's no such thing as
Oh,
absolute
so you
motion.
can think of it as the pendulum that's processing, and not the Earth. Cool. Thanks.
Yeah, but is it
Yeah,
processing
yeah,
due
cool.
to
No,
a variability of the strength of gravity as well as a deflection of the vertical? And that's a big key because if there's a deflection of the vertical, and they claim there
Thank you.
is, then you would have an asymmetric pendulum swing based on the bias of the gravity vector pulling at a specific angle relative to true plumb.
but what changes it?
They claim that gravity's uneven. There's an uneven distribution of
It doesn't
mass of
move
varying
around.
density within the Earth. So there could be a mile below your feet, super dense rock the size of a mountain that they claim could be causing gravity to be a bit stronger and also pull downwards at a slight angle.
In different different directions.
That doesn't move though. So what would trigger a
No, but
pendulum
if you tried to
to
swing a
into one
pendulum
place?
there, it would not swing symmetrically, according to them.
Oh, I see what you're saying.
Yeah.
By the
Right.
way,
So this
what's
isn't flat earthers saying this stuff, right? And that's the problem. The globe has built this entire ad hoc ball of crap of unfalsifiability.
No, but if that is what you just described, which is a reasonable theory at first glance, but if that were the truth, then eventually the pendulum would stop rotating and it would just swing towards that denser gravity.
Would it? Have you done
We'll
that
show
to
it.
check?
It wouldn't keep logic would say it if it's doing an asymmetric swing
Yeah.
because there's gravity on say one side of it,
Well,
pulling
I
it
can logic that
pulling
I'm
it that way as it
actually a
swings.
Oh,
raccoon sitting
how
on
many
the
clowns are
cage
in here?
Well, go on
tripping,
then. Logic
and I'm
that you're a
imagining that
raccoon
I'm a
then.
person on
Logic that you're a
Discord having
raccoon
a
then.
conversation with somebody saying that, well, you
Logic
could
that you're a
logically
raccoon.
deduce this. Okay, you can logic anything. You can
Go on. Logic that you're a
fallaciously claim
raccoon.
anything and then claim anything in support of that claim to show logically, yeah, that's true, that could happen. But we're talking about the tangible reality, the thing that's, between you and me. outside,
Yeah.
touch grass, that kind of shit. We're not talking about imagine it and then like support it with ideas.
Yeah, I don't know. I'm not really into you being able to throw out things like, "Oh, they say this about it," and then when I say something, you say, "Oh, well, we're not here talking about, fantasies. We're talking about the grass outside." I'm not down with that at all. You can't
Well,
use
Yeah,
one
no.
piece of argument and then turn around and tell me I can't use it.
no, you were trying to use a logical premise, but not an actual test in physical reality. That's
The
the
only time I
Right.
difference.
said logic was when he said that they say that the movement could be caused by denser gravity in one area.
Well,
If
this
that
is
were
what
the
they
case,
listen. There are hundreds of years of this
why
being
am I?
recorded, and it's not consistent. Going back to the
Bias effect.
1730s.
What's the influence of an eclipse on pendulums off the Richter?
Uh-oh.
No idea. I'll just
Oh, come on.
assume.
Globe model explains everything, right?
No, but I don't know everything, though.
Oh, okay. You haven't looked into it? They
No,
don't know. The answer is they
I've
don't
never
know.
heard.
They don't
Never heard
understand
that.
why during a solar eclipse they get inconsistent results with the Foucault's pendulum. They don't know.
Okay.
Yeah.
Perhaps before we beg the question of any of this stuff, a ball Earth spinning on its axis, perhaps we should see if there's any curvature to measure to see if the Earth is a ball in the first instance. But I haven't seen any Earth curve measurements presented. Not in my 11 years of being around this topic.
And what's the criteria for you to say, yeah, that's a curvature measurement?
Well, somebody going out in the field measuring drop over distance between points consistent with the Earth sphere radius of 3959.
Yeah, and also
Right.
accounting for the necessary variables that could skew their results as well, because it's a hyper-specific claim. So, yeah.
Geo surveyor? What are they called?
Plane surveyor?
No.
Geodesy?
Geodetic surveyor, is that it? Not dudes that just do for buildings and stuff, guys that do,
Geodesy.
Yeah.
You're talking about
What's the
geodesy.
process? Describe the process.
I'll stick a video of a guy. Go and look at a bunch of his videos.
All right. Well,
Some of you have probably
process
heard of him.
in
Simon Rutledge.
simple
No, we already know the
terms.
process. We're asking to see if
Yeah.
you know the process. We don't need to see a video on it unless the video accounts for all variables and validates that the Earth is a globe, showing drop over distance.
Yeah, these videos do. So what are the variables that you're saying are not being accounted for?
Okay, measuring what's going on with the atmospheric refraction between point A and point B, for starters.
Okay, so refraction exists.
Perspective.
Okay, that's good.
Yeah,
That's great.
absolutely. It absolutely exists. It's the worst nightmare for the globe.
Oh, hang on. Do you say if it pushes things down?
No, it doesn't do that. That's not how it works. It's a
It
little
lifts
more
things up?
complicated than that. It does a lot of things depending on what's going on with the temperature gradients.
Fair
There's a
enough.
whole
Fair to
series. There's a whole series of miraging effects related to it.
Is it fair to say that in general it bends the light down, therefore
No,
lifting things up?
absolutely not. No, it's not fair to say that.
So then what, 50-50? Sometimes it lifts it up, sometimes it pushes them down?
No, it's completely dependent on the index, on the refractive index gradient, and if the heat flux
Yeah.
is up or down.
Right. So what would the outcome be? More likely one than the other?
It would depend if you were doing it in the middle of the day over a hot road surface, okay, and you were doing it every time over a hot surface, like a pavement or a road or something like that. then it's more likely going to be making things appear to dip in the distance.
Right? So, over the observations that we have seen in history, what's the more likely result? Regardless of where you are, like over hundreds of people doing the observations, what's the more
Not
likely
one
result?
not one person has ever measured it accurately and accounted for it, especially an observation that
The
actually,
refraction?
yeah, that's what I'm talking about. Unless you want to show me one where they did do that
No, I don't.
somehow.
I think you can make an estimation at it before you
No.
view it.
Oh, so you can just guess.
No, that's not a guess. It's an estimation.
Okay, so how would you go about
Right,
making?
it is.
How would you go
It
about
is a
making
guess.
an estimation on that?
Weather conditions? But
Okay,
you know, over
what would the weather conditions? Okay, so
Can I
we've gone
extrapolate on
out.
my answers or not, or do I just get the yes or no, and then I have to move on to
Yeah.
your next question?
No. Go ahead. Weather conditions. Go ahead.
Yeah. So the world record, or it's not the world record anymore. There's just been a longer picture done. The Pete Gaspard picture. That guy understood the basics of refraction, and
We're
specifically
talking about surveying.
Specifically went up the mountain that day, right? Because he knew there was going to be good refraction to achieve the photograph he thought he could get, and he got it. So we know how it works. But over
No,
massive
that's you can't just
distances,
get away. You can't get away with saying that. We're specifically talking about surveying right now.
I can't get away with finishing a sentence. It seems.
Yeah, but you changed. Okay, so what you did was you shift the goalpost from surveying
No, we were talking about
to a high
refraction.
altitude, long distance observation. Okay, the guy that did the Pete Gaspard or whatever it's called observation had no idea exactly what was going on between point A and point B. You're talking about geodetic surveying at the moment, not talking about being able to see something a really, really long way away that completely debunks the globe anyway. Okay, and guessing the refraction.
It's not guessing, dude. Stop using
Okay,
words that seem like
okay,
it
so
helps
where's the
the words
measurement? Where's the measurement of what was going on with the refraction that day?
Why does he need a measurement if he makes an estimation of the weather conditions are this much?
Okay,
I
so
think
how
we're
did
going to
he
have
estimate that?
high refraction. Go and read. Go
Okay,
and read the
define what do you
Northeast
think high
Dot.
refraction means?
Dude,
What do you
it's
think high
so hard.
refraction, bro? You have no idea what you're talking about. What do you think high
Ugh, how would you
refraction
know,
even
dude? You don't let
means?
me finish a sentence.
Well, you're talking shit. That's the problem.
Oh, dude, how would you know? You haven't heard me finish.
I
a
know
sentence.
because
refractive index does
because
high
I've studied
refractive
refraction,
index.
bro. I've looked into it.
Yeah,
I've spent a
exactly.
ton of time researching it, and obviously
Yeah,
you haven't.
BitChute's not research, dude.
A higher refractive index doesn't necessarily dictate the direction of the light.
BitChute's not research. Do you think there's videos? Is there videos about refraction on BitChute, or is that just a?
Can we just go to who said a high refractive index?
Yeah, look, it doesn't mean
increase
look. You're
direction?
begging the question because you're going to say a higher refractive index means that it's going to bend more, right? But in which direction?
Yeah. Well,
Up, down,
unless you have
sideways, into space.
unless you
What?
have a temperature inversion, which is a relatively rare thing, it's going to bend the light down.
No, it's not a rare
Yeah,
thing.
but like,
It's a super common thing, actually, especially in
So
surveying.
it's
Sorry.
rare
like
on a
DJ was
daily thing.
saying,
Okay?
depends
I've only
on
seen it in
which
my
is
I've only
below
seen
and
it in
which
my
is above,
a few times.
right?
Yeah. So when you
Because you can have
exactly
cool below, hot above, hot
Yep.
below, cool above.
And when you're talking about mountains, okay, where's the hotter air? It's down lower. It gathers lower. Okay, you're going to have warmer air down lower and cooler air up higher. What's the light deviate towards? The cooler air every single time. Okay, so you can't guess, right? And don't make guesses pre-assuming a globe.
No,
You can't do that. That's begging the question.
In relation to the Pete Gaspard picture, he didn't make any assumptions about a globe.
Okay, well, okay, so how did he know what was going on with the refraction? Just
Through
guessed.
the weather conditions, he can make an assumption, yes, that there is going to be a higher refractive index, in which case it's going to lift the object in the distance up more. I might be able to get that shot I think I can get today. He specifically went
No.
up there because he thought he could get that photograph on that day.
Okay, how did he know that there was a higher refractive
Read
index.
the article, dude.
I've read the whole article. He didn't measure anything. Okay, and we
No,
were
he
talking
didn't
about
measure anything. He looked
surveying.
at the weather report.
So he just guessed. You admitted that he guessed. Looking at the weather report doesn't measure the vertical refractive index gradient, bro.
Why do you keep saying he guessed?
You admitted he guessed.
No, I didn't say anything of the sort.
Okay, so how did he measure it?
Through looking at the weather report, going,
Okay,
okay,
what did
we're
it
going to
say in
have
the weather report? The weather report tells you the humidity. It tells you the general air temperature. Okay, it doesn't tell you what's going on with the refractive index gradient.
Don't you have humidity in your weather reports?
Okay,
Or
how
you
does
do?
humidity relate to refractive index gradient? What role does humidity play?
It's going to have more particles in the air, ipso facto.
Yeah, but that's not what causes light to refract. That's not what causes light to refract. It's the gases in the air that primarily cause the light to refract.
What causes light to bend?
Temperature changes the refractive index.
What's the mechanism?
What causes it? It's temperature is the primary cause. The mechanism is the refractive index. It's the optical density of the air, which is the gases. Nitrogen and oxygen are the main factors when it comes to what causes atmospheric refraction, according to the mainstream.
Was it a clear day?
Yeah, I think it was a clear day. Sorry, I was talking with my missus and I missed that. So what's the mechanism for light bending in relation to
the optical
refraction?
density of the air?
Yeah, what's the mechanism that makes it bend, though?
The temperature changes the refractive index. Okay, and where it's cooler, the light deviates towards the cooler part because it's more dense optically.
Why? That's what I'm asking.
Why? Because it's more dense. Okay,
Why?
okay. Do you need an example? Okay, you know how if you're driving
I
down
need
the
you to
highway,
explain to me why it actually bends
I told you
towards the
why.
denser medium, not just that it bends towards the denser medium. Why does it bend
Because it
towards the denser medium?
travels slower through the denser portion of the medium, just like
At an angle.
Just travel slower in a straight
has to
line?
be at so the angle of incidence has to be an incidence right, of angle, so it needs to change direction. Otherwise, it's just going to keep going straight, regardless of medium density.
But why
it's
doesn't
like
it just
if you
travel
shoot a
slower
bullet.
in a
It's
straight
like if you shoot a bullet into the water at an angle, it's gonna deviate toward, like, it's gonna make a deviation towards it's gonna deviate towards, like, it's gonna bend towards the denser medium as it hits the water. This is like
No,
that,
it's not.
but
It's gonna
it's
bounce
like a
off and head
gradient.
towards the less dense medium, the air. It's going to bounce off the denser one.
What are you talking about? We're just talking about the air here.
You said if it heads towards the water. Sorry, so I was
Yeah,
picturing
I gave you an analogy because you didn't seem to get what I
It wasn't a
told
very
you
good.
happens.
You
Yeah, it
haven't
is a good
explained it.
analogy. It's the exact
Haven't
same
explained
thing.
Sorry, you haven't.
Yeah, so it travels slower through the denser medium. The light travels slower through the denser medium.
So what makes it bend?
It's deviating. It's not bending.
Angle of incidence. Angle of incidence makes it change direction.
Can you explain what that means?
Yeah, the photon
Something
has an
different.
electromagnetic field and it interacts with the medium. The medium has a certain amount of permittivity and permeability that is modified by the density and temperature change. So the angle of arrival modified by a change in the refractive index actually causes a phase shift. It slows down the velocity of light, the wavefront, and causes actually the wave to change direction, and it also causes chromatic separation.
Not always. So
Well, yeah, always.
If
That's when there's refraction, there's always a separation based off of frequency.
so can I put it in layman's terms?
Well, no, you
Like
asked for more than layman's terms, so I'm giving you more than layman's terms.
I'm just trying to reiterate what you just said. So I
You asked for specifics. And now you're saying,
May I
oh,
ask a
that's too
question?
specific.
I can't even paraphrase what you're saying, so I'll make sure I understand it without getting shit. Honestly.
May I ask a question?
Yes, you may.
One of flat Earth believers, like, is there any topic that you think is speculative? Like, you can argue with that Earth's actually a flat Earth, or there is only arguments in the point that Earth is flat?
Not
You
sure
talk.
exactly. Yeah, not sure exactly what you mean. You'd have to give us an example of what you're talking about.
Yeah, okay, sure. Like,
unrelated?
if you have something, some topics that you think is speculative and you don't actually have answer for this kind of argument in the way that Earth is flat. So, for example, I can't prove, for example, that Earth is a globe, and I have a lot of such arguments, but I have arguments, for example, that green is that grass is green, but some people think, for example, that it's not green, that it's our perception or something like this. I don't know, just topics that you don't actually know how to work and actually have in that actually inject into your mind thoughts about the fact that Earth is a globe, something like this.
So, in the case of grass being green, green is a measurable frequency. So the light, or whatever it is that we're measuring, in this case, whatever the color or the spectra is of the light, can be measured and can be objectively concluded that it is green, somewhere between the blue and yellow primary spectrum.
It's a but
if we're going to be talking,
example, yeah, sorry.
So what we're trying to do here is not go into the weeds of speculation or entering into regions where we, argue fallaciously. We just go by what can be measured. So that's what we try to keep it to in here. We don't speculate very much, if at all, unless it's Sunday. But we're trying to just go by what can be measured. That way there is no speculation. There is no subjective position which we are going to argue from.
So you actually believe that Earth is flat?
No, the Earth is measured flat. I think I've told you that multiple times. Most of the time people want to just kind of skip over that part, like it's way too hard for them to process. The Earth is measurably flat. So it's measurably flat. I don't think so. That is what the data and the measurements show.
With that, yeah, I agree.
Yeah, okay. So if it's measured flat, I don't have to think or believe. Because of the measurement, I know it's flat.
You know it's flat.
Yeah. Yeah.
Sure.
So do you. I mean, you don't treat this Earth other than flat and stationary and enclosed. The way you describe it, the way that you live your life, the way you talk about up and down, that's all horizontal and vertical relationships. No one's measuring any curvature of the Earth. No one's measuring any spin. We have gas pressure.
We have a gas pressure gradient.
We have a great. Thank you very much. So we have a gas pressure gradient. So we have gas pressure. So there's no vacuum.
That's that atmospheric pressure.
Yeah, atmospheric pressure. Yeah, pressure. Right. And the thing that you have to have for pressure to be built is a container.
No, not true.
Okay, well then can you demonstrate for me gas pressure without containment?
Yes. Maximum, the fastest known gas velocity is 1.9 kilometers per second. average gas particle velocity or molecule velocity is 400 to 500 meters per second. The escape velocity required is 11.2 kilometers per second. So they can't escape Earth's gravity.
Gravity? What's that?
It's just compounding one, ridiculous belief on top of another.
No, this
Alright,
is your belief apparently. So what is gravity?
why is it that he asked you for a demonstration of gas
Gravity-
pressure without a container, and you give him more story time? Right? Because according to the globe, the gas pressure moving in the gas travels at this vector at this rate, and then according to the story, what's required to leave the Earth is greater than what they actually do. So, example.
Perfectly reasonable explanation, don't you think?
No.
You're
Begging the
giving-
question is not a great place to start.
An example would be like, okay, if I have high pressure and I don't have a container, that would be like a hurricane. And then you're going to get asked, what happens to that high pressure? And then you're going to have to say that the high pressure releases off into the lower pressure because there's no barrier preventing that high pressure from remaining in that location. So then he's going to ask you again, well, that's not the example that we're told with the Earth having gas and liquid in outer space. Vacuum, low pressure, right? Because Earth is not contained, but it's high pressure, uncontained, adjacent to low pressure, and it's not rushing off, right? So we need an example.
There's no high pressure next to the vacuum of space.
Okay, what do they claim is the deepest part of outer space, and what's the pressure that they claim through calculation?
Can't remember. Minus 13
10 to the
torr.
minus 17 torr, and compared to 1 psi, 10 to the negative 17 torr is 5 quadrillions times lower pressure than 1 psi. And on average, they claim it's 14.7. So that's 5 quadrillion times 14.7 between the air in your lungs and the vacuum of outer space, low pressure without a container, and the air's not rushing off to equalize with that.
Sure. Where is 1 psi in our atmosphere? What altitude?
It's at sea level, but the altitude doesn't matter because you understand we have high pressure, and you're claiming that the high pressure is next to. Oh, sorry, excuse me. I thought you meant what? Excuse me. I'm sorry. I thought you meant 1 bar. I misheard you. That's my fault. So 1 psi. Where is 1 psi? I don't know. Where'd you measure that at?
Well, the other person quoted 1 psi in relation to a minus 17 torr vacuum.
Right,
So
5 quadrillion.
Yeah, so where's 1 psi in our atmosphere? Because it sure ain't at the extremity.
It's just showing the difference between that.
I'm making a comparison between 1 psi and
What would you
10
point
to
it
the
at?
minus 17 torr. That's it.
So each change in pressure is not its own system, right? There's change of pressure within a single system. That's a single system of pressurized gas adjacent to a place that isn't considered the same system. An area of volume available to that gas. That's the claim.
Meanwhile, we still don't have a demonstration of gas pressure without containment.
No, I'm only begging the question.
Nor do we have any experiment verifying that gravity contains gas. We don't have that either. Whatever gravity is.
How would you demonstrate that in the confines of...
Not our claim. It's not our claim.
Yeah. How would you do it? Tell us how you would do it.
I don't know. Don't think you can.
Oh. Okay, so
Then
if you can't demonstrate
can't
that
support a
gravity
claim.
is even a thing, and it's not containing gas,
Talking about gas pressure.
I guess. Huh?
We're talking about gas pressure and showing
Right.
that it can exist without a container within the confines of Earth's atmosphere.
No, you
Right.
can't.
So
You
are we
can't.
begging the
You can't have
question that the
You
Earth
don't
is a
find
sphere
ask for
in
it.
outer space?
So what?
Are you begging the question in the first instance that the Earth is a sphere in the vacuum of outer space?
No, it's not begging the question.
Oh, okay. Well, I think it is, because if that's what you're assuming and yet you have no evidence for it, then
I
it
have
is
plenty
begging
of
the
evidence
question.
for it. Get a
Okay.
photograph
Well,
from the
where's
January 8 every 10 minutes.
yeah? No. If those photos show curvature and we can't measure it at the surface, then
We
those
can measure
photos are
it
no
at the
good.
surface. We can measure it at the
Okay.
surface.
So show me the curvature of the Earth and the measurements of it.
They're all over the internet, dude.
Yeah. Get
We
me
started
one.
off with
Just give me
geodetic
one.
surveying. And
Just give me.
I
Okay. So
couldn't,
geodetic
You couldn't even
surveying.
do it.
So what they're
You
doing
couldn't even
in
do
geodetic
that.
surveying is they are measuring using planar surveying and then taking those horizontal level flat pieces or portions and arbitrarily placing them around a pre-assumed geoid.
No,
Where did the
it's not,
geoid come from?
not how they do it.
Okay, well then tell me how they do it. That's why we asked you earlier to show us how it's done. So
Okay, I'll
walk
find
us
a
through the
video.
process.
You couldn't.
Yeah,
He
I'll,
couldn't. He couldn't do it.
I'll find a video. Give me a
That
second.
is literally how it's claimed to be done, bro. Like, why don't you look into this stuff before you come in here, like, making a fool of yourself?
Making a fool of myself. I'm in a flat
Yeah.
Earth Discord, dude. I'm the only
Off
one
the
in
record,
there.
Yeah, getting destroyed by flat earthers on a flat earth
Getting
Discord.
destroyed by flat earthers, saying that geodetic surveying uses a planar.
It does.
It uses
You're an idiot
planar
if you don't
surveying.
understand that, bro. They most
I'm an
definitely
idiot.
use
I'm an
planar
idiot.
geometry.
And that
How do you
means
think they take angles? How do you think they take angles?
Oh, is this where we go into
Get
the
angle measurements.
you can't get a flat
No,
base on a sphere?
no, I'm not going there. Don't assume. Don't assume. Hey, listen, bro. How do you think geodesic surveyors get angle measurements? Would that be with planar straight line geometry?
Planar being a flat surface on the ground.
No, planar being straight lines or planes.
Let me look that up.
Drop a plumb bob, get a level, make sure that the thing that's going to be taking the angle measurements is level 360 degrees on that plane that's created with the level, and then make the angle measurements.
Yeah, they measure in angles. What do you think angles are?
Angles are the difference between two lines.
Straight ones or curved ones?
What's the difference?
That would be the difference between using planar geometry and using some other methodology that doesn't involve straight lines or planes.
Right. So if I stand on the surface of the water and look out to the horizon and draw a straight line from me to the horizon, right, and then make a measurement of, say, a lighthouse that's way past it where I can only see the tip of it, so there's some drop, right? That's planar measurements. I'm not measuring any curve there. Is that what you're saying?
Oh my God.
Where are you drawing an angle from? What are the two lines from where to where?
From my eyes to the horizon, from my eyes to the top of the lighthouse.
Okay, so you have an angular separation between the top of the lighthouse and the horizon.
Yep.
What about it? Okay, what about it?
You ask where I'm getting my angle from. That's
Right.
the angle.
So that's your angle. So two straight lines.
Yep.
Okay. Now what are you trying to do? You have an angle now. What are you trying to do with that angle?
Sorry, one sec. So I will be back in 1 minute.
Yeah. What spins around the Earth?
Nothing, as far as I know.
Okay. Then Earth is spin because the moon stays stationary, and we have moon that goes from one side to the other
Sorry,
side.
hold on. before you go any farther, when you say spin, I'm thinking that you're talking about axial rotation. Okay,
Yeah.
so instead of us getting crossed up with the way that we discuss this in our terms, you're asking us what orbits around the Earth. Well, orbits are described in relation to a horizontal plane. So if you're talking about the luminaries, being the sun, the moon, stars, and the wandering stars, which are called planets, those are the things that are essentially orbiting or moving around the surface of the Earth. When I say around, I mean they take a path and, or I should probably say across, because they go from one horizon to the next horizon. But those are the things that we can see that are moving.
Well, from what you're saying, I see that you think that sun actually spins around, actually orbits around the Earth.
Well, the orbit is described in relation to the horizontal Earth. Like if you were to get out a program like Google Sky Map, those orbits would be described from the flat Earth. So the orbits are in relationship to horizontal. Now, what I would actually describe it is a transfer or a transit from one horizon to another. That's what I observe. That's what most everybody observes, unless they're in the extreme south or the extreme north. Then you have the sun taking a circular path. You could call it an orbit in a circle 360 degrees around you on the flat plane. So yes, the sun and all of the luminaries are moving in relation to a flat and stationary Earth.
Spins around its axis.
No, there is no axis. As far as I can tell, Earth is not spinning on any axes. That's a concept.
Well, why we do have 4 seasons? Why do we have night and day time?
Well, it's pretty obvious, but I'll go ahead and explain it to you if you're not aware. The angular relationship of the sun to that particular region usually coincides with the seasons. So it mostly has to do, in my opinion, with the relationship of the sun to the Earth below it and how much it gets warmed or cooled, and that's what determines the seasons. And the second question, I believe, was sorry, what was the second question?
Oh, day and night.
Day and night.
Like,
right. So when the sun is up, it's daytime. When there is no sun, it's nighttime.
okay. But where does sun go when there is night? Where
Over a different region of the Earth, apparently, because it will set where I'm at, but where somebody else is at, farther to the west of me, they still have daylight. So the sun is moving over their region, and now it's out of my view, and it's nighttime.
I didn't understand. Sorry. Can you explain it again? Like I think that sun should go behind our Earth in the square. Like if we perceived Earth like a square, how did you
No,
call
no.
that?
I never said that the Earth was a square.
But it's a flat, and sun should go somewhere behind Earth's flat. So
No,
I
no.
know.
You're making an assumption that because you don't see the sun, it's behind something. That's a poor assumption to make.
Where is it? I don't see it.
It's too far for me to see. It could be that the light is being attenuated, like we talked about earlier, by the air, right? Because as things move farther in the distance, they do get closer to the horizon. And even a light source like the sun, as it moves away, is going to get closer and closer to the horizon where the thickest part of the air is, and the air will block out the sunlight to my eye, even to the land where I'm standing. So we just have a sun that's far enough away that it no longer illuminates our region due to a myriad of factors, most likely being the medium of air blocking out the sun.
Well, why there is sunrise from one side and then sun shine from the other? The evening. How is
Sunrise from one
sunrise
side. Uh-huh.
and sunset from the other? Like it should somehow be teleported, or how?
Well, I don't know anything about teleportation. I just know that that's what we observe. What path the sun takes ultimately to end up close to the same spot it was the day before in the morning, I ultimately don't know. I have no idea. I don't know what the actual path of the sun is. I don't know what the actual makeup or distance or height or material that the sun is or is made of. I have no idea about any
Nobody
of those
does.
things.
Nobody does.
Right. So nobody has any idea about any of that stuff. What we do know is that we have this cycle going every day. So it seems as if the sun takes some kind of cycle.
Well, do you agree with the assumption that nothing appears from anything and nothing goes anywhere, like Newton's laws?
Well, those aren't Newton's laws. That would be the first law of thermodynamics, which states that matter cannot be created nor destroyed. Right. So you can't have something essentially from nothing. We have the material that we have. So if we have the material that we have, I don't think we're getting a new sun every day, although I really have no knowledge about what's going on. Meanwhile, we're talking about the Earth, right? So the Earth is measured flat. What the stars and the luminaries are doing, I have no idea. They do a whole myriad. I'm using too big of words. There are a whole lot of different things that the sun and the stars and the moon do that defy any reason or logic. They do all kinds of weird stuff at different times that would also debunk the idea of a globe, because when the sun rises and sunsets and the amount of days that we have each year will not coincide with a heliocentric concept or a model of that if you do it strictly according to, hard, fast times, dates, geometry. All of the luminaries defy the heliocentric model in their patterns and in their shifts. So the sky is a complete mystery. It does what it does. It does that over a measurably flat Earth.
Can you explain the last sentence? Like, what do you mean?
I mean that the sky is basically its own system where all of the stars and the sun and the moon do their own thing. They do very bizarre things, right? They're very curious to us. They defy logic, like I said, at least in my opinion. But all of that stuff is happening over the surface of the Earth, which is measurably flat. So how it's happening, why it's happening, I really cannot tell you. But the Earth is measured flat.
But we can explain some concepts about space, about sun, about luminary, about with the concept that Earth is a sphere and it goes around the sun.
When you make up
Yeah,
stuff, you
right.
can explain anything.
Right. So what you call an explanation is just a story based on the observed phenomena. However, the problem with all of the story is that it is using a globe Earth to create the entire fairy tale. Well, if the Earth is not a globe, which we checked, and it is not a globe, then that entire story falls apart. So every explanation or story that you think that you have, if the Earth is not a sphere, all of those stories are complete fiction and can be ignored.
You tell him that you checked actually that Earth is flat. When did
Yes,
you
like I
check
told
that?
you earlier.
You have explained me
Myself?
that you can't absorb you can't absorb it like a globe. You can absorb
No,
and
that's not what I
and
said to you. I remember you being
not
in here
absorb.
earlier. Excuse me. No. That's not what I said. I told you that the Earth is measured to be flat, not that we just
Measured.
observe it.
Yeah.
Measured.
So you told that it's measured flat, but you never said that it was observed as a flat. That you have proved that it's flat. You never proved and
The proof is
never
the measurements. And these are not measurements that I'm taking even. I have my own measurements. Most people would reject them because I did them over land. But nonetheless, I've done my own firsthand personal knowledge test of the curvature of the Earth. Now, as for the surveyors, the navigators, and everybody who walks the face of the Earth every day, they measure it practically and use it practically flat, horizontal, level. That's the measurement of the Earth. So it's not just me, it's everybody in every industry doing these things. Nobody is measuring any curvature. Nobody is measuring any spin. All of those things are just parts of a story, and that story is based on the Earth being curved. The Earth is not curved, therefore, it is knowledge for everyone, although denied, that the Earth is flat and stationary.
But it explain that some concepts of space, like sun and Earth going around the sun, for example, why this concept even exists, from your opinion? Like,
why does the
why
concept
people,
exist?
Yeah.
Well, it started usually, most of these things all come from pagan ideologies. This one is no different. Even the ancient Babylonians believed that the sphere was some kind of perfect shape, but also more recently, within the last 3,000 years, a guy named Pythagoras also picked up on this pagan ideology, and he had a cult called the Pythagorean cult, and they worshipped the luminaries, but also round spherical objects. And they are the ones that put this idea into, into the mind's eye or the imagination of the culture of the time. But even in their day, people measured the Earth flat, but the cult, the religious cult itself, believed that the Earth was a sphere, only because they preferred it that way. Now, that particular myth has been transferred and grown into what you call today heliocentrism. Still a pagan ideology, right? Where even in the Roman era, people believed that the sun was a god. And they also named the sun after a god called Helios. So these are all just religious, occult, pagan ideologies that have changed over time. And in this current day, the people who believe these things happen to be the people that are, running the corporate governments of the world. And they put this idea forth so that the masses would believe them and they could control them using deception. It's fairly simple. It's the same thing that's always happened. It's the same thing from one end of history to the other. Greedy, wicked, stupid people using deception to control the rest of the people so that they could be enslaved. The best way to keep a slave is to train them in the mind, not to put a cage around them.
I can prove that Earth actually not spinning around the sun, so yeah.
You can. Did you say you can or cannot?
I cannot.
Okay. Yeah, it's very difficult to prove because the only observation that we have is that the sun goes from one end of the sky to the other every day.
But
don't feel
let's
bad.
imagine.
Nobody can.
That's on the
imagine-
assumption that we don't go to space.
Space is going to have to be defined, and then it's going to have to be proven.
Don't
Otherwise,
include
it's just a
yourself in the
belief.
efforts of other people, man. It's not a we. It's not a we. It's a them.
countless
You're trying to
photos of it.
piggyback. You're trying to piggyback off someone else's claim with no ability to be able to support
So
their
are
claim.
you.
Get them in
So
here. Get them in here to support their claim.
So what can you put up some of your measurements for us?
Oh, just look at any geodetic survey table.
No, T-dub.
Just look at any of the measurements.
Right, so we can use other people's data. Awesome.
Wait. Oh, you're back. Okay, so can you tell me what we're going to do with that angle between the top of the lighthouse and the horizon now? What are we going to do with that angle?
No, I don't know. It was an example of having a straight line over a curved surface and being able to
Why
take
would you assume that
an
the
angle.
surface is curved? All you have is an angle between the horizon, being the
Well, it
apparent
wouldn't matter, would
location
it?
where the sky meets the sea, and the top of a lighthouse. So, what are you going to do with that angle?
So it wouldn't matter if it was curved, would it? Because we see the horizon and it's a straight line between my eye and the horizon, correct? If it was curved, it wouldn't matter, correct?
Well, when you say straight line, are you going to say that the horizon is an actual tangent point on the edge of a sphere, or is it an apparent location and it's not something that we can draw a line to?
Deflecting. If I draw a line from my eye to the horizon, is that a straight line, whether the ground under it is curved or not?
Well, I would say it is. If you're going to draw that line, it's going to have to be straight.
Sure. So that's what I was explaining when I said about the angle of the lighthouse and the horizon. That's all I was explaining because you asked me how do I get
Right.
an angle.
Yeah, two straight lines. So you have an angular separation. That's an angle. I don't know what that had to do with the topic, but okay.
You asked me how am I going to get the angle, and I just explained it. It wasn't a big deal.
Okay, so you have angular separation. Now, we were actually talking about surveying before that. So if we were going to survey between 2 points, how would we do that?
What do you mean?
How would you determine the height of an object that is far away from you and its relationship to the surface of the Earth using surveying? How does it work?
So get my height or the equipment's height, and all over the Earth there are points that are well established about what their heights are over sea level.
How do they get
And
those heights?
I don't know. Maybe a barometer of some type to work out exactly what they are above mean sea level or above sea level. But they use them because they're very precise.
Maybe. Well, barometric pressure changes not only according to altitude, but
I know.
also weather.
I know.
So, yeah, so that's not terribly accurate, especially it's going to change from day to day because of the weather. So, how do you know the height above sea level?
Why are we getting so bogged down in this? You asked me how we do the surveying, and now we're getting bogged down into a point that if I didn't even bring that point up, you
This
wouldn't be talking
is
about it.
surveying. Where do you think these heights come from?
Other people that have taken the time to really consciously be precise with that measurement, so you don't have to every time you try.
How do they measure it? How do they measure it? This is going to prove that this is all planar, and you don't know. Okay, so you don't actually know anything about surveying either, do you? You appealed to geodetic surveying, and you have no idea how it works.
So if I use that point and look out over a distance and something that is supposed to be at eye level for me, so for want of a better term, and it's below that, I can assume that the ground is below that. If I take refraction, etc., all the other conditions into account, and it's still below where it should be on a flat surface,
Whoa.
that it is lower.
You
than
already
it
measured a
should
flat
be on
surface.
surface.
You already measured a flat surface. How would you know below what datum are you using?
The one that I'm standing at with my piece of equipment that's
Okay.
looking directly horizontal out, and the object way in the distance that is
Perfect.
supposed to be at exactly my height, it's below it. What explains that?
Great. No, you didn't actually establish that, because in surveying, this is what they do. They establish a horizontal from sea level and measure angular heights and depths according to that horizontal datum. And the distance that you're measuring between points, that's also a straight linear line, right? It's a distance, so it has to be straight. So everything that you're doing is measuring a flat Earth and heights and depths below a specific datum. So you're measuring a flat Earth. I appreciate you bringing that up.
Preposterous nonsense what you just said. Oh, we're
It's
using
monstrous
straight lines,
nonsense. Okay,
so
no worries.
so
So
it's a flat Earth. Spare me a
yeah, it
break.
has to be. It has to be.
It has to be because we're using straight lines to measure
Right.
something.
Are,
The
are
straight
you
line
going
that
to get
I'm
me
using
of a
shows
curve?
something that is supposed to be at eye level, shows it below eye level, but we're using
Okay.
a straight line to look out there, so it's a flat Earth. Do you
Below
understand?
eye level, right? So below eye level, so horizontal, straight, flat. That's the datum that you're
Eye
using.
level, the object, you know, the theodolite or whatever it is you're looking through, the
Uh-huh.
object that you that should be on that crossbar in the theodolite is below
Uh-huh.
it, and it's supposed to be at that height if it's a flat Earth, and it's below that.
That'd be a straight line.
Straight line. Yeah, you just measured a flat Earth again. You don't even know that you're doing it. It's kind of funny. When you say below,
That is the most ridiculous thing I've ever heard, honestly.
I know it is ridiculous because you're not even realizing that you're describing to me a flat measurement.
I'm describing you a flat measurement, sure, right?
Yeah.
So the drop from that line, that's a flat
The straight
measurement
line,
too.
the horizontal line, the one that you carried off from sea level.
Yep, and the object in the distance is supposed to be at
Thank
the same.
you.
The object in the distance
Thank you.
is at the same height from sea level as what my theodolite is, yet when
Okay,
I look at it,
give me an example of
it's
this.
below the
Excuse
theodolite.
me. Excuse me. Give me an example of this and show me how you accounted for everything.
All right, give me a minute to go find something.
Okay.
I have come up with idea why someone can't actually send radio signal from any point of Earth to other point of Earth, because signal just mostly travel in straight lines, and Earth's curvature actually blocks them, and because of that we can prove that Earth is actually curved.
No. What you would be doing is committing the same fallacy you've been committing since you got in here, which is affirming the consequent. Plus, one of the first radio transmissions by Marconi from the eastern side or the coast of the United States all the way to Europe, about a 2,000-mile transmission. They received that point-to-point transmission. This was around the turn of the 20th century. So radio transmissions between points, vast points, are often achieved. I think there's even one from the UK to Australia. Is that right, fellas? That was 10,000 miles. So they're, yeah, 10.
Yep, 1918.
10,000 kilometers. Yeah, so in 1918, we had another transmission from two continents, mind you, for 10,000 kilometers. This is happening all the time, every day.
Well, there is new technology and inventions are currently inventing that actually allows to send signals to further distances, and the name of invention is satellite, because satellite is first intention is to send signals from one point of Earth to another through space, because they can solve the problem with curvature of Earth, and
right.
Yeah.
That's great. So now what I want you to do, instead of just telling me the story, is to prove any of that. One of my favorite parts of that story is to show me how you have a piece of machinery like a satellite orbiting, meaning making a circular path around a sphere Earth that isn't measured, and how it's tethered and stays in a perfect distance away from the Earth, going in an angular path around the Earth. How is it being tethered to keep its orbit?
I didn't completely
Governed
understand
by
your
its
question.
speed.
No, this is not about speed. This is about how is it maintaining a circular path around a sphere at a very particular distance. What is
And it's
holding it
trying,
at that distance?
it's trying to fall towards the Earth, but it's going so fast sideways it keeps missing it.
You find your
Putting
test
like
yet, buddy? You're meant to be getting a test.
Yeah, where's the
There's a lot of tests
theodolite
about
observation that you were going to give me?
Okay.
Yeah, I've already heard the idea of the satellite falling around the Earth, but it is taking an angular path. So it has to be maintaining an anchor to a point, and it's not a piece of string holding it. So why is it taking this circular path?
Why does it have to be anchored?
Well, if it's not anchored, then isn't it going to just go ahead and continue on the trajectory that it is in a very straight path? Because
No,
centrifugal force, right? So if you have a piece of something on the end of a string and you spin it, the reason it's taking that angular path is because it's tethered to the center. If you let go of it, it's going to continue in a straight path, right? This is all simple physics that we've already known. So why is it not taking a straight path? Because it's not tethered by a piece of string. What is tethering it, and where is it being tethered to?
It's tethered to the Earth via the depression in space-time that is gravity.
Space-time. So the fabric of space-time. Can you get me a sample of this, please?
Do you believe that people
it's
use satellites?
Sorry, what? The other guy interrupted you. Could you ask that question again?
Sure. Do you believe that satellites exist and satellites used by people?
It depends on what you mean by satellites. We do know that there are machines, at least being held up by balloons, that move across the Earth at high altitudes. Okay? Now, if you're talking about a piece of machinery that is hovering in a second law of thermodynamics violation called outer space, being tethered by a space-time fabric, according to our friend over here, no, I do not believe that that nonsense exists. It sounds absurd.
I asked what I asked, and you answered that you believe in satellites, but why do you think we use them?
Did I qualify what I said I believe? What did I say?
Some stuff about second thermodynamic law, but
That's all you heard?
Yeah.
Wow.
Sorry,
Why am I
said
having a
I
conversation with you? Okay, so the first thing that I said is we already know that we have pieces of machinery being held above the sky or above our heads using balloons. This is well known. The idea of a satellite balloon is very well known. So this is definitely possible. The other idea, a piece of machinery that is orbiting a sphere Earth being tethered by nothing, no, I don't believe that.
I've heard right that you think that satellites actually are flying because of balloons.
Mm-hmm. Yep.
A lot of researchers that actually build the satellites have construction of satellites. They don't have balloons. Like they just have, as we said, piece of equipment, machines that actually just fly around the Earth and not on the balloon not on the balloons.
I'm sorry, so are you denying that satellite balloons exist?
I don't deny that such satellites exist. I saying that architects of these satellites actually not using balloons in all
Hello guys, how
satellites.
are you?
Hey, could you calm down for half a second? There is a conversation going on.
So balloons used
Okay,
in
okay. I'm sorry. I'm so
almost
sorry. I didn't know that.
in
Good lord.
very
Okay.
high, in very almost space height. There is such use of balloons, but in most of the satellites that, for example, Tesla and not Tesla, but SpaceX use for their Starlink. They don't use such concept as balloons.
Okay. These are things that you're telling me that you believe. Do you have any evidence for anything that you just told me?
Well, there
Because
is
I posted in the
yeah.
chat, if you will look, there is a short GIF. You have actually two satellite balloons in the frame. One is taking the video, the other one is in view of the camera. These are two satellites being held up by balloons.
There is a photo in the chat of Starlink equipment.
All the day.
Free app has more photos of the satellites on balloon. Could you post? Mine's taking a half a minute. Yeah, great. You have pictures of lights in the sky. Do you have any evidence that those lights in the sky are being held in orbit by nothing around a sphere Earth? I know that you have lights in the sky. Now I need you to prove the rest of the story.
I didn't understand the question.
He didn't post lights
Can
in the
you
sky.
prove? What does he have?
It's just a picture of a Starlink satellite, like in like a factory or something. Like just a picture of it.
Okay. Yeah. Brother, I am not, like I said, you have to understand what I'm saying. I'm not saying that there aren't, machines, technology above our heads being suspended, most likely by balloons. The thing that I want you to prove is the idea that these machines, this technology, is in space, being tethered by nothing, taking an angular path around a sphere Earth, and then I want you to prove each one of those pieces of the story. I know the story. I've heard the stories. I know who Elon Musk is. I've heard of SpaceX. I've even seen lights that apparently are SpaceX going over my house at night. But I have nothing at my disposal, even physics itself, to verify that this is occurring according to the story we're being told. That's the part I want the proof of.
Well, actually, some satellites drop from the space to the Earth back and just burn in the atmosphere.
Okay.
Some not burn, but and
Friend,
some of them drop.
I got to stop
And
you. I don't want to hear the stories. A satellite landed in somebody's backyard. Can you prove to me that it fell from space while it was, orbiting a sphere Earth, the thing that cannot be measured, angularly taking a path around the Earth tethered by nothing? Yes, people, is it more likely that maybe one of the balloons failed and then it descended to the Earth? Because it turns out there are many satellites found in people's backyards or out in the country or whatever, and they have massive balloons attached to them. Were you aware of this?
no.
No.
Did you see the picture of the Earth in this resolution of hundreds of terabytes?
Great. We have an image of Earth, and there's a lot of data behind it. Now, does it look like a big ball?
It's a circular object. Yeah.
A circular object. Okay, so there's curvature. Now, on the Earth, where can I find that curvature? Where can I measure it?
Well,
who has measured it?
I think if you look in the on the actual ball and circle that is cutted from the paper, you will see difference in in perspective, and you can have same analogy in the Earth pictures that made from the space.
Friend, I don't know why you're avoiding the thing that I'm asking you, and it's becoming a little bit tedious here. Where can I find the curvature of the Earth since I'm standing on the Earth? Where can I measure it? If you have a picture of it curving, but then I go and measure the Earth and it's not curving, should I assume that the picture is right or that the reality is right? Which one?
I think I'm not very fluent in English, so I can't actually understand your question completely. Like, what should I explain you what curvature? Like,
Should I believe the government story or should I believe the measurement of the Earth?
the philosophical question. I think you have to believe what you see.
Yeah, if I measure something on the Earth and I know that it's flat, I don't really care what the government pictures look like. I am not going to trust the government, and I don't think anybody really ever should. I don't think most people do, because they are already aware that the governing authorities are lying to us constantly.
Okay.
That's a good point. So Drace AI here has a good question. Have you ever used a dating app?
Yeah.
Have you ever dated somebody online? Yes. Okay. So have you ever seen some of the pictures of the girls? They're pretty attractive, right, in the pictures. And then when you meet them in real life, is there a difference?
I'm not. I don't think that dating apps related to the topic of the Earth, but I think some of them can be, some of them can't, but are not.
Well, I'm pointing out. Yeah, I'm pointing out that there can easily be a fraud, committed against somebody using a picture. So there's a lot of dating apps out there, and there's a lot of supposed women putting their pictures on these apps, and they look beautiful, right? And so then when the time comes to actually meet the individual, when they show up, she's either, 30, 40, 50 pounds heavier, or it's a dude, right? So pictures cannot be our basis for truth, sadly, especially in this age where now we have to contend with very, very, very good CGI. And on top of that, really, really, really good AI manipulate photographs or completely fabricated images.
أرض مسطحة. Oh!
Send in the clowns.
Hi.
Well, the analogy here is that you're being presented with a picture. You're being told it's the truth. It's a woman. She's hot. Then you go on the date. Turns out it's actually a man with a stubble and an Adam's apple in a woman's dress. So, do you now accept the picture as reality, ignoring your senses, ignoring reality? Or do you maybe accept reality for what it is, and that the picture was not maybe real?
Sadly, we live in an age now where people are much, much, much more reliant on video and imagery that they will see in a book, but more than anything on the internet, and they use that as their source to determine what reality is. They have abandoned physical reality and the testing of it and being in it and observing it and measuring it. They've abandoned that, and now they just rely on imagery and stories about the imagery. There are certain situations where photographs can be useful, imagery can be useful, but it cannot be relied upon as people's source or determining factor on what is true.
Why not?
That's well, because if you only accept the image, then you're going to go on a date with a dude.
Well,
right?
Girl can change her behavior and can change her appearance for the photo taken, but satellite wouldn't change its appearance. And someone who takes a photo maybe be a journalist that actually not paid for some government shit and just taking a photo of Starlink.
Yeah, once again, the lights in the sky have no bearing on reality. You're assuming that the story about the lights in the sky is correct, but you don't have any evidence for it. Second of all, any imagery that purportedly comes from a satellite that you already believe exists, although you don't have evidence for it, you don't think that that image could be manipulated or even fabricated and then given to you by the authority and all of their hundreds, if not thousands of outlets that we call media. So there's no way for you to verify anything that you get as far as an image is concerned that is supposed to be coming from a supposed satellite. You cannot verify it. So you are only trusting something, and it's not a good idea to trust things that you cannot verify. Just in general.
I think it's a good approach that you should verify what you believe in and believe in what can be verified and proved. But all stuff we believe in and all stuff we prove something with, we already agreed to some concepts we will be using by doing uh, some researchments and agreements. Like you already believe in in geometry of 2D spaces and such stuff. So I think from philosophical perspective, we all believe in something that is not that can't be actually proved by 100%.
Well, when you say we, you're going to have to only speak for yourself, because I do not agree that I have to believe imagery that I get from really anyone. I am always allowed to be a skeptic of any imagery that I get. That is my, well, not just my right, probably my duty to always be skeptical of things that are forced in my face, especially when I can't verify them. I can always say, I won't believe it until somebody proves it or verifies it. You have chosen a different path. You have decided that because you're part of the society goes, well, everybody else believes the images, so I guess I will also believe the images. That's your choice.
Do you know why governments don't tell us the truth that Earth is flat? You
Well,
already
I
said
mean,
that
I
it's
can't.
for human human changing of perception for manipulation, and I think it's based on the fact that all things human is absorbing, and anything he is proving, he should prove on some concepts he believe in, and if they don't have a strong foundation, he can't build a very strong understanding of everything. I think you said something about that, but is there any other, or do you, from that perspective, am I right that you thought something in that way?
Yeah, my assessment is that the governments, who we do know lie to us quite often, the reason that they lie to us about anything, not just necessarily the nature of Earth, but everything, for control, because they are wicked and they want control of other human beings. I don't even think it has to do so much with money, because the money itself is a means by which they control the people. So the ultimate goal is to have power and control over their fellow man, because they're wicked. Now, that is my own assessment. Other people may believe differently. They may evaluate the situation differently. But that is what I see. That is what I experience. Otherwise, this would be a much different place in which we live. If people were going out of their way to benefit their fellow man instead of control their fellow man, we wouldn't even have a need for a government. But men do that. There are men who are wicked. They have nefarious or evil agendas, plans for other men, and that's why we are in the state that we're in.
But this is assuming that they know, that they have some sort of knowledge that the average person doesn't, and are now trying to,
correct,
right, hide this information. But I don't necessarily lean that way. I think it's quite possible that they themselves could still believe that the Earth is a ball and simultaneously fake going to space. Because that's all you're appealing to, is this imagery from space that you're presented on a TV screen or in a book or on the internet. That's all you're appealing to. That's what initiates this idea that there's a lie being told, right? Because if someone says it's flat, but you showed imagery that it's not flat, right, from a long distance away, then you're going to say, well, okay, somebody's wrong or somebody's lying, right? But that doesn't necessarily mean that they're lying to convince you of something, that they understand, right?
You know what, T-Dub, you make an excellent point. It also doesn't require that the people be evil. to lie to other people. Some people believe it's virtuous or a good thing to lie to others about certain things for their own protection, for their own good. So it doesn't even necessarily mean that they're evil. Maybe they find it virtuous to deceive or to tell half truths.
Right. Yeah. I think people give them more credit than they're due. I mean, like in the aspect of of their capabilities, right? So if they're
Well,
capable of going to like said distances away from the Earth, then they would have that vantage point to be able to turn around and look at it, the Earth, and go, well, it's either this or that, right? From this vantage point, and then attempt to lie to the rest of society about what they experienced, right? But did they even get to that altitude or that distance away from the surface of the Earth in the first place? That's another question. Do they have that capability as they claim? I don't think they do. And who are they really that I should care? That's a question I so want to ask a lot, right? When somebody says, "Why would they lie?" I want to say, "Why should I care?" What is the
Yeah, I
difference
like
between
to.
them? Go on, sorry.
Well, yeah, I was agree with what you were just saying as well. Like, I usually ask them, like, do you have a name? Like, who at the government? People say, "Oh, the government," but it's a whole bunch of people. Okay, so who at the government knows that the Earth is flat and is lying about it being a globe? Give me a list of names and prove each person on that list is actively lying about this. I don't think they are. I think nobody's going to be able to come up with that list. And people just assume the governments are the ones that are truly in control as well, where I like to think of the government more like a mafia that's kind of designated to look after a particular part of the plane. And absolutely not the ones calling the shots. That's just speculation. But yeah, I think most people aren't lying.
Do you have sorry, we've been sort of going on a bit between ourselves. SX, do you have a response to any of that? Or sorry, Jacquard?
about what? That government's not in the center of what? Of the world, and they not the least piece of chain that rules the Earth, or what?
Well, that was the speculation part. More the part that T-Dub was talking about, how most people that work at the government aren't actively lying about this, if anyone.
I don't
Most
think
people.
that it's possible to actually hide such fact, hide such secret that Earth is flat, because a lot of people in in power have dementia, like disease of brain becoming not very useful, and I think it will
Wait,
be
what?
very,
You're talking about Joe Biden or what?
for example.
Yeah. I don't think the secret is that it's flat. I don't think that's the secret. Yeah, that's obvious. That's the obvious part. You go outside, you look at the Earth, it looks flat. Right? Measure it, measures flat. And when you go to
Most of the
practically use it,
people,
it's flat.
if most of the people think that Earth is orbit, that it's a sphere, like then people that think that it's flat, like actually have a secret in their minds. Because I don't know the statistics, but
That's what I was
most of the
saying. That
people,
it's the capabilities they claim to have that I think is the lie. That they're able to gain enough information exclusively, right? Not privy to the average person, in order to be able to definitively say, beyond all doubt, that Earth is a spinning sphere in the vacuum of outer space. I think that's the lie. Not necessarily that they know it's flat, but they mustn't let everybody else know that. They've got to try and convince us that we're on a ball. That just doesn't make any sense to me. That sounds silly to me. Like others may, others may have a different opinion to me about that, because of spiritual reasons or um, other different reasons, philosophical reasons, whatever. I just don't see the benefit myself, as a lot of globers don't see the benefit in lying about it being flat, but convincing us it's a sphere. I don't see the benefit in it because they could easily just as exploit us in whether we think it's flat or not. Right? Come on, you got to admit that the majority of citizens of the Earth are pretty dumb, pretty easily manipulated, gullible, naive, controllable. Right? You don't really need to tell them that they live on a sphere in order to control them.
yeah,
It might help a bit. I think the majority already, like the majority of the Western world, had already accepted that the Earth was a sphere prior to any space exploration. I just don't see that they needed to really reinforce it just for a minority group. Right?
Yeah,
I think that most people
it's a
can't.
good point. It is interest. Yeah, that's a good point, T-Dub.
Like most people can't know. Most people can't do what certain agencies and governments claim they can do, which is go really high up in the sky, right? Further than your conventional aircrafts, right? And from there they can deploy and utilize certain technologies, right, which gives them an advantage over others, right? And then claim to provide the average person with services, right? You can't verify any of that. So they can say to you, we're investing your money, your tax money, so much of your tax money into this project. And you can't say, well, I want the receipts. You can get a service that they claim is being provided to you by that methodology, but you can't go and verify that they're actually using that method in order to provide you that service. Can you? That's irrespective of the Earth being a sphere or flat. The Earth could still be a sphere and they could still take advantage of you like that.
I think there is also such interesting topic that human brain actually have something like it can't uh, it can't understand the negative, like and such topics that uh, prove that human will find something he wants to find, and if it's easier, then other perception he gets, he will actually believe in the easiest perception. So I think some people just believe in what's easier, and if someone tells them that it's easier and Earth is orbital, is spherical, then they just believe because it's easier, because they didn't prove for themselves that, and believe in that because it's easier. And I don't know, maybe it's
It's
very
easier to have someone
over-utilitarian.
else think for you, in other words. You go about your daily life. Those guys they've got it. They've got me. I don't need to worry about it. Some other very smart people are figuring all that out, about the secrets of the universe and everything.
Most people have also never been given an alternative worldview. They've just been taught it's a globe. They've never questioned it. They've never tested the Earth. They don't know any of the technical information about it. They just blindly believe it because they were taught it growing up. Okay, they've not been presented quality flat Earth arguments ever in their life, so they have no reason or nothing else to choose but the globe.
Exactly, yeah, and it doesn't impact their lives in any way. They don't even think to challenge it until they come into a place like this. Right?
Well, I think I've come to the point that it's easier for me to think that Earth is flat.
Well, this is the thing. I
But
mean, it's very simple. I mean, if the Earth's a globe, they tell us the size of it. They also tell us that over 70% of the surface is covered in water. And we've done literally thousands of tests at this point, and every single test shows that there's no curvature. And we can't find a single test. We can't find a single test that shows that there is curvature.
Mm-hmm. And in which way you benefit by Earth being flat?
The checks, gunslinger, big checks, sure.
No, I'm asking in which way do you benefit that Earth is flat?
Like, what do you mean? Like, how would you benefit from that?
Huh?
What do you mean? Like, what do you mean by benefit?
Oh yeah.
Like, what's your that's
What
subjective?
is
It's a subjective term that you're using right now. What do you mean by benefit?
well, if you got like information that something is true, which otherwise would not be, and you have it, I guess it comes with some kind of benefits, yeah, for you. So
Yeah,
what are those benefits?
well, it's very, very good at teaching people to think critically, which is very important
Oh,
and
yeah.
very beneficial, I think. And also, yeah, there's a lot. It's subjective. It depends on each person's
aids
situation.
in engineering, helps with your engineering, building.
Yeah, I learned
Really, huh?
a ton of technical information that I've learned since I've been looking into this topic
Yeah.
as well. But lots of things, man. It really depends on the person. Happy New Year, by the way, Gunslinger. I don't think I
You
spoke to
too,
you this year.
DJ, man. You too. Happy revolution around the sun, man.
Happy annual solar cycle day.
Yeah.
How does thinking that the Earth's a spinning ball in outer space benefit you? At what point in your life are you're gonna go, oh, I have to utilize my understanding of Earth being a spinning ball in outer space to complete this task. If I didn't understand this, I wouldn't be able to complete this task. When is that going to ever happen to you?
I don't know what you're talking about, but I know that we have them videos of ISS through telescopes in front of the sun, you know. You got ISS orbiting all around us, and then they filmed the sun with a solar lens for the telescope, and you can see the ISS just like they showed us. It looks like flying around like a motherfucker. So that she gotta be propelled by something, yeah, and it's propelled by orbit.
Who knows how it works? Who knows exactly what we're looking at? We don't know. We can't check it. We can, you know what we can check though? It's the surface.
But you agree that if something is that high up, it had to get there by something, and it needs to be propelled by something to keep circling, yeah.
Yeah, who knows how fast it's going or how high up it is.
Yeah, but it's pretty high up. It's you agree with me?
Well, this is the thing. I don't know if you want
Well,
to have a
let's
look at
check.
what Says Who just posted in the chat.
Oh.
The ISS is only roughly the same size as a giant jumbo jet. Okay, and when a giant jumbo jet is just 6 miles up in the air, you can barely see it because it's like a tiny, tiny, tiny little dot. Okay, you can barely see it because the angular size is so small due to perspective. Now, the ISS. Okay, so just imagine that jumbo jet. Okay, imagine if that jumbo jet was double the distance away. You wouldn't be able to see it at all. The angular size would be way too small to be able to see. Okay, that's just at 12 miles. At 12 miles, or even 10 miles, you wouldn't be able to see a jumbo jet, which is the size of the ISS. You're
Yeah,
claiming
but
that you
these
can see something with your naked eye that's 250 miles up in the air.
who told you that we can see with a naked eye?
Because everyone. I mean, I've gone out when it's.
Nobody
I've seen.
said.
No, I've
Nobody
seen it.
said you can see ISS with your naked eye.
Yeah, you can, and I've seen it
What you mean?
twice
Yeah,
with my
you can.
naked
You
eye.
cannot see it.
Yeah, they say the ISS is going to go over
Nah.
you, bro. I've seen it myself. I swear on my life. Okay.
You seen ISS?
No, I've seen a light go across the sky that they tell me is the ISS. So they say the ISS is going to be coming over at this particular time. I go outside and I watch a little light go across the sky. Right when they say it, it's going to go across the sky.
Mm-hmm.
Okay, with the naked eye. So
yeah.
Tons of people have seen that. Okay, what is it? How high is it? How fast is it going? Those things we can't confirm. Sorry, Says who you.
Okay, but it don't matter. But it's up in the air. Yeah, let's say it's on the same altitude as a plane. Yeah, but what is it propelled by? We know what a plane propels by. Can you tell me what ISS?
I don't know what it is. We can't
But
confirm
listen,
that.
every single human can follow it, and it will go directly just over their head, just like it went over your head, and that means that it's constantly in the air. Yeah, if we just keep like tracking it with humans, you know, if we gave humans the task to do,
No problem. So tell us, what's it being propelled by?
It's orbiting the Earth, but
Yeah,
and
I'm
there's
asking
no
you what it's being propelled
counter-argument
by.
for
I'm
you
not
guys.
asking about. Sorry, I just need you to tell me what it's being propelled by.
orbiting around the Earth. It's orbiting.
Orbiting is not propulsion. Orbiting is a
Yeah, but
description.
I'm
What is it
telling
being
you,
propelled by?
I'd never said it was propelled by anything.
So it's not being propelled, but you asked us what it's being propelled by. Why would
Yeah,
you ask that
because you
question?
guys don't believe in orbits and the gravity pull and shit.
No, we didn't say anything about not believing in orbits. You would have to describe to us what it is, give us the distance of the object, how it's moving, all the
For the sake
propulsion and
of
all that stuff.
for the sake of argument, you know what, we've been over this, and you guys know what a gravity pull of Earth is and how orbits are described. You know, the most popular definition.
Yeah.
Yeah.
Yeah,
So let's
we
go
know the
with that.
story. So
Yeah,
let's go
yeah,
with
the
the
story.
story. You just need to prove any of that. Go ahead.
Yeah, I'm not talking about proving it. I'm just asking for your guys'
Oh.
opinion on it.
Well, if you make a claim but you don't provide any evidence for the claim, we can dismiss it. We don't have to talk about anything.
I didn't say any claim. I'm asking
So
your
you don't
guys'
actually
opinion.
claim, you don't claim, or you don't believe the claim that there's a object roughly the size of a commercial airliner orbiting a sphere Earth. You don't claim to ascribe to that.
It says who? I'm here to ask your guys' opinion on it. Yeah.
Great. So you're just going to ignore what I just asked you.
You're
Why
gonna
is it
ignore
so
what
hard
I asked
to
you.
answer the question? What did you
You
ask me?
ignored
I'm
what
asking
I
you a
asked you,
question
man.
about the story that you just gave me. You gave me the story. I'm asking if you believe it, if you ascribe to that claim. You won't answer the question. Strange.
What are you talking about? I came in here just to ask this question, and you still didn't answer.
What is our opinion of the claim? The claim sucks. It violates natural law, and there's no evidence for it. So we can just dismiss it. That's our opinion. Is that good enough for you?
That's not my question. My question is, in your opinion, what is ISS propelled by if it doesn't orbit the Earth?
I didn't say it was propelled by anything. Do you think it's propelled by something?
No, but how does it move then, in your opinion?
Oh, I
How
have no
does it move?
idea. I
You
don't have
have
an
no
opinion about it.
opinion.
I don't even know
No
what it
opinion.
is.
You don't know what it is?
No. Do you know what it is?
It's a space station.
It's a space station. Okay, great. What's a
Yeah.
space station?
It's a station in space that astronauts use. Come on, man. Come on, man. You can. Somebody said something in the chat a few days ago. Like, you guys argue from like a negative standpoint or something like that. That's very true. You know, you
It's
guys
not a
like
negative standpoint. You're making a claim. I'm asking you for evidence of said claim.
But
It's the way everybody should operate, don't you
you're
think? We shouldn't just automatically believe things all of a sudden when we hear them, do we? Like Santa Claus? You think we should believe that?
But there's difference between Santa Claus. Santa Claus, everybody agrees that it's fake, but everybody
That's not
agrees
true.
ISS
That's not
is real.
true. That's not true. There's millions of kids around the earth that think that
Yeah,
Santa Claus is real.
exactly. Millions of kids. And
Yeah.
you going to take a
Yeah.
little kid's word?
I'm not taking their word for it. I'm just telling you they believe that.
Yeah, most learned and reasonable adults, yeah, agree. He ain't real.
Right. So they agree that Santa Claus isn't real because they haven't seen any evidence for it, and it's preposterous, just like the globe and the ISS. Although, for some reason, adults like you have decided to keep this fairy tale for reasons I can't explain. But that's your prerogative. If you want to believe in Space Santa Claus, you go right ahead.
I mean,
Dude, it's
some,
like,
some,
hold on, man. It's like Santa Claus for adults. This NASA nonsense.
yeah,
It really is. Most people just blindly believe in this stuff. They've never looked into it. They've never checked anything. They just blindly believe what they get told.
you
Just
know,
like the kids.
you guys are like argue from like a negative standpoint, because I've seen some there's different types of flat earthers. Like, you got that boy, even Witsit and Flatter Dave, they like prescribe to the flat disk theory. You know, they got the
No, they
flat earth.
don't.
Yeah, a Flatter Dave has like a disk
No, it doesn't.
earth.
He doesn't. No.
Yeah, he
Well,
does.
Flat
He
Earth
does.
Dave, yeah, he's talking about a map which he quite often
No,
says he
not no
doesn't
man.
think this is exactly what the Earth looks like.
No, he has like a model he shows in his debates.
No, he doesn't. I've
I
watched
can,
every single I've watched every
I
single one
can.
of I've watched every single one of his debates. He doesn't have a model. He brings up a GIF to show people what flat Earth is not. He brings up discs in space to say this is not what flat earthers think the flat Earth is.
Let me try to find it for you, DJ. My man.
Yeah.
Hold on.
Dude, I've been watching his interviews for years. I'm not the hugest fan of his, but I used to like his stuff. And I watched every single one of his interviews. Okay, and I know what he claims and what he doesn't claim. And same
I'll
with
find it.
Witsit. Same with
Hold on.
Witsit. He doesn't claim a disk in space either. No flat earthers claim a disk in space.
I love how in one debate, Flat Earth Dave is debating with some physicist about something, and Flat Earth Dave goes like, I never turn on my airplane mode when I get in a plane. Never.
Yeah, I remember him saying that. You know what that same physicist said in that debate?
What?
He said that refraction will only allow you to see 7 to 10% beyond the restraints of the globe. And if you can show me an observation beyond those restraints, beyond that limit, that would not be possible to be explained by refraction.
And
we've got hundreds of observations showing thousands of percent beyond that 7 to 10% that the physicist spoke about. Okay, so he said
that's
it'll
hearsay, DJ. That's hearsay.
no, that's him saying it. I've got the clips. I took the clips. I've got the clips right here. If you want the clips. It's not hearsay. Yeah, I heard him say it. I heard the physicist that you're talking about say that.
Let me give you the clip where Flat Earth Dave gives his like Flat Earth model. Hold on, man. I can't send pictures in here.
Send it to me in
They
Send
don't
it to me
like
in DM.
slang
Send it to me.
yapping.
Send it to me. I'll post it.
Yeah, I'll send it to you, man. It's a
Hi.
it's a YouTube clip.
Okay.
I'll
You
give you
can't post a link to a clip in the side chat?
Hi.
I can, and I can give you the minute. Wait.
Why can't you just post the link to the
Hold
clip in the
on,
side
I'll
chat?
post it. Give me a second.
It's because he's on his brand new sock account and he doesn't have image perms yet.
No, it's not a new account. It's I guess it is a new account in a way. Yeah.
Uh-huh. Anyway, what does Flat Earth Dave's azimuthal equidistant projection model have to do with what we were talking about?
I mean, what I wanted to talk about is your guys' opinion on how this, the satellites move, but you don't have an opinion, so we're going
What
to
satellites?
another topic. Well, ISS, for example.
Oh, is the ISS a satellite?
Yeah.
We're back to Santa Claus, huh? Okay, well, prove any of that story. I'll wait.
And like satellite, and like the moon, a satellite also.
Okay, just prove any of it, man. Go ahead.
Yeah, I'm just saying.
You're just saying it, so you're not believing it. You're asking our opinion about it. Oh, well, there's
Yeah, I'm
no
asking
evidence
your
for it.
opinion, and
There
I
you
don't
go.
wanna, huh?
There's no evidence for it.
No, I mean there is evidence, but I don't want to get into debate with you fellas.
Yeah, you don't want to get into the nitty gritty of the details of the evidence. That wouldn't make any sense.
No, but we've been over it. We've been over it.
Right. Right. And at the end of the day, what do you say? It all comes down to refraction?
Yeah. our debate always comes down to like the curvature and what we can see, and we can say as globetrotters, we can say like what you see like is a reflection, and you guys say nah, it ain't, and that's the bottom line.
Well, let's go this way. Let's say it is refraction. Then the geometry that you're claiming can't actually be determined, so you're still screwed.
What?
Yeah, because if you use refraction as your position for the observation that we're making, and saying that what we're perceiving is not geometric and can't be measured because the light is bending or doing whatever when it's refracting, well, then no measurements can be taken, and therefore you're stuck with the axiomatic principle that the Earth is flat and stationary as experienced by everyone.
No, because we got other things.
Pictures from space. Yep.
Yeah.
How did you verify those? How did you verify them?
How did I verify? So basically, with that logic, you cannot verify anything you see online. Yeah.
Yeah, you
Great.
can.
I'm glad we agree.
You cannot verify this Discord room. You guys may be like paid government informants,
Is this
I can't
Discord
believe
room
the government
like a physical
satellites, your
thing?
imagery, nothing is real. That's what you're saying, bro.
I
If
love
I
that.
can't trust the government satellite pictures from space, then I can't prove anything. I can't even prove I'm real.
Yeah, if the
Yeah,
government doesn't tell me.
it's an all or nothing fallacy, right? So we say a very specific case that we don't have the means to go to this fairy tale place called outer space, and he turns that into, well, then I guess we can't verify anything because of the one specific example that you brought up. That's ridiculous, gunslinger. Come on, man, you know better than that.
Who watched my video that I sent?
Yeah, I watched it. I was just watching it then. So yeah, he's not saying that the Earth is a disk in space. He's showing you a like a graphic showing how he thinks the toroidal field works around the Earth. Okay, kind of like if you look up like a magnet toroidal field and hit images on Google. Okay, it's going to show you an illustration of say a ring magnet or a bar magnet, and it's going to show you how the electric field goes around it. That doesn't mean that they're claiming a magnet in space. Okay, it's just like an illustration. And I'm not defending Flat Earth Dave. I'm just telling you that what you said is incorrect. I disagree with a lot of things that Dave says, and some things that
Like
Whitson
what?
says as well. Well, the AE map, okay, that he's presenting. I don't agree that the AE map, right? I don't agree the outer, like a lot of the things that he sort of claims as, well, sometimes he forgets to say it's speculation. I don't use those arguments. He's got some arguments that are bad arguments that I think he even knows are bad arguments. But he still presents them because they're part of his script. I don't know. But yeah, I just told you that some things that I disagree with. I don't like some of the crazy maps that he brings up of the outer lands and things like that. Yeah, that's dumb.
The outer lands.
Yeah, it's all speculation. So quite often he does say he's just speculating, but half the time he forgets, which annoys me.
What about that final experiment shit? What you think about that?
Well, I was expecting for them to see a 24-hour sun. I mean, there was time lapses that I couldn't find any holes in before they went there. So, I mean, I wasn't shocked when they saw that.
So how does that happen on a flat plane?
Well, how does the sky work in general?
Yeah. So you're saying it depends.
How does flat water work on a globe?
So you're saying since we don't know how, like, we don't know actually how the sun moves, so
You don't know what it is. You don't know what it is that you're looking
yeah,
at in the
yeah,
sky.
yeah,
You're
yeah, yeah.
seeing. Well, this is what I would claim. Okay, so we have two apparent points of rotation in the sky. That's what we observe. Okay, and then we have to take all sorts of things into account, like what we don't know, what medium it's in, how it works, what's the structure of the sky, and you have to factor it in with perspective, and then a whole bunch of potential completely unknown factors that we don't know anything about. Okay, so we don't know how the sky works. We shouldn't claim to know how the sky works, but we can confirm that whatever's happening above the Earth is happening above a flat surface that we continuously measure to be flat over and over and over again. And there's not one observation or test that shows that it is actually curving. So whatever's happening in the sky is happening above a flat plane. That's where I'm at.
The question also. Is there actually a measure of the flat Earth? Like, can you measure the square meters of flat Earth?
How many meters?
Yeah.
Yeah, like measurements, like if you look up the definition of what a measurement is, I mean, you don't have to get a tape measure or a ruler to do a measurement. It's different ways of doing measurements.
The ultimate extent and size of the Earth itself is unknown. There's no way for us to know how big it is in reality.
Why not?
There's no way for us to know every inch of the Earth, which way it extends, how far it extends. We don't have that ability.
To flight from one place to another by plane.
You realize there are places on Earth where you can't land a plane.
I know that there is places that you can go from Europe to New York and go from New York to Siberia and go from Siberia to Europe
Right.
and go around
Those
the
are
globe.
what we call the known lands. What about the places that we don't know about?
Like what? Amazon.
Well, I mean, the farther that you go south, right? There seems to be a problem where it's going to be really difficult for you to independently explore that region on your own. Very expensive and basically prohibitive. So, although people would like to go and explore these places, it is prohibited.
I have a question. Where does this dome or atmosphere start? It starts from the ice wall and then it goes on the entire Earth?
Sorry, what dome?
The atmosphere, the...
What ice wall?
The circle. What do you mean, what ice wall?
I don't know what ice wall you're talking about.
You're not a flat earther?
No, that has
Yeah,
nothing
we
to do with flat
don't-
Earth. The ice
claim
wall
the
is a
ice wall.
term that was coined by the United States military, but we don't claim any ice walls.
What about the ice wall that is filmed?
That's filmed?
people
Are you
call-
talking
that
about the
people call
coastline of
Antarctica.
Antarctica where there's
Yeah.
yeah, okay, so there's a large ice shelf bordering the continent or whatever Antarctica is. I mean, that's not my claim,
Okay.
that's just observed.
So do you believe in atmosphere?
What is atmosphere?
I already asked you if you believe in it.
I don't even know what it is. What you're saying is air sphere.
Okay, you
So,
already know
what is an air sphere?
You already know what I want from you. That's
No,
why you
actually
really
don't.
want
You
to
need to tell me what you
Yes, I
mean
already
by
asked.
air sphere. What is an air sphere?
Yeah, you already know what I'm asking. So this
No, I don't. Dude, bro, you can't divine my thoughts. I actually don't know what you're talking about. When you say air sphere, what air sphere are you talking about?
Like a bubble?
Yeah, this bubble, where does it start? Is it just on Earth or is it when you go beyond
What
Earth,
bubble?
there's one bigger and then one bigger, like one egg, one bigger egg, one bigger egg, and so on.
Bro, relax. Bubbles in the water?
Yeah, you know what I'm talking about. You just don't know the answer.
I have no idea. Honestly, if you're talking about an air sphere, I have seen sphere-shaped bubbles in the water before. Is that what you're talking about?
Sure, bro.
Dude, I think
Okay,
you're
so
talking
in the
about
water.
like.
Oh, yeah.
Sorry, Sesu. I mean, this guy's talking about those like depictions of the Earth system where you have like different layers of heaven and things like that, like those kind of. Yeah.
Oh, not that. The gravity, the dome that's on top of
What
flat Earth.
dome, bro? What are you
He
saying?
is
Bubbles and
talking
bubbles.
about the fucking dome, you know, the fucking dome above the earth, you know,
Why is he
like
saying
this
he's
is
saying
this and
bubbles
you
in
have a dome.
bubbles? He's saying bubbles
What?
in bubbles and
Get
different
over that.
layers.
Get over that. Get over it. The bubble.
He's like
Okay,
a
but
rookie.
The dome.
Yeah, I know, and you're not helping anything out. So shut the hell up.
Okay, so look in the
Anyways.
chat. Look in the side chat.
Yeah.
Okay,
Can
I'll
you
look
see
in the
this
side
GIF?
chat.
I'm not allowed to post videos, share my screen. Not allowed to do anything in this shit server. Just click this link right now.
Okay.
Everyone, click this link.
Yeah.
You've been
So that's
infected
I see
by the speculation, flat
Okay,
earthers. You're
so
not
this
in
dome,
that kind of
is it
room
just
anymore.
on this Earth,
We
this
don't
dome? What
speculate
happens
in
if you
here.
go beyond the ice? What
Bro.
happens when you go beyond the ice?
This is somebody else's conceptualization of the Earth. Do you think that we claim this thing that you posted?
Yeah, you don't?
We don't.
Why do
We
you
don't
think
claim
that? Why would you assume that we claim that?
Because all flat earthers believe this.
No, we don't. Why would you say that all flat earthers believe this thing? That's a very irresponsible thing for you to say.
Okay,
How would
so
you
what
know
do you
every
believe?
flat earther believes in that idea? How would you know that?
From debates, I watched like 100 debates. Okay, what
You
do you
watched
believe?
100 debates. Terrific. So, in the 100 debates that you watched, how many different people did you see? Was it 100 different people? Or was it a handful of people 100 different times? Are they going to be every flat earther? No.
Okay, what do you believe then?
Oh, I don't believe anything. The earth is measured flat. No, that was easy. Okay.
So what you is he still here? Is this
Okay,
guy
so
gone?
then why are
He's still here.
some
Hold on, bro. 1 second. 1 second. Okay, so
why are
that's
some
what you posted. What you posted is kind of like a biblical depiction of flat Earth in a sense. Okay, we're not claiming that. That's what it says in religious texts. We're not
Okay, then why are some rainbows smaller than others, even though they are all on water or in humidity? Some are way taller. Why? If you don't believe there is a dome or atmosphere, how come some rainbows are taller and ones are smaller, like the ones in Australia are smaller? I assume because of this dome. So if you don't believe in this dome, how come some rainbows are taller, way bigger?
Well, I don't know, bro. The thing is, I lived in Australia most of my life, and now I live in Europe, and the rainbows look just the same. That's what I never noticed any difference when I see rainbows here or when I saw rainbows when I was in Australia.
He was paid to say that he moved to Europe specifically to be able to say that rainbows are the same.
So you
Well,
don't
that's
know
the
that
end of
some.
Gunslinger.
So you don't know that some rainbows are bigger than other rainbows.
I've seen a range of different rainbows, and I've heard the theory that when you go further south, rainbows are more like they're not as high, not as rounded, but maybe people are cherry picking pictures. I'm not sure. When I was in Australia, I noticed rainbows just looking the same as what they look here in Europe. Also, rainbows are circles. Like if you go up above a rainbow, it's a circle.
One thing that might help you out in this discussion is instead of just thinking that the people in this particular channel, in this server, that are flat earthers, they don't necessarily believe anything that you've seen on TikTok or YouTube. Those people make their own conclusions. They speculate about what they believe. This is an entirely different environment, different people. You're going to have to be more specific about what we actually are claiming.
Says who? You said that you in this topic it's 11 years. Do you have some physical representation or description of how the Earth look like what the borders of the Earth?
No, there's no way to know where the borders of the Earth actually are. I mean, unless we actually got to that place, but I don't know in which direction we should go to find them.
I up to you, baby. I don't mind. I can make
Hot
it
mic,
for you.
DJ. Cool. Yeah, no, there's no way for me to know which direction I should go to find the limit of this place.
Oh. Thank you for discussion. I actually think that I improved a little bit for 1% my English. Thank you for that and for ideas that you gave me. Yeah, and you're great. You
Hey man,
very
thanks for coming by. Yeah. Thanks for coming by. I mean, thanks for being, reasonable and chill and asking good questions and having a good conversation. Please come back and and I think your English is pretty decent. The more you do it, the more you'll learn. So, but it sounds good. You're doing well.
Thank you. Actually, had English exam today, and I got the D from that, and I think that I had to improve it some way. So it was my resolution of this problem, kind of.
Yeah.
Thank you for that.
Well, if you find this topic interesting, come back anytime. Keep practicing. Practice makes perfect. But you're always welcome.
Okay. Thank you. Bye.
Yep. Have a good one. Bye.
Where is the... Why does air get thinner on mountains? What? The air gets thinner on mountains. Why? If there
Because
is no atmosphere.
because
Where
it's
it locks up.
it gets colder up. There's a lower pressure, right, when it's colder, and also all of the air, all of the gases that make up the air are produced down low at ground level. Like 80% of the oxygen is produced under the ocean by ocean plankton. Okay, and then we have the nitrogen cycles and all of that sort of thing. So over 99% of all of the gases that make up the air are constantly being produced and distributed from the ground. And then it gets really cold as you get up higher. When gas particles cool down, they move much slower. You're going to have a much lower pressure.
Okay, then how come a cold refrigerator is still full of air?
It's still full of air, but the particles, like the gas molecules, are going to be moving at a slower rate. Like you can't stop a gas particle moving, but you can speed it up or slow it down by changing the temperature.
Can you repeat?
You can't. Gas particles move because of kinetic energy. So when you give any heat to a gas particle, it's going to move due to kinetic energy. And when you heat them up, they're going to move faster. And when you cool them down, they're going to move slower. Like if you get a balloon and it has a certain amount of air in it, if you cool down the balloon, it's going to shrink really small. And then if you heat up that balloon, it's going to get really big. Same amount of gas.
So then shouldn't the cold air on the mountains be thicker? I mean, be the thickest and most pressurized.
No, because there's also less as well. And it's also you don't have it in a balloon either. That's the difference. It was probably a bad analogy for me to bring up the balloon thing. Like, I don't know, this may be a bad analogy as well, but if you just say you're boiling water on the stove, okay, and you've got much more, like it's constantly it's distributing steam. Okay, obviously there's going to be much more steam where it's being distributed, and then it's going to thin out as it goes upward. Like there's going to be less and less.
But if there is no dome and no gravity and no atmosphere, what stops these high energy hot particles from just flying away forever?
Well, because we're not in space, we're not in a vacuum of space. That's actually what would happen on the globe. If we had a globe and we had a space vacuum, and then you had, gas particles. Gas particles are going to try to fill the available space. Like if you get a car tire and you pop the car tire, the high pressure inside the car tire is going to violently rush out of the car tire to try to fill the available space. The high pressure is going to go to the low pressure so it can get into equilibrium. It will try to fill the available space. That's what gases do. They fill spaces. And if gravity, they say gravity's acting as the container and it's holding the gas particles to how are the gas particles, like gravity's strongest at ground level. Well, the strongest that we can access is the gravity at ground level if the Earth were a globe. Okay, so that's where the gas particles are being created. And if they're being pulled down, how are they getting up? How are they going up, 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 up? to even get to the top of the mountain. And gas particles themselves, they don't have a directional bias. Like, they don't have a downward bias. If there's a gas particle and it's shooting upward, it doesn't get pulled back down to the earth by gravity and stick to the ground. That doesn't happen. Gas particles move at random in all directions. It's in the gas particle movement definition.
What do you mean that we are not in a vacuum of space? What do you mean by that?
Well, that's the heliocentric concept of that we live in a big giant space vacuum. Okay, so you've got this big giant vacuum. Okay, that they say outer space, that's a vacuum. They say it's 10 to the negative 17 torr vacuum in deep space. And then we've got all of these balls of plasma gas and planets and stuff orbiting around inside this big giant vacuum. And one of those planets is meant to be Earth, which is a big ball that's covered in water, mostly, and then gas, a layer of gas around the outside, which is what we're breathing right now.
Okay, so then what is out there?
I have no idea how, I have no idea how
Just
the
air?
sky works. Well, as far as we can validate, it's just air. I mean, it's sky. I would just call it the sky.
It's more air.
And then I would say that we can only get up to a certain height. So we can only get up to the height of a commercial plane, or we could send up a weather balloon to 120,000 feet. But we can't get any higher than that. So we can't really check exactly how the sky works beyond that. We have to start relying on speculation, basically. But the fact that we have gas pressure, it's very, very strong evidence that we would have to have a container, be in a contained system of some kind. Exactly how that works, I have no idea. But as far as we can test on a smaller scale, to have gas pressure, you must have a container. And it's even in the definition of gas pressure. It's the force exerted on the walls of the container by the gas particles. That's the definition of gas pressure. So it's like the necessary antecedent, which is like the requirement to have something. You have to have a container to have gas pressure. As far as we can test on a smaller scale. That's why you always need a container if you want to have any pressure higher than the air pressure that we're breathing. If you want to have something above 14.7 psi, you're going to need a container, like a balloon or a car tire or something like that.
But if it's just air out there, just more air, what stops that from just crushing us? If it's just air forever, and there's no dome, no gravity to have a limit on
I
the amount
never
of air.
said there's not a dome. I said I don't claim that there's a dome. There could be some kind of container that's dome shaped for all we know. It's
you
in
tend to believe there
of
is a dome?
I have no idea. I would just be speculating. I think it's interesting that all of the ancient cultures all depicted the same kind of thing, like a big dome type of container over the earth. I think that's interesting, but it's not proof of anything.
I think it's likely that there is a dome if the earth is flat.
Yeah, it's like logical. I mean, to be able to contain the pressure, there could be something like that. But
yeah, so
what is it made out of? How does it work? It could be something beyond our comprehension.
But then my question would be, if there was a dome, if the earth is flat, and we just keep going, like Or maybe it's not a dome. Maybe it's like just like a ceiling. Maybe just a ceiling that just keeps going or something. But then
Sure.
No way.
then that would also be like too much air, too heavy. So I don't know. Like if there is a dome for this what we have here for these continents, then what happens when you go beyond the ice? Is there another dome, or is there a bigger dome on top of this one? You know what I mean?
There's no way to know that ultimately. I mean, the reason that we don't use the word dome is because it implies kind of a shape, right? Like a large arced hemispherical type shape. And we have no idea if that's what it really looks like or what it's made of or any of that stuff. What we do have is gas pressure. And so there must be some kind of container. What it's made of, what it looks like, how high it is, how far it goes, we actually don't know. Where we'd find the limit of the realm that we're on, I don't know which direction to go to find that.
Earth looks like a D.
Great. So we have mature people that have joined the chat. Good job. Your parents must be really proud.
Hello, fellas.
So
How's it going?
anyway, yeah.
Fuck.
Yeah. So anyways, we're not going to try to speculate about those sorts of things, but we have contained gas because we have pressure. That's almost guaranteed. And then we have water that's contained. So there has to be a limit for all these things to stay within the realm. I don't know where that is. And that's just us being honest.
Sorry, you said that you don't know what is.
We don't know if it's a dome shape or anything like that. Hemispherical, we have no idea. We don't know how high it is, but we have gas pressure, so the gas must be contained by something. That's the best that we can
so
say.
there is something that contains the gas. If there is something else beyond the ice, maybe there's another thing that contains the gas there, like another dome or something. Whatever.
Well, here's the interesting part.
Whatever.
So, sadly, the idea of the AE map, the circular azimuthal equidistant map that people use, especially flat earthers that are pretty irresponsible, people are implying that the limit or the outer regions of the realm is beyond the ice. I don't even know if that's true. I couldn't say for sure if that's the direction that we should go to find the edge or the limit or whatever you want to call it. So we really don't know. And we're just as frustrated not to have the answers. We would like to have the answers, right? But some of those things are beyond our grasp. So we do with what we can actually test or observe or measure or any of that stuff with what we have at our disposal. Well, we do have the Earth itself at our disposal. So we can check it. We can test it. We can measure it. And it measures flat. And we treat it that way for everything. That's everybody's experience. That's what we know. As far as the dome, as far as the limits of the realm, no way to really determine that. So we don't make a lot of claims about it. Some people do, and they get themselves in all trouble making claims that they don't have evidence for. We try to avoid that here.
I have seen recently some videos of flat earthers flying over the ice wall, but they never. They just show like 1 minute. They never keep going, or I don't know.
Yeah, Antarctica is a place that people can visit. There are cruises, Carnival cruises that will go down there, and you can go and visit a ceremonial South Pole, and those are things that people can pull
down
off.
there.
But yeah, I mean, it's just a habit, right? Down there, out there, whatever, over there. So over there, wherever that is, people can go there. They can take a cruise. But at the end of the day, I don't know if that's where the limit of the realm is. Although it is interesting, and that's all I can say, it's interesting that there is a very, there's a concerted effort to keep people from exploring that place. So unless you have a ton of money, and also that you have clearance from at least 50 governments, there are more now in the Antarctic Treaty, you have to have permission from all of these different nations and a lot of money, and you can't take much with you. You can't bring huskies or malamutes to pull a sled. You can't take fuel. You can't go very far. So these are all things that are prohibited by the nations that decided that you can't go too far into Antarctica. Why? I don't really know. I just think it's interesting, though.
Says, who are you, an American?
No.
Oh, okay. I was going to say, if you
What's an
weren't,
American?
or are you a U.S.
What's an
citizen? Apology.
No.
Apologies.
What's a
Yeah,
U.S.
I was
citizen?
going to say, holding a U.S. passport and having a U.S. birth certificate, having all the rights that are granted to you by being born on U.S. soil or to U.S. parents. No, the reason I ask is if you want to go work at McMurdo Station, at the quote unquote South Pole, there's a bunch of like technician and like sort of like trade jobs. Like they have a janitor down there, they have a bartender, like there's places you can apply for a job there that don't require a clearance at all, because the organization itself was given clearance to operate at McMurdo.
Okay, what does that have anything to do with what I was talking about?
Well, you're saying that it's limited to explore that region of the realm. So the cruises don't actually go to the quote unquote ceremonial South Pole, because McMurdo Station is actually at the South Pole. So if you wanted to, I'm just saying, if you want to go there, you don't need to jump through all those hoops.
So McMurdo Station is at 0 degrees south.
90 degrees south, but not 0. But yeah, same thing.
It's at 90 degrees south.
Correct. Yeah, it's pretty close. They have the pole. They have to move it every couple of years because the ice shelf it's sitting on top of shifts. But they move the geographic South Pole and the magnetic South Pole, marker every few years. But yeah, no, it's right in the middle of what the globe claims to be Antarctica. What I find really interesting about that is that the star paths, like if you take a long exposure, close buddy of mine wintered over there at McMurdo like 2 years ago. He's a satellite ground station technician. We went to school together. But if you take like a long exposure photograph, you get the same sort of star trails you'd get at McMurdo as you would from close to like the Arctic Circle or close to the North Pole, where the stars seem to be going around above your head in concentric circles. I find it interesting that there's celestial symmetry between McMurdo Station and the North Pole.
Says
Cool. Yeah, so I think and maybe Seisu was busy or something, but yeah, Seisu wasn't saying that you can't go to Antarctica. Okay, going to a designated base or something like that is completely different to just being able to go and explore the place. Okay, he was saying it's an extremely hostile environment, and also to go and freely explore the place beyond the designated little places that
yeah,
you
you
can
can go
actually
visit,
go
but
to. Yeah, you can't just like there was a Navy SEAL just last year, or not long ago. Okay, he wanted to just go and drag a sled across a little section of Antarctica, and he had to raise over $1 million because of the conditions to the permit. He had to pay hundreds of thousands of dollars to have all of these safety teams on standby. He had to tell them exactly where he was going to be at every moment. And there was a whole bunch of conditions. He made a whole bunch of videos explaining how difficult the process was and how expensive it was. I think he raised like $1.2 million just to cover all of the expenses. So yeah, it's not easy to just go and freely explore beyond 60 degrees south.
Oh yeah, no, I agree with
In the
that.
side
Like,
chat, hold on a second. In the side chat, I've got an image where McMurdo Station is. That's not 0 degrees or 90 degrees south, Josh.
sorry, I was referring to Amundsen, not McMurdo. McMurdo's on the coast. I got them mixed up. It's Amundsen, Scott, South Pole base. It's the like 4 or 5 buildings that are on skis. Apologies.
Says, do you believe there is a creator?
Who are you directing that towards?
Says who?
Yes.
And do you believe this life is not this life? Do you believe this is an experiment? This Earth?
An experiment? I don't know about that. That's kind of that particular term, experiment, is a little bit loaded. Do I think that there is a creator being that is, running a giant ant farm? No.
It looks like it. Looks like an experiment. But this is maybe this is another discussion about hard determinism. That's what I believe. Since I started eating healthier and living healthier and stuff, I feel like I'm thinking better, and I think that's why I started to believe and started to understand causation of everything. And I think that I tend to believe now that this our life here is an experiment. Like we are created by God, and like everything was created by a creator, and to see how it plays out or something like that, to see where it goes. Like, for example, one of the reasons why I believe there's a creator, or tend to believe at least, is because we have these like unbelievable powers like memory. Like we remember pretty much everything. And when someone does something bad, someone does a mistake, people talk and they discuss, and people learn not to do it, and they learn the effects. Like to have like better society, They achieve the truth after all. Like this is what we're doing as humans. We're just discovering more truth day by day. Like, for example, before we used to throw people in the volcano because we thought this is what's gonna bring us rain for the crops. But we realized that wasn't true. And maybe this is why this voice chat exists here right now. about this subject, right? With the rise of the flat earth debate, we're also learning about the moon landing hoax and about corruption and about NASA. And maybe we'll learn if the earth is flat or a globe after all, with the occasion of this debate. But you see what I mean? Like, even these subjects here, like people are here to learn English in this server, but at the same time, people want to talk about these things, philosophy, veganism, you know, flat Earth. People are at this point in history, at this point in the movie, at this point in the story of humanity, people are interested in this subject right now.
Yeah, absolutely, man.
So the fact that there is a voice chat here about flat earth means that people haven't concluded, but people started asking questions. Before, people didn't ask questions. People said, oh, the earth is just a globe. But people have started to ask questions, and that's why we have this channel here. In the future, there is no longer going to be this voice chat here because it's going to be concluded. It's going to be interesting to live to see that. Same with
Uh,
veganism.
I was gonna say I'd push back on that softly. I mean, we got like Samuel Robotham in the mid 1800s, with his level experiments, zeticism. Like this comes and goes in cycles. This conversation, so I wouldn't, I would push back on the fact that this conversation would cease. I'd expect it to continue for hundreds of years to come.
Well, the thing is, because I was thinking about that, but I think what makes the difference is there can still. So let's say we conclude that. Okay, so let's say there are debates, and some evidence is shown that is so powerful that, and we all see it, because if it's so powerful, all the entire humanity is gonna see it. It's gonna spread instantly because people have to see it. That's why it's gonna spread so fast. But
good point.
See, after they see that evidence that, let's say, proves that Earth is flat, then there's still going to be people arguing forever that the Earth is a globe, right? Or maybe not forever. But what makes the difference is that people no longer pay attention. People no longer pay attention. Right now, people are paying attention. You know what I mean?
I'd posit that people aren't paying attention. I think it's bias towards being in this conversation that you would think that people are paying attention. Like this is, objectively pretty fringe still.
I would say people are paying attention. I mean, it's like I see this debate here. There's debates on YouTube just recently, one from the channel Modern Day Debate, and I see people on social media talking about it a lot. It's definitely quite popular. I mean,
yeah.
everyone has heard of this concept, flat Earth. Everyone has heard, and even just today, I saw like some balloon experiment on Facebook Reels, and my colleague saw me. He was like 1 meter away. He didn't even see it properly. He just saw that, and he asked, "What is that?" Something about space. You like space? And I said, "Yeah." And his next question was, "You think the Earth is flat or a globe?" So this is just some random colleague. But the question that came to his mind is whether the Earth is flat or a globe.
Yeah. I just wanted to mention a couple of things. Like when Josh was saying that it comes in cycles or something like that. Back then, we didn't have the internet. Back then, we didn't have the type of equipment that we have now. But the internet's the main thing that's different. Now, when you see surveys being done, like random polls being done on the internet, the results are always even shocking to me how many people are doubting the globe. Even when they do mainstream surveys, apparently, if you look up just about any country, it comes to about 10% plus of the population don't think the Earth's a globe or think the Earth's flat. And
How
then
much?
another, well, 10% is a number that's pushed around often. If you look it up, most countries, if you type in 10% of blah, blah, blah country thinks the Earth is flat, pole or something like that, type in that as the search term, it'll come up with some studies that were done. So in America, for example, they say I think it was about 10% of the population didn't think the Earth was a globe, and another 9% were unsure. And then they did another. There were some other ones that had been done. Okay, and it depends where you do the surveys as well. But it's a popular topic. Whenever we get invited to a server, for example, this server, 350,000 members, we quickly shot up to number 1 position in the server, the most popular channel in the entire server. Same with the politics server. Okay, and when Flat Earth wasn't censored on YouTube, Flat Earth shot up to number 1 on YouTube as well back in 2015, 2016. These videos were getting millions of views and they had to censor it. They did a great job censoring it. And not only just censoring it, but replacing the information with a propaganda playlist to try to turn people away from the topic by mocking and ridiculing it with misinformation about Flat Earth. So, yeah.
Do you think the attention is derived from the actual topic itself, or a meta commentary on folks thinking that like the trolls that roll through here, right? Like I'd be interested in seeing how many folks tune in and listen to these conversations because they think it's absurd, rather than actually engage with the conversation itself.
Yeah, definitely. That's like a byproduct of the propaganda surrounding it. And they're expecting to hear something crazy when they tune in. Quite often we'll have someone will come in trolling. And then if they're willing to actually listen to what we, clearing up the misconceptions that they have about
Because
Flat
this
Earth,
is
and then
this is
pointing
the
out
impression they've got
yeah,
from
they've got
social media and
exactly.
news and
They think we're a bunch of tinfoil hat wearing people that think that Earth's a disk in space and all of these kinds of things. If they're willing to actually get through that and listen to the actual arguments, they quickly change their tune. Very quickly.
eventually they will. Eventually they will. But one thing I wanted to add, I don't know if you guys are gonna understand what I'm trying to say. I don't know exactly, but I'm trying my best to tell you what I believe. You know, the example I gave with my colleague, his first question came to mind, even though we're talking just about space. Randomly, he asked if I believe the Earth is flat or globe. It happened today, by the way. For me, this looks like humanity is interested in this subject, and it's as if there's like a bigger brain on top of us, you know, that we all are connected to it. It's not like that, but imagine it that way. So that's why the first question came to this guy's mind was this, because humans in general are interested in this topic right now. It's a popular topic. You know what I mean? It's like as if the humans, the minds of all humans are directed towards the same thing or the same things or the same subjects at the same time. You know what I mean? It's just basically I guess the meaning of the word popular when a lot of people are paying attention to a subject. Do you guys know what I'm trying to say?
Yeah, no, I know what you're trying to say for sure.
Yeah,
Also,
and
the censorship.
so why? Yeah.
Well, just quickly. Also, a lot of platforms have stopped the censorship of this topic as well, and YouTube has just joined with that. So now, when you type in a flat Earth video, it actually comes up on YouTube. Whereas for the last 5 years, or since 2016, actually, it hasn't come up. It'll come up with a propaganda playlist. Now people are being recommended flat Earth content again, and it's coming up in people's search results, and you've got all of these other platforms like TikTok and X where flat Earth content's getting hundreds of thousands of views. So we're seeing like a bit of a surge in the popularity of the topic at the moment due to the censorship getting much
Yeah, if it's
less.
censored, it becomes even more interesting. But if it's censored, people want to learn about it more. If it's being mocked, then that shows that it's kind of like you have no other weapon except trying to mock it.
I'm just gonna add something to the topic. So when COVID came over, right? If anybody says that COVID was BS or whatever, what happened to that person? He would be recruit. It will be demolished, basically, right? Or even if a doctor speak up or something, right? The same happens with the flutter topic, basically.
Yeah, we have slavery on this planet. That's what we have. We have hierarchy. Hierarchy decides. But what I wanted to say is, if you look at this, if you look at the existence of humans as a story, as a movie, as an experiment, right? Because that's how I look at things. If you look at it that way, and you look at the current situation, ask yourself, how come humanity is interested in this flat earth subject right now? There must be a reason. It looks like at this part of the movie, humans are figuring out that humans are figuring out the true shape of the earth. You know what I mean? So it's just a matter of time.
Yeah, I do get what you're saying, but at the same time, people are being fed up with too much lies, and that's why they are interested. At the same time, once in a while, they question themselves, and therefore, they have to, come to the truth.
Yeah, but how come all these governments are? Because like any politician can just say, okay, let's go investigate this, and they can send some military military planes. So how
Right.
come none of them do it?
Right. So the same way, I'm going to ask you this question: why, when COVID hit it, right? Why every single country in the world agree with the same BS?
Yeah, that's the same question. Yeah.
Exactly. Yeah.
So maybe
So you already have.
that would imply there's a secret world government, maybe an occult that people are talking about, like a family occult that has been existing for a long time and they control everything. Maybe this Epstein thing has something to do with it, where they move these politicians there to have something against them or something like that. I don't know, but there's definitely something weird. I mean, with these statues they had there. Have you seen the statues Epstein had on his island? All these some type of like Satanist stuff.
Epstein
Hey
for
guys,
me
hey
is
guys, just quickly, we're recorded on YouTube. We want to stay away from any topics that could be considered against TOS. So try to keep it on just on the flat Earth topic. Cheers.
Yeah, sure. So I'm just gonna add this to the person. I don't know his nickname. Epstein. It's just a distraction for me.
I don't think it's a distraction. I think it's something real.
That's your opinion, and I'm gonna respect it. That's all.
Jeremy, our deck Q066, you said you picked a side, huh? The guy asked you to pick a side and you did?
Is that question towards me?
That's right.
I don't know. I haven't looked enough into this subject, but the thing with the rainbow, I seen recently. Like I saved it, but I can't find it now.
That was actually going to be my next question. Like, what are you going to look at, do you think?
Just
Like
whatever I'm
if somebody said
interested.
that if somebody said the moon is cheese, what would you look at to figure that out?
Well, whatever I can find, but well, first of all, I'm not gonna believe that. I'm not gonna research it because
Okay, if somebody said the Earth is flat, what are you going to look at?
just whatever I find interesting, I guess. Whatever curiosity I have. But so what I do is I come here in this voice chat. I listen to what people are talking, I engage with people, and I watch these flat earth debates pretty rarely, and I see some Facebook keeps recommending me these reels about flat earth, and from all of these things, if there's something if I have a question, if a question arises, I look it up on the internet and see what I find.
Save the Nash is like reality. Yeah, no, that's a good idea. But yeah, I mean, actually, it's not terrible to ask somebody like, what do you recommend for me to look into or whatever. But I wouldn't look to the thing that you had mentioned, saying I look to the debates for the answer. Like I wouldn't look to men for the answer.
I guess that's where I'm getting questions from. Like I'm watching these things and then I'm like, that's interesting, let's look it up, you know. But again, I haven't, like, I'm early stage with this, you know. So it looks pretty complicated though, by the way.
It's actually pretty simple, but we all start simple.
Not complicated, but complex, I guess.
No, it's so simple. It's stupid. It is so simple.
But I remember for a long time, even when I was a child, but even now, even recently, because I looked at your profile picture, it reminded me of that. I've always wondered, how come they know that there's like this it's like big lava ball inside the earth, you know?
It has to be, they'll say.
Hmm?
Because there just has to be. It would be like some inference based on another presupposition. Yeah, they don't know. They don't know though. That's the truth. They're not even close to knowing.
Yeah, like a lot of things we're being told. It's like, especially, I think most of the things in life that we feel like it's like I feel at least that are just ridiculous. I've always felt that. I think now are probably things about space. Like when they say like a planet is like, I don't know how many millions of miles away. How do you know this? How can you calculate that? That's like, I've always felt like that's impossible to calculate.
I mean, that's all true. Listen, these guys are smart. Like these guys are the absolute like smartest people who ever lived, who came up with this idea. But it's stupid. Like they're gonna have great math. They're gonna have great relationship between dots, planets and stars and angles, and they're gonna have it all, quantified into a nice little bundle for you. And it's like, wow, what can you do? Like, who are you to, be able to figure out anything? But they haven't figured anything out. Nothing real.
nothing you can't touch an angle, or a distance. That's not a real thing that they figured out. And they'll tell you. I mean, it's not a secret. They'll tell you how they figured it out, or they'll tell you
But
the claim.
one thing that was like the most interesting to me was that I think someone from here recommended it to me. It was a video from some guy in Hawaii. He films one Hawaii island from Oahu or whatever it's called. It's like so far away, and he films it from ground level. And what he did is he put the. Do you know what I'm talking about?
I'm sure DJ does.
He put the entire globe on like something digital drawing, but with the exact measurements, and then he put the islands, like small islands, on the exact measurements, and he zoomed in a lot on this circle, and then you could clearly see as the earth curves that the island is just under the eyesight. Like you're not supposed to see it at all, but he sees the entire island very clearly. So that was like that moment when I saw that, I was like, wow. And it was so far away from how much they're saying we can see. And it's not like he was just seeing like only the top of the mountain or something. He was seeing like a lot of the island. And then I looked up what people were saying. They were saying, oh, it's from the reflection. I mean, that doesn't make any sense. What reflection? There's no mirror behind the island. Like, what reflection? So
Yeah, they want you to believe that everything's a mirage, and then there's videos and etc. of cars driving, like, and people waving at you when you're doing the test, like those are mirages. It's ridiculous. He waved right at me. I waved right back.
And so that was very interesting. The other thing I thought was interesting was like I said, the rainbow thing. I can't find it. I keep saving these reels on Facebook. They just disappear. I don't know why. Not just with this topic, a lot of them. Because like I keep watching a lot of the conspiracy stuff. But anyways, there's one rainbow in Australia that was very small, and they were showing the entirety of it. Okay, it was very small, but they were showing another rainbow in Vancouver, I believe, Canada. It was way bigger, way taller, and they were saying how it would make sense on a flat Earth because of the dome. So if the dome is like smaller at the, like in Australia or something, that would be why when the rainbow was smaller. And I think that actually made sense. That actually made sense for me.
Oh, yeah, maybe.
So, if it's a globe, it's still interesting to learn these things.
I mean, if it's a globe, it's interesting, but if it's a globe, it has consequences where you can't see Hawaii, so it can't be a globe.
Yeah.
Yeah, like you would think that one proof is all you need to prove to prove something. But apparently people require, like, the human psyche requires more than just one proof. But you would think that's all you need.
Well, my two biggest questions I have, perhaps I'll have bigger ones in the future. But I mean, I asked some people here, but it's not very engaging, let's say. So the one is so there's two things. One is the the stars go in one direction when you're at the so-called North Pole, but when you're in Antarctica, they go the opposite direction.
Yeah, you're gonna need an absolute like coordinate reference system to then denote direction. You're gonna have to establish some kind of framework to do that.
So that's one thing, and the other thing is about the there were some flat earth YouTubers who went to Antarctica, and they said I didn't understand exactly the entire thing. I didn't understand it, but maybe people here know. They were saying that at a particular hour the sun was not supposed to be up in the sky, and they were wrong. Do you know about this?
Yes, I do.
Okay, so what is that all about? I'm very curious.
Why would they
about
say that though? That's the question.
Like, what makes it
I
so
don't
that
know.
it's supposed
I
to
don't know.
do
They were
something?
saying that
What's
because
the
of their flat Earth model, the sun was supposed to be at a different place or something, but it was there.
There's the problem right there. Yeah, that's the problem. Flat Earth is not a model. It's not a model. So they're attempting to try and depict all of reality, right, and how the sun and stars and everything operate above it in accordance with some type of like map or ideology, right? That's not that's not our aim here. So it was
Okay,
their fault, their own fault for trying to say that the sun should or shouldn't do this based on something that they can't even prove, right? It
No,
was
I
their whole
mean
basis.
their belief is based on obviously the sun is moving, so sometimes it's dark, sometimes it's sunny, right? So because they're saying like, oh, they're thinking, okay, like, you know what I mean? Like they were saying, if it's sunny right now in, let's say, if it's
Yeah, I
dark
get
right
it. I
now
get
in,
it.
let's
Yeah, I
say,
get it. I get it.
America, it should be
We
sunny
understand.
in Antarctica and the other way around, right, or something. But
But
they
what
didn't
they did
expect
was
that.
no different to what the Globers do, right? So present a model of reality from a perspective that they don't have and they'll never have, right? And say this is true, this is what's happening, this is how it all works, right? And then look for something in reality which confirms that bias, right? And that's what the flat earthers did, but they didn't find confirmation of their bias. They found something antithetical to that bias. Whereas we're not doing that. We're just saying, here, look at the measurements of the surface and the observations, right? It's flat. So any claim that it's a sphere, right, and that we live on the exterior of a sphere can't be true. But we're not saying on top of that, and this is how the sun works, and this is how seasons work, and this is how all this other stuff works, right? We're not doing that. Those flat earthers work.
get back here? I don't feel that good. I don't feel like holding this down. Where is he?
Okay, so like,
Yeah,
what other
that's just
stuff
like an affirming the consequence of a model, and the model. You know, again, like I asked it early as dawn, right? Like, what would you if I said the moon were cheese? What would you look at? You would look at the moon, right? If I said the Earth were flat, why would you look at the sun? It seems wrong. Like do you think like that's kind of like the proof thing that like if you have one proof, can something else disprove that proof, or can only if I have a table in my living room, the whole rest of the world not knowing what a table is, does that disprove that I have a table in my living room? Can something else disprove it?
No, you know what I mean with this something.
No, I know, but that's how they have a coordinate system, and they have a coordinate system that they use that they transform. I mean, what gives them their heading and direction? What is it that sets these directions? Uh, is it just the sun itself that tells them where east is? You know, so you have to look at see see what they're affirming, except and whatnot. But yeah, how could the sun how could the sun do this? How could the sun change what you know to be true on the earth? Is that possible?
So the thing is, if Antarctica is like an ice, what we call Antarctica is actually ice around the flat Earth, then a 24-hour sun in Antarctica would be or anywhere on this ice would be impossible, right?
Yeah, why would Antarctica be ice around the Earth?
No, what we call Antarctica is not Antarctica. This island at the bottom is actually ice around the Earth, right?
That's what I'm asking. Who told you that?
I'm asking you if you believe that.
No, not exactly.
Okay, so now we no longer believe there's ice.
Kind of like when somebody says, "Well, I believe that there's a dome." It's like, "Well, what's the reason you believe there's a dome?" Well, maybe I believe there's a dome because we have gas pressure. You know what I mean? But if somebody said like, "I believe that we have ice around the Earth, wherever that is," I would say, "Well, what's the reason for it?" And then the common sense reason is because I know for a fact that water requires containment, and the sun seems to heat up. It seems to be hot, so it just makes sense based on what I know is true. It doesn't mean it's the case. But it's like you kind of have to maybe follow that backwards and say, why am I even asserting there would be ice? Well, the reason I mean, there may or may not be ice, but the thing I know for sure is that large bodies of water at rest require lateral containment. So, or
Yeah,
maybe
this
you
is
think
what I
there's
was
ice
saying
for a different
before.
reason.
Because some flat earthers have gone beyond just the pure measurements of the surface of large bodies of water, right? Okay, so we've examined large bodies of water. The surface lays horizontally, right? It's not curving, right? So we can rule out that we live on the exterior of a sphere with a radius of 3,959 miles, right? As would be the crux and the foundation of the entire modern cosmological model, right? That they adhere to. Right? But some flat earthers go beyond that pure geometric claim and take it upon themselves and find themselves responsible for having to explain and give answers to other questions that aren't to do with the geometry of the surface necessarily. Like, how does the sky operate, right?
Yeah,
And
I think
how is all the land masses depicted? How are they configured, right? Where are they in relation to one another? Blah, 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 all this other stuff. We don't need to go there. All we need to do is just show people that the surface of large bodies of water is horizontal. And that's game over for the globe. There's no more argument after that for the globe. It's done. Don't have to
yeah,
present to you any sort of map or any kind of universal model, anything about how the sky works, nothing.
I
That's it.
think
Now, if you
I
want to
think
take it upon yourself to try and answer those questions, feel free. It's not
yeah,
my ambition.
yeah, I think the Hankelis who he are the one who know if the Earth is fate or like a ball or something like that. Yeah, I think so because the Earth is a plate, and me and them and Hankelis we know that, and you know that because of the reason of the created of the universe. We know that.
Earth is cube.
Who the fuck is that guy? Who the fuck is
See,
that?
Jeremy, this is what they do. This might be the reason for the globe is to separate you, like Jeremy, you and me and T Dub down there from I don't know what you can say from idiots. You know what I mean? The globe goes on one side, idiots, those who question globe, like you, me, and T Dub, on the other side.
Yeah, I agree in this point. I think that too. I think Jabbo, he was there. He do it. He and Hankelis, and they
Well, that's
What
right. They
do you
sorted
believe?
everybody out.
Yeah.
Hmm.
Yeah. So, what do you think?
I think in regards to what Jeremy and T-Dub were saying, that one thing that is true, such as a large body of water at rest requiring lateral containment, requiring the sides of the container to hold in the water, does not become untrue if Antarctica is not an ice wall. One thing doesn't become untrue. Something that's true doesn't become false because something else has its identity.
You don't believe there's an ice wall? What about these videos where they're showing this ice wall?
Yeah,
Is
there's
that
walls of
what is it?
ice. Yeah, I mean, there's definitely
Okay.
walls of ice. Yeah, for sure.
You believe it's around this earth, this wall ice?
I mean, it could be an ice wall around this earth somewhere. I don't know. I haven't verified that.
Someone here
I mean,
believes that?
there could be an ice wall around the Earth, which I haven't verified, and Antarctica can be a continent. Both of those things can be true.
Okay. Does someone here believe there is an ice wall around Earth?
The problem is he believes, but he doesn't have no evidence for it, right? He just believes in it. So just by saying that, it's like saying, "Well, I do believe that somebody's doing something, even though I don't know. I cannot see him doing something, right? But I'm gonna believe it. Just you know, that's not proof that it is, you know, all ice wall. You understand?
Interesting. So you're saying you guys don't know?
I never been there, so how can I tell, right? That everything around is all ice wall. I mean, I never been there, so I cannot say it is when I've never been there. It's like saying well, in Morocco or any other place around the world, it's like this when I never been there to verify that whatever somebody's saying it is true, right? If I've been there, if I watch or witness something, then I can say yes, that's the way it is because I've been there and I witnessed, right? But when I when I haven't been there, I cannot prove that that is the way it is because I don't have no ways to verify it unless somebody who lives there can prove it to me. Well, around here it is like this. Understand the difference?
Yeah, like, what do you think? I mean, I don't know if you want to respond, Jeremy.
No, that's fine.
Yeah, I'll just like it could be true, but right? Let's say it's true. How would you prove that it's true? Yeah, that's the only issue. It makes sense. Like I said earlier, like it makes sense. Like if I take the things I know to be true, I say, okay, water, large, everywhere I go, like a lake, a pond, a beach, the land is always higher than the water so that the water doesn't, move. Everywhere I go where the sun is, it's warm. So if I went away from the sun, it would be cold. What's things that are cold are frozen. So all of those things make sense. Doesn't mean it's the case, but it makes sense. Yeah,
What's that?
that's the. I didn't want to interrupt the magical moment there. It was beautiful.
Marvelous.
But yeah, that's what they gave. So like we were born, the day we were born, they put a mobile above your head, a mobile, saying here's everything, and we can explain everything for you, and we have a model for everything. And then when you remove pieces of that, you say, well, I want a replacement. I want a replacement for everything, right? So it's kind of tough. Like you initially you'll want a replacement.
Huh?
Well, it seems like you kind of dropped off, Jeremy. But yeah, no, I appreciate you looking into some things. But um, yeah, I don't know, my recommendation is to look into what you can prove, which is not as much as you might think.
Yeah, it's so interesting. I don't know what to say. I mean, if you don't know if there's an ice or wall or Antarctica is an island, this is a bit disappointing.
Well, the ice wall's weird because what's above the ice wall? Like, what if you just keep going up? Oh wait, no, I'm an idiot. Fuck. I'm thinking about space arguments, not flat Earth shit. I'm sorry. I'll shut up.
Oh, hold up. Excuse me. Who was that?
I am me, and me is I. And I is leaving. So is me.
I just posted an old map. It's called Euro map. A lot of us already know. You may not know. You take a look at this map and ask yourself how the hell they managed to create this map back in the days. If this map is really true at the same time, right?
You guys really let this guy down. You named the chat. Ask about the flat Earth, and nobody answered.
What was the question? Was it about the ice wall? I can answer that.
I knew you'd be the one.
Yeah, there is an ice wall. It does exist. So there you go. I mean, Antarctica is just land covered in ice. The ice is like 100 feet deep, or even thousands of feet deep. So I mean, obviously there's an ice wall because where the ocean meets the land, it's not land. It's a wall of ice. It's not some big mystery.
That's true. He even asked. He said, "Well, you don't believe the pictures of the ice wall?" I said, "No, those ones, yeah. Like there's pictures of a wall of ice,
Well,
yeah."
well, it happens in some areas in the north too, like around Alaska. Right? And they're actually worried because of climate change, blah blah blah. It's going to affect the ecosystem. Wildlife relies on the coming and going of of these glaciers, coastal glaciers, and these ice walls. Even in the media, these places are depicted as being ice walls. Right? But it's the configuration of the coastline of Antarctica that's in contention, not the existence of its coastline. There's some claims out there that are made, which I can't verify to be true, and they're made by both Globers and flat earthers alike, right? Such as if you go south, directly south from any starting location, right? Like choose Australia, choose Europe, choose Asia, anywhere, and go directly south, you will reach the coastline of Antarctica. That's a claim, and I don't know if it's true or not.
Yeah, isn't that claim also not exclusive to a globe?
Exactly. Right. That Eric DeBay makes that claim.
Right.
I'd like to know how he verified it.
And it wouldn't answer anything either way.
Yeah, it would answer some stuff.
Yeah, I was about to say, like, it would definitely give you more questions than you had before.
Right. Well, even if that's true, like, okay, so you go from the tip of South America and you reach a place, that's icy, and they say it's Antarctica, right? Okay. So now you leave the tip of South Africa and you go south, directly south, and you reach another icy area. How do you know that's Antarctica?
Right. Or how do you tell the difference between whether or not you are following lines of longitude that extend radially out from one point of origin, or if you're converging upon another point of origin along the same longitude?
Yeah, that's the thing it would answer.
Mm-hmm. That's a good one. Yeah, good point. Yeah, yeah. How are you determining what is south? Are you using stars, the sun, a compass, magnetic field lines? Like, what are you using? How are you determining which way is south? Because we know about magnetic field fluctuations and declinations, inclinations. The magnetic field map that you post, Yoda, that's pretty messed up. It's pretty
Right, isn't
wonkily
that?
donkly.
It's one of my favorite maps. So I got an interesting piece of insight. Not regarding that, but supposedly if you are under the equator, let's say you're under the equator, maybe you're biased a little to the north or to the south, just a bit. Let's say you could see basically on your right side, due right, you could see Polaris right on the horizon, hypothetically. You could travel west and keep going west, and Polaris will show no parallax, will not move.
Yeah, interesting. Yeah.
That's the claim. Right? So you could go whatever you want to call it, a great circle route, in which case the claim would be that you are curving down, or that you are going exactly 270 degrees west from 0 degrees latitude, and you are not turning at all. You're on a flat topology. Would Polaris not move the entire time?
Shut up!
And then you think about like the UTM maps, the Universal Transverse Mercator maps. What do they depict? Well, if you were to plunk yourself down there on the equator on that map and head west, all the lines of longitude are orthogonal to latitude. Polaris would not move. You keep heading west, I mean, it's almost as if it was effectively an infinite distance and casting parallel light rays from the north. If you were to look to your left, and the Sigma Octantis region is a group of stars. I mean, those would also show similar characteristics, wouldn't they? I mean, that's the claim. That's not what I'm claiming, but that's what's claimed. And the way the globe explains this is you're curving down in a third dimension. Well, if that's the case, a gyroscope, like you should take one with you. You should watch as the housing rotates as you go underneath it, essentially. Right, because the inertial plane of the gyroscope would remain fixed. You'd set it up, maybe at eye level, you could say, just for sake of visual purposes. As you rotate down, as you go over the curvature of the Earth, as you go around the globe, you should be able to see that thing rotate, like the bottom of it. At some point, you should be looking up underneath it. Right?
Right. Just as if you were going like over a hill with a gyroscope, right?
Yeah, exactly. You know, and nobody's ever been able to demonstrate that this is the case at all whatsoever at any time. So that's interesting. Now, is it possible on a flat Earth to do this without seeing the gyroscope move? And boom, 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 you end up back where you started again. So this is where some people like to plop open the map and then laugh at flat earthers and say, well, how did the Japanese get to Pearl Harbor, right? Because they're thinking of this UTM rectangular map where all the lines of longitude are orthogonal to latitude. They're perfectly vertical up and down, intersecting horizontal latitude. Not minding that this is still a globe map where you have a non-uniform scale. And the further you get to the top or the bottom of the map, those map distances between lines of longitude end up converging. So you got to reapply your scale. You got to take like your 1 inch is equal to 500 miles scale, and suddenly now it's 1 inch is equal to 5,000 miles, you know? But is that really happening? Like how much does it scale like that far north and far south? You know, and one of the reasons why these UTM maps, why they don't show 90 degrees north and 90 degrees south is because mathematically this projection puts those 2 points at infinity. So they'll stop. That's why you see these maps stop at like 80 or 85 degrees north and south. I mean, they can't go the full 90. 90 is infinity. You know, and it's worth bringing up too the pizza world map, the azimuthal equidistant map, like on the UN flag. The South Pole, that's still a globe map because the South Pole is now a ring and it's not a point. And if you apply the scale properly, like many people in this argument don't, if you're at 89 degrees south, just shy of the outermost edge of that AE map, that's actually like a 430 mile circumference, not like a 60,000 mile Captain Cook circumference. It's actually about 430 miles on that map. But is that really happening in real life?
Hey, Tom. That's plant abuse.
How else are you gonna get your plants to look cool like mine?
That's terrible, man. You trying to get Venus flytraps hooked on nicotine? Or what?
Where do you think nicotine comes from?
So would that
Can
be
you
like
repeat that?
smoking your own arm?
It's pretty original. PFP. It's funny. I love Venus flytraps. I can never get them to stay alive for very long. I don't know if it's because I don't water them enough or they don't get enough food or what. But I think they're so cool.
Yeah, they're pretty delicate from what I've heard. I've heard they get problems with overfeeding sometimes. I don't know.
No, it's interesting. I was reading some history of geodesy last week, and some of these French explorers that were sent by the crown, King Louis the whatever. Don't remember if it was the 4th, the 5th, the 7th, the 11th, 14th, whatever the hell. But some of these French scientists discovered, by their own accounts, their claims, that the stars don't rotate uniformly with distance traveled. That the further north you go, the more you have to travel for the stars to rotate the same degrees as before. So, like Polaris, for example.
Guys, what other stuff can you tell me that's very interesting to convince me?
Okay, well, heliocentrism doesn't predict the tropical year. Do you know what I mean by the tropical year?
Heliocentrism is the globe model, right?
Yeah, in a solar system.
It doesn't predict the seasons, you said?
Yeah, a tropical year. So specifically, the sun migrates between the Tropic of Cancer and the Tropic of Capricorn in the sky.
Mm-hmm.
So if I
Well,
were to go out on let's say let's pick the winter solstice. Wherever winter solstice is for you on the earth, it doesn't matter. If I were to drive a stick into the ground, and if I were to measure the shadow at noon at this case not being your time set by your local government, but in this case, the zenith, the highest point in the sky that the sun goes. And I were to mark the point on the ground where that shadow is, I could count 365 days until the sun returns to that same point and produces the same shadow length, marking that same spot on the ground. Fantastic. So I can do this again the next year. So I have that same spot marked on the ground, and I will count 365 sun ups and sun downs. And over
the
those
same hour.
365 days, I will watch the sun migrate from the winter solstice to the equinox, which is the equator, to the summer
You're
solstice.
saying
back to the equator, I'm almost done, and then back to your winter solstice, again, 365 days. I will do this a third year, okay? I'm almost done. Third year, I will also count 365 days until the sun returns to that same spot, marking a shadow at the same spot on the ground. But on the fourth year, if I wait 365 days, I haven't waited enough. I have to wait one more day for that sun to return to where it was. This happens every 4 years. This is not a difference between solar and sidereal globe orbits around a sun. This is an actual extra sun up and sun down that occurs every 4 years, and it's not on the leap year.
In the fourth year, you had to wait how much?
One
One
extra
more.
day for the sun to produce a shadow to hit the same spot on the ground that I had marked the
That's
last 3
interesting.
years.
What
Yeah.
about, so are people saying that we have winter because the sun is far away during winter? And that's why the planet gets cold or something like that?
Yeah, but under the
Okay.
heliocentric globe model, the Earth is actually closer to the sun in the winter. I bet you didn't know that.
No, but wouldn't it be interesting in order to test this that people do something that you said, but not like that? Instead of that, measure the the shadow distance from the sun in the summer, but also in the winter at the same hour. You know what I mean?
Yeah.
Because I would assume the sun, if it's further away, the shadow should be longer at the same hour, no?
Not necessarily, no.
I mean, according to the what do you call it? Heliocentric
Yeah,
model.
helio meaning sun centric.
Yeah. Also, the thing. So, do you agree with this? You agree that it should be that way according to the heliocentric model?
Well, what is granted to us from space agencies, from astronomers, is that the sun does occupy the relative center of the solar system, and that during the winter, Earth's irregular orbit around the sun puts the Earth slightly closer, about 3% closer to the sun during the cold season. Right? But it's warm for the Aussies. Right? So winter for us. So this being in the northern climates, December through February, freezing cold. But the claim is that Earth is also still closer. Now, our friends in Australia and New Zealand, they're probably roasting their asses off meanwhile. So for them, that just seems normal. Like, okay, yeah, it makes sense. The Earth is closer to the sun. I'm getting a sunburn out here, and it's freaking January. It's still a trip for me to think about, though. I've never been down there.
You mean you've never been upside down?
Nope, never been upside down, my friend.
Well, regarding, going back to the Antarctica thing, right? Some people point out, now, I don't know, but some people point out that, okay, so shouldn't it just be like, especially if we're actually closer within that solar system model, right? If the north melts and then refreezes, why doesn't the south do that too?
Yeah,
Right.
that's what
During its summer
we were
and winter.
talking about.
That's a good point, because you not only have Earth's tilt, so-called, working in its favor, but you have the proximity working in its favor too. You're exactly right. I never thought of that before.
Oh, I thought you were talking about that when you were talking about Australia being. I thought
He's talking about
the
Antarctica. So listen, the point is if Earth is a globe and it's closer to the sun during the southern climate's winter, and if the globe is tilted towards the sun during that same time period, then why hasn't Antarctica melted? Why doesn't it go through a similar cycle as the Arctic region in the extreme north?
Wow, that's a good question. Let's see right now. Let's see on.
I think you'll find that they say that to a degree it does, but overall the mainland, right, the covered parts of land stay frozen to a large degree, but some of the
Yeah,
outskirts do melt. So that's why they choose to go there in the summer with their big ships and that, because there's
yeah, they
less
show.
ice in the waters to negotiate, less glaciers.
They say it's
But
melting. Yeah.
right, but if you look on Google Earth, right, Google Earth depicts the Arctic region as just ocean, no ice at all. And then other
Look, this
pictures you
is
get from from
so
aerial views, there's a lot of ice. So it's like, okay, so it melts, completely melts during its summer in the north, and then glaciers form in the colder weather. I don't know. That's weird.
But better not this is a bias of millions and millions of years.
so look in the side chat. This is what they're saying. But I want to tell
Side
you
chat?
something.
You
Side chat, yeah.
something.
But I wanted to say one more thing, just in case I forget.
More thing.
One more thing about the heliocentric model, where they're saying that.
Geocentric model.
Yeah, what's up, bro? Can I speak, or you want to say something?
No, you have work at 7-Eleven.
Anyway, so they're saying that the planets rotate around the sun and they follow the sun, and that the sun is going at 50,000 miles per hour, I believe, throughout space. And you know about this concept, right? Guys, you heard about that. The person I was speaking with, who was it? Oh, I think it was you, Yoder, but I can't hear you anymore. Your microphone.
You're muffled, Dr. Yoga.
My microphone sucks.
Yeah, so it was you, right? So
Yeah.
the thing, when I saw that, and even now I rewatched it now, this idea that the sun is just traveling throughout the universe, I find a problem with that, because how come when we look at the stars, the stars are in in the same place all the time, you know?
Yeah, I mean, well, they explain that, right? They say these stars are so big and so far away that we witness no parallax, which means we don't see them appear to move in our field of view with respect to our change in position.
They're saying it moves super slow or something.
Yeah, because they're so big and so far that they say you don't notice it. But they also claim that they have the scientific instrumentation to measure these. And if you look into their claims, it's kind of dubious,
It
to say
could
the least.
it could be true that they are big and very far away, because I saw this documentary from Graham Hancock. He's talking about lost ancient civilization, and he's talking about some type of structure that was built in Malta, which is close to Sicily. But they build like another one, and then another one, and then another one. But the entrance of each of these structures was pointing towards like a big star in the sky. You have to watch the episode. But they each time they build another one, the door moved just a little bit slightly, right? And this was like built a very long time ago. And he also was saying that the water level was way smaller. But anyways, this is a different subject. But yes, it could be that these stars are so far away that even though the sun is traveling so fast, the movement of the stars it's so hard to track. But the other thing is, if the sun is like traveling so fast and stuff like that, how come we don't hit any star or
They
hit
also say
anything?
that space is so empty, you're not going to. It's like almost everything else we hear about, right? Earth is too big, that's why it looks flat. Earth rotates so slowly, which is why we don't feel it move. The solar system moves so slowly,
Okay,
which is why you don't see the stars move.
this
They have
already
all
tells
of these
me
excuses, dude.
this already
I
tells
wanted
me
to
that
say
you
that
have
both.
been looking into all these things.
What?
That Yoder, you have already been looking into all these things.
Tell me something. How does the sun's dial work? If the Earth is moving at the same time with the sun and the moon and the stars and everything else, so
Everything is
explain.
moving. Yeah.
Yeah, if
Yeah, they claim
everything
it's
is
relative difference of motion.
Yeah. Difference in speed, I guess.
yeah, so how does the sun dial work if that is the case? Is everything is moving, right? And
It's
even
based off
though
of
you
relative motion. That's the claim, Slalom.
yeah, no, I get it. The question wasn't for you; was for the Duke, whatever his
For me,
nickname. Yeah, for you. Yeah, you get it? What I'm saying?
you're asking me how does the sun work, but the thing is, I'm
Not the
neither a
sun.
flat. I'm neither a flat earther or a glober.
Right,
So,
right.
Oh, you haven't made up your mind
so
yet?
what? No.
It
So
ain't the
what are
sun.
you?
It ain't the sun. It's the sundial. Do you know what it is? A sundial.
Sundial? I don't know.
So the sundial is an object that predicts what time it is by the sun. Okay.
Oh, okay, that makes sense.
So that object, if we are moving at the same time with the sun and with the moon and with the stars at the same time, how does the sun dial work? Because everybody's moving, right?
Oh
Do
yeah,
you
because
understand my question?
they're saying that these planets, including Earth, rotate around the sun and follows the sun.
Yeah,
Yeah,
I
but
get that. I'm sorry. Go
there
ahead.
was
Go
a.
ahead.
I'm sorry. I think there was a device that that was used in the Islamic Empire, Mamluks or something like that. That you can like calculate the position of the stars. I'm not sure, but I wanted to mention the point Dr. Yoda said earlier, where he said that Earth rotates too fast, too slow for us to notice, but too fast for the water structures not to fall apart, or they're like held by gravity. And also, we're expected to believe that uh, for some reason the rotation doesn't move the water at all. Like you would have centripetal force, you would have force that would pretty much at, at least like it would submerge Africa, or like you would
Yeah,
find Africa
yeah.
with a lot of water because there's a rotation speed. So that never happens.
Yeah, at 50 miles per hour, I would assume, yeah, the water will be
Contradicting
flying
claims.
away.
It's either too fast or too slow, and they explain it in both cases. Like it's too slow for you to notice, but too fast for the water to screw us off. Doesn't make
No,
sense to me, honestly.
it's like no, it's traveling at 50,000 miles per hour, but somehow the water is not flying away.
I worked on that was an educational program where we used to get satellite images for the River Nile, and we'd present that to back then the Egyptian NASA, something like that. And the way the mechanism works, they have something that takes a photo of Egypt, right? Because Egypt, Sudan, and like the River Nile, and the photo is it's fully black with different intensities of black, and they have like a part of the processing. You process the image itself. So part of the processing is coloring the image, and you start by the night. So that's the deepest, or like the most concentrated darkness in the image, and you color that blue. So I asked and I said, what if there is a decrease, like a immense decrease in the water structure or something like that? And he was like, we can trace that to know, but we can also color it just to look very normal. It's how we color it. I'm sorry if I hijacked the call. I did not mean that.
I'm sorry, for some reason I didn't understand you. I lost track of what you said. I completely didn't. I'm sorry.
It's okay. Simply what I'm saying, that satellite images are mostly black, and we as humans get to color that to be understandable to us. So there is a huge factor of cosmetics.
Where are these satellites created?
Back then, that was 2014, 2015. They're swarm satellites. So they're, I think they were called EGSat, and they're basically cubes, a meter length, width, height, and you have like a swarm of those, like say 1,000 cube, and you scatter those in the low orbit, I guess. So you scatter those in space, and they get to collectively take images of the Nile. They do that for like geographic purposes, or like to not for any political reasons or like media or anything. They just track water.
Are we under the assumption that these satellites are orbiting a sphere Earth?
I have no idea. I heard the guy from the Egyptian NASA explain that shit, and I found the notes 2 days ago. We had an equation that we applied to like connect the ground station to the orbiter, like certain times, but the equation didn't make any sense, and he didn't know how to explain that shit. He just goes like, it works, and that works.
Yeah. So the ultimate claim behind these satellites is that they are some kind of machine or technology that is orbiting, meaning taking an angular path around a certain point or over a certain geometry.
Pretty much.
So what we need to do, yeah. So what we need to do is establish whether or not this technology or this machinery can do what is being claimed. The first thing we would have to kind of grapple with is if it's possible that the Earth would be a sphere that the satellite is actually transiting or orbiting around.
I got a question for our friend, if you don't mind, real quick. You mentioned an equation to trace it down to ground stations. Does this have to do with magnetic field line tracing, perchance? Do you know what I'm talking about?
I'm not familiar.
Okay, never mind. Carry on.
So anyway,
Okay, I thought you were explaining this. Anyway. Go ahead, man. Go ahead.
He's just checking to see if you are familiar with the mathematics and the equations that are involved. If not, it's okay. So if if these machines or technology are taking a path around a sphere, then we should be able to measure the sphere. Would you agree?
Yeah.
Okay. How would we do that?
Not very sure.
Right. So that's kind of where I get kind of hazy with the whole satellite thing, because people can make a claim about technology or machinery in the sky and it's doing a certain thing, but if part of the story about what's happening is happening around a sphere Earth, but the sphere Earth is not measured, what I'm saying is if there is no globe for these things to orbit, then why would I kind of investigate any further if there is no sphere? Does that make sense?
Yeah, I asked something similar, but I don't know. The satellites are not very impressive. They they're supposed to be launched like 200 kilometers away from Egypt, so that's from the Earth ground. So that's low orbit. That I don't think that's further than the International Space
Wait a
Station.
second.
That's no.
Wait a second. So you know how people have
Take the Earth is round.
That's
look,
great.
look.
Please don't
You know,
interrupt.
people go on boats. I know one guy, one YouTuber. He bought a boat, and he's like, I believe he's been across the Atlantic, I'm not sure. But in these places where you don't have internet, he bought Starlink, and he's able to upload with Starlink. I believe it's called Starlink from Elon Musk, and it's connected to a satellite, right? So there must be satellites, right? At least this Starlink
No.
one.
It would be irresponsible of us to assume that because now all of a sudden I have internet in a place where I didn't have internet before, that these are pieces of technology that are going around a sphere Earth. You know what I mean?
Yeah, I actually agree with you a lot. That said, I believe there are
There would be
satellites, but
something like
I don't know how
rather
they work.
than us obtaining a radio connection or internet connection, rather we are kept away from it. What do you think?
Well, it's more a matter of what is possible based on the story. So if at one point in time you didn't have internet access, and then you bought a subscription to someone or with someone that said that now you can have internet access because they put satellites in outer space so that you can receive internet, and therefore the Earth is a globe, that kind of leaves a whole lot left out. In reality, it's possible. I'm not saying this is true. I'm just saying there's a possibility that there is another form of technology that could give you the internet access, and it still has nothing to do with sky technology or the Earth being a sphere. Does that make sense?
I see what you're saying.
Great. So, just because we have internet doesn't make the Earth a ball, nor does it verify or prove that satellites exist.
I heard the very same statement about GPSs, and actually, you don't need internet or satellites to create a GPS or like virtually have a GPS.
Well, yeah, but the thing is, it's like so far away in the ocean. I'm not sure if it was in the ocean. I'll have to see. But I remember he was in some place where he normally didn't have internet there, so that's why this Starlink. I believe they use Starlink where in Ukraine or something. Ukraine
so
yeah, they do.
Let me help you out with something that you may not be aware of. Prior to the idea of GPS, originally meaning ground positioning system, ever being an idea where right, there was no globe, no satellites involved in that process. Everything was being triangulated or trilaterated with towers, meaning they would ping a signal between you and the towers that were available to receive that signal. And that was just Earth based, it was ground based.
Yes, you
Why would
need
it
no satellite for that.
No satellites for that. So why would it not be possible to place buoys or, let's say put towers on oil rigs, wherever they are, scattered across the ocean, and still use the same technology to find out where you are just by pinging a signal between these towers on the surface of the Earth? Why couldn't you do that?
Well, that would imply that, well, for example, there wouldn't. So first of all, there wouldn't be these oil rigs absolutely everywhere. It will be in just a few places. So these towers will be just in a few places in the ocean. But maybe rather the connection is far longer than what they're saying. They're saying it's only 45 miles for mobile data. But then that would mean that everywhere on Earth, it's like a massive conspiracy to, and I don't like to use this term because I believe in conspiracy theory, but like this unbelievable conspiracy theory where all these towers don't provide us internet.
Right.
You know,
So
you know what I
there's a
mean?
couple different. There's two different things going on, and I understand what you're saying, and I appreciate your position. There's two types of GPS. One of those types of GPS relies on internet access to trilaterate your position. The other type is just bare bones pinging of signals between radios. And you can get a handheld GPS receiver or transmitter. Usually Garmin makes these, Motorola makes these, and they are only designated for the pings that you receive to trilaterate your position. So if there's no internet involved, you're still dealing with radio signals that could be transferred or broadcast across the surface of the Earth, line of sight, especially in the ocean where there's no obstruction because it's flat and level across the surface, and you would have no problem doing that.
Well, now
So
I
which one are
realize
we
that.
talking about?
So, so the thing is, from what you said, now I'm just thinking now that yeah, this Starlink thing from Elon Musk, like why would this product, why would Elon Musk all of a sudden just create better, better radio or internet connection? Like how,
Well,
like
that's not a healthy way to start a question.
well,
Elon Musk
you
is not
essentially,
exactly. Oh, sorry.
you go ahead.
No, I was just gonna say he's not exactly a logical person. Like, why did he name his kids weird names? These are questions that are very
Yeah.
hard to answer.
Ultimately, we can't know why Elon Musk is doing what he's doing, why he names his companies what he names them. I mean, he named his car company Tesla, right?
no, I'm saying no. I'm asking why, like, I'm saying how
Yeah, I
come
had a different
Elon
question.
Musk
You were
is
saying,
how come Elon Musk is able to provide better internet connection? Why don't we just have better internet connection from the beginning? How come how is he able to create that? You know what I mean?
Well, fair. I mean, you got to appreciate that technology and our accessibility or our, the availability of the technology grows over time. It becomes easier to produce, cheaper to buy because the supply and demand issue, right? So if people are living in rural or remote areas where they don't have access to internet through cable or whatever, they've just provided a new way to get internet to more remote areas. There's no reason to believe that it has to be done through satellite. In fact, a satellite would be the most inefficient way to do that because it's the most expensive and the most risky. Why couldn't you just put up more towers in different places and then announce that you have satellite, you know, internet, and in reality, you've just put more towers in different places? That to me seems more plausible instead of assuming that the satellites are once again orbiting a spherical Earth. Now there's another possibility. The other possibility is that they've created a network of balloon satellites that gives, internet and information and radio signals to more remote areas, and it has nothing to do with space or a globe. It's just an elevated radio transmitting network that essentially operates using balloons and satellites attached to those. Still cheaper, still more plausible.
It's interesting because I'm just looking up now. I search picture of satellite seen from Earth, and I'm not finding any picture of a satellite seen from Earth.
Right.
You know.
Yeah,
Because they should be
we've
able
done
to
those
zoom in. Because
searches.
they're saying we can zoom in with our phone to the moon, so we should be able to zoom into the satellites since they're way closer than the moon. But we don't see any picture
Right.
like that.
Yep. That's the things that you're going to start figuring out, is that the more that you research, the more things you're going to find missing, and some of the assumptions that you've made, or even some of the claims that have been made, when you look for the evidence, it's not there.
But there was one interesting thing you said, but I didn't understand very well about the internet connection thing. Before I said the thing about why would Elon Musk be able to create better connection, what was the thing you said? You said something about Motorola makes something.
Right. So when you use your smartphone and you use Google Maps, let's take for instance, there is a relationship between your internet connection and where your phone is getting the signal or getting pinged by the towers that are pinging it, right? Or let's even just pretend for a moment that maybe there's a balloon satellite, blah, 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 that is pinging you to get your location. Fine.
Okay, yeah.
But before all the smartphones, I used to work for Cabela's. So Cabela's is a retail outlet for outdoor gear. So a lot of hunters would want to know where they were hunting, you know, when they get back, way back in the woods, way back in the jungle, way back in the forest, and they start to get kind of lost. So they would use GPS. They would use standalone handheld units. Usually they were made by Garmin or Motorola, to get the, you know, receive a signal and triangulate or trilaterate their position. So those are totally independent of the internet. You use the internet to more interface with whatever reference system that you're using as to where you are. Google Maps being one of those reference systems. It's a web Mercator projection. So that's why you would need the internet. But ultimately, some of those standalone systems would just tell you your latitude and your longitude, and you would use a map on your own to find out where you were when you were out in the forest. Does that make sense?
I guess, but what's producing internet and radio?
Can I have can I just add something?
Go ahead.
Even the old phones or the new ones, your phone, in order to call you, right, they have to ping a tower that is next to you. Otherwise, your company, your cell phone company or whatever, cannot tell where are you, so that the other person can call you. So your phone, without you knowing, is pinging every single tower next to you, so that they can tell this guy is nearby this place or that place or whatever. Do you understand
Sure.
what
So there's a bunch of different ways that they can kind of figure out what you are or where you are. They also use Wi-Fi. So if you have a designated Wi-Fi at an address and that address is known, they will be able to triangulate or trilaterate your position using Wi-Fi, you know, using the towers that your phone is ultimately connected to, because most people don't understand this. Your internet is always going to be through a radio signal. It's a radio. It's a form of light being broadcast across the surface of the earth in all directions, and that has to be received by some kind of tower with a receiver on it. So you're really never, as far as I know, I could be wrong, you're not directly speaking through your phone and then a satellite and then another tower. It's usually tower first and then another tower, or through a cable. but it's always towers. It's always radio signals. Your internet is radio if it's wireless. It's a radio signal.
Most of the conversation that's taking place between me and you, says who's I'm on my mobile device, right? That's linked to my router. That's linked wirelessly to a cell phone tower. And then the cable takes care of the rest. The cable will go to the coast of England. It'll go underneath the Atlantic and it'll come up somewhere near New York. And then because of the landline system, it'll pop up near a tower near you. And then you'll get the rest of the signal however you get it. But the majority of
100%.
it is cables. The only wireless bit is my handheld device and the router.
Yep. Now I use mobile data. I very rarely use my Wi-Fi. So whatever wireless communication I am doing through this particular apparatus is, I have a Bluetooth, a headset, and then that broadcasts a radio signal to my phone. That broadcasts a radio signal to the tower, and then it goes through the cables. But all of this is just radio transmission. It's just light over air. It's fascinating. It's really impressive. But it's electronic signals, ones and zeros, over the air through radio signals.
What about the internet cables they have in the ocean?
That's what takes care of the majority of the communication.
Actually, it doesn't matter. I just realized. But what about? I'm not sure what I want to ask.
If you look at a map of the internet undersea cables, you'll notice that every continent landmass is pretty much surrounded on the perimeter. Not the UK, for example. We've got got some endpoints from the Atlantic islands and then to mainland Europe. But say around the continent of Africa, that country is surrounded by an internet line, and then it goes into each country and then through those countries further inland. That's basically how the cables take place. Me and says who, and everybody else. Our communication is primarily under the water.
Yep. It's much more efficient. It's an infrastructure that already exists. The risk is very limited, and even if there is a break, which does often occur within these fiber optic cables that are run under the ocean, they're easily repairable. There's no really repairing a quote unquote satellite if it gets punctured or destroyed by some kind of random piece of space rock, which apparently there's a ton of those. Tiny little meteorites would shred, according to the story, these satellites in no time, and there's no real way to repair those.
I was watching a military program a couple of months ago talking about Russia and how it would cut communications and all of this types of stuff, right?
I was just thinking about
3
that now.
well-placed bombs around the UK would cut our internet access and send us back to the Stone Age in that regard, because the 3 bombs would be placed undersea where internet cables meet. And to shoot down satellites, you just have to blow up things in the water. That cables.
I think they probably have a backup plan for that. But they have done something similar on, I think, China. It was between Russia and China, I believe.
I'm not familiar with that. But either way, the thing about the story with satellites is that there's a problem with plausibility and efficiency. These corporations do things according to what's most cost efficient, and beneficial. So is it more efficient to put up a tower on the earth that you can easily service and easily get cable to, or is it more feasible and cost efficient to build a piece of technology with lots of man hours, exotic metals, and so on and so forth, put it in a rocket, hope that the rocket doesn't explode, shoot it up to some ridiculous altitude, deploy that particular satellite, and not be able to service it physically for essentially the duration that it's up there. And if anything goes wrong, you've got yourself a huge floating paperweight that you can do nothing with. Which one seems more plausible, right?
Sorry, I just started laughing because my router needs resetting every bloody week. Like one way or another, it's going to start blinking at me for some fucking reason, and I've got to press a button for 5 seconds. That's not going to happen with a satellite. Oh shit, it's gone down. What do we do? Well, we can't turn it on and off again. Can't reach the bloody thing. Now we can do it.
Yeah.
Well, they say manually from the ground, right? Okay, if you say so. If you can't get a signal to it, you're fucked.
So if we just, well, I'm not sure I understand how radio works. Like, so I have my phone and it's connected to this tower. So the tower is like receiving my phone or something.
Yeah, it's
But
sending
does
and
it have, what
receiving.
does it have in this tower? It has some type of receiver. What is that
Yeah.
made
Yes.
of? What is this receiver?
Well, that's a little bit above my pay grade, but essentially it is a device that receives amplified transmissions, radio transmissions, frequencies of light that we can't see with the visible eye, but within that light is coded ones and zeros, right? Digital information that it receives from the amplified signal from your phone. Now, I also understand that these receivers also have kind of like grabbers where they have an amplified receiving radio signal of their own, so they connect within the air to meet each other and communicate. I think it's fascinating. I think it's really cool. But that's how the receivers work. They just receive the amplified light signal with ones and zeros, digital information. It is decoded, then it is translated into visual stimuli, light through your computer monitor or your phone screen. All those ones and zeros, that digital information becomes usable information to you on the user end.
Okay, so although this is extremely fascinating, I only came into the conversation about 15 minutes ago. Where's this going?
Oh, just we started with the idea of the satellite, right?
So the thing
Okay, of
is,
course.
okay, give
Good
me a
old
second.
satellites.
Radio. Now I'm trying to see the, all the radio towers on the world. Yeah, it looks like there's these
Some of the
radio towers
tallest
everywhere,
structures in the world, radio towers.
even
They're
on
not as
islands and
well
stuff like
known
that.
as like the Burj
So then,
Khalifa and all these other large buildings because they're just antennas. Some of them are huge.
yeah. So why would we need the satellites then? Especially so many,
It's
because they're saying there's so
it's
many.
always good to have an overarching view of the land. We have to understand that this technology is primarily born out of military, right? Wars and stuff, like radar that came straight out of the military, eyes in the sky, aerial photography that came out of the First World War. Because from a military point of view, the best vantage place is far away where you can see everything, and that really is as high in the sky as you can get. If you can get higher than anybody else, then they can't get you. So that's the benefit of it. You can look down and see the world. You can survey. You can check temperatures and wind directions. All of these lovely things, like we have done for like decades since the invention of weather balloons and meteorology.
But how come there are no pictures of satellites from Earth? Maybe they are classified.
I don't know, dude. Maybe the angle of size is too small for the cameras that you've got to resolve. You can see lights shoot across the sky. I don't think any reasonable person would say that there aren't things in the sky. It's just the story that's behind these things in the sky. What they prove or don't.
No, I'm like saying, like, how come nobody's taking a picture of these satellites? We don't see these satellites,
Yeah, I don't know. I mean, the International
If
Space
it's for
Station
military, maybe that's why.
is the one, but I don't know.
So maybe it's not for radio connection. Maybe it's just a lie. It's probably just for military or something to do with the government. But yeah, so it looks like there are these radio towers everywhere on world, pretty much everywhere. Even in Sahara, there's a lot of them. Not everywhere, but yeah, I would see some places in the ocean where would be still kind of difficult to get internet connection.
Not really.
But
there's a vast lattice across the oceans, Pacific, Atlantic, around the China Sea and so on, Indian Ocean. A lattice of buoys, or buoys as we call them in the UK, but buoys for the rest of the world. You know, there's little things that float with little devices attached. Now they detect, they're at sea level and the surface and at lower depths. They detect noise. They're there to spot things like submarines, military vessels, and so on. They also have connectivity with other things that are passing, so you know where you are. They're just buoys that are on the ocean. They're connected to the seafloor. There's millions of them.
yeah, well, after all, humans are connected, you know, because humanity is connected. But humans have been connected for a long time. Even in ancient times, there is this tomb, ancient tomb in Japan, and it has like handlers made out of the stone on each side, and the exact same type of tomb was found somewhere in Mexico, and also like similar architectural style for pyramids or other constructions found similar all over the world.
Yeah.
So yeah, information is transmitted, but the point is the humans have always been connected.
Yeah, we've always communicated. Yeah.
Yeah.
Now the question is, how long did this take? Was this over the lands and stuff that we know, or was the communication taking place on a more local level and the world separated over time? So maybe the
Yeah, the
continents were
world
all
has
kept like
separate
Pangea and everything split. The technology was relatively local at the time, but after some kind of cataclysm, it looks like the technology and the buildings are all further apart because of great earthquakes and shit. But
there was
that's,
I
well,
think there
off
was a
into the deep
flood.
end, my dude. Do apologise.
I think there was a flood.
Yeah,
Look
we could
look
spend
up.
hours talking about this stuff, mate. But primarily, the subject of the room is the flat Earth, or subjects closely related to that. That's why we were talking about satellites, I presume.
Yeah, sure. I just want to send you just one video for you.
Okay.
But which one? Let me see. Yeah, this one. I posted in the side chat. You can save it and watch later.
Okay, thank you.
You're welcome.
Yeah.
Yeah, so about flat Earth. Yeah, interesting stuff with the satellites and all of that. But you know, for me, like the moon landing topic was like so huge. I've been looking into that a lot. But now this is like, I realize now this is a small part of the discussion. Right? There's like a big amount of questions, big amount of topics to question now.
Did you saw the moon landing of India?
Yeah,
Like
I
it?
saw that it looks fake. Yeah.
So you didn't like that movie, huh? Okay, that's that's good.
Yeah. It's dude, I'll have to honestly, you know what I'm gonna do tomorrow? I'm gonna look I'm gonna try to see these these moon landing debates on YouTube and try to see like these people who are like they're saying they're like scientists or like serious people or something. Try to defend this moon landing. I have to watch it again because now for me it looks completely ridiculous. Just the most ridiculous thing. Well, there are plenty ridiculous thing. The phone. There's no stars. The shadow of the rocks. But the most ridiculous thing is just this thing itself. The whatever thing they landed with, right? You're telling me just with this shed, they flew through the universe. I mean, it just makes me feel like humans are so stupid. Everyone who believes this probably is like the dumbest thing I have seen in my life because of the how many people believe that. I don't think there's something dumber than this. If you look at this thing that they say they landed with on the moon, this shed, whatever it is, the way it looks like it was built by a kid in middle school for like a science project or something. The amount of people who believe it's possible to travel with that in the universe, this has to be the dumbest thing, honestly. I can't think of something dumber than this right now. Because like people actually believe it inside themselves. And I know humans are very smart. But man,
The individual person's really smart, or has the ability to be really smart. But people, a collective, can be stupid. It's like a herd mentality, right? And especially, do you know what a shill game is? It's like a game you'll find on the street of like cup and ball, right? Or find the lady. You got 3 cards or 3 cups, and you've got to find the lady, like the queen, or you've got to find which ball is under the cups, for example. Now, as you're standing in the crowd, there's a couple of people that are on the side of the person, playing the game with you. They're encouraging you. They're nodding along. They're putting money down. And this is the same type of thing as like the moon landing, right? You've got a load of people, and you've got news presenters nodding along, you've got scientists nodding along, you've got politicians nodding along. So you start nodding along too, because these are people of authority. And before you know it, everybody's nodding along. It's a shill game, dude. In this instance, it's a confidence trick. I mean, this is a massive, massive lie when you think about it. So that also comes into play. You couldn't lie massively that big. Somebody would find out. There'd be a whistleblower. All of those reasonable things come into your mind when you're talking about a lie that is that big. But ultimately, it's a confidence trick. It's a shill game. Everyone's being deceived. People, very, very stupid.
So probably people feel it's weird, but they don't want to admit it, because people's feelings are very powerful, and I think we have this incredible instincts from the creator. So yeah, maybe people believe it's weird. People feel it's weird, but they choose to ignore it.
That comes into it as well. They
But
can't
when people are young, especially, they
it.
probably do believe it. Sorry.
No, I was going to say they can't quite explain it. It seems complicated, but somebody smarter than them, a scientist, they can explain it. They know what they're talking about, so I just trust them. But yeah,
So
that happens.
they're probably like in a position where they have no choice. So they're like, well, I guess that's how they did it,
And you're in a position of no choice when you go to school. Like, that's the position of no choice that you're in. You're very vulnerable as a child, especially to authority and information and what is right and what is wrong. When you go to school, you're taught what is right from wrong sometimes, right? So you go in with that idea that everything that you're taught has got a level, if not the truth. You don't question these things when you're at school necessarily. So they get you when you're young. Then they form an anchor bias, right? Whether that's that can be to a religion, to a state's theology, to a way of thinking, a political bias, a social structure. Your anchor bias can be set very, very early on as a child. So that's why we go to school.
Yeah, there are many lies. There are so many lies on this earth, and I've learned. I know so many things. Honestly, I'm not saying this to brag. I really know a lot of things, and I'm, let's say, aware. This is like funny. I am aware, but
I hear you.
It's like I wouldn't say sad. It's interesting. This is what I wanted. I remember the moment in my childhood when I decided that I want to know why things are happening the way they are. I was a small child, so this is what I wanted, and now here I am. Now I'm kind of sad. I mean, I can have normal conversations with people, I can just talk about football or something, right? I'm not that type of person. I'm just not. But
I can do both.
That's a plus for you, for sure.
Yeah.
For me, I'm always, my passion is just learning things, just learning truth nonstop, and listening to music, I guess. But I know so many things, and it's like I don't know what I'm trying to say. Like this time that I'm living in right now, it's like kind of like, what's the word I'm looking for? I know it's taking me a lot to say this. Maybe frustrated a little bit or disappointed that I'm not living in a time in the future where things are just nice the way there should be, right? Like I'm living in a time on this earth right now where there's so many problems, so many lies, just lies everywhere. Lies, like everything is fake. Everything, like so many things people believe in, they shouldn't be there. They shouldn't be there. And like I gained this level of knowledge where I'm able to apply that to subjects, and I instantly, because of my accumulative knowledge, I'm able to understand how it works. Like even with religion, I feel like people who believe in religion, like I can see on their facial expressions, because they believe in it, they want to think it's true, they like ignore their instincts and stuff. But we all have instincts about truth. It's like a hack from God. We like, sometimes the truth is in us, but we just choose to ignore it. We just choose to ignore it because of lies and propaganda. That's why, because truth is so powerful and our instincts are so powerful, maybe that's why, like you said, maybe that's why they try to lie to us when we are children, because that's when it's most effective in order to fight this truth instinct inside us, these powerful instincts that we have. I'm catching on to a lot of things.
Like what?
Like, I mean, these quotes that people are saying. Humans have invented quotes. Like, you keep hearing nice quotes, like what quote? Let's say, truth hurts, for example, right? This quote, right?
Yeah.
It's not only is it true, but it kind of like implies something so deep, like so meaningful. When my entire life, when I would hear the word deep or the word meaningful, or I've always thought these are just like cringe words. Like, but now I've been shocked. Now I understand. There's something deeper. I don't know how to explain it. There's something deeper about our existence. I tend to believe it's an experiment from God, but it's I tend to believe in objective reality, in objective morality, and objective truth. And I don't know, I feel like God has created everything perfect, and we are perfect as well. I think humans are perfect as well. We are capable of evil also. Well, not evil, but we are capable of harm. We are capable of harm because we need this ability to harm in order to defend ourselves. We have detective abilities. We have everything. We have everything. Yeah, so maybe things should just be perfect. Maybe things were perfect, but we decided to test greediness, right?
What's this idea of perfect that you've got? What does that mean for you?
This is what I'm catching on to. I feel like things should just be perfect. Humans want perfection, and I think that we are perfect. Like,
okay, but you still haven't defined what perfect is for you. When you say perfect, tell me what that means.
I guess the way God meant for things to be, the way God created things in the beginning for us. Like, we have everything here, everything we need, and humans are perfect. Like, we have everything as humans. We are so we are
So I'm
incredibly
going to
intelligent.
divide something. So I can understand the environment being perfect, okay, but then you bring in people, and forgive me, from one side you say the people are perfect, but then we're capable of, let's say, so much harm. Now that would be imperfect, I would presume, right? Because I would say in God's perfect world, you haven't got lions ripping smaller animals apart and blood flying everywhere, right?
Yeah,
So,
that's a big question for me. I don't know about that.
Yeah. So it's this thing about duality, right? Within human beings, there's the one side of nature that you would class as, I would say, good, and then the other side of your nature that you would class as bad, right? Subjectively or objectively.
I think people are capable of doing bad things.
Okay, so what is a perfect human then?
I think a perfect human is just just a regular human. I think it's
okay. So a regular
But
human.
I'm not ready to say it's perfect, but I tend to believe a human
Okay,
is
so a regular
perfect.
human that bashes their toe on the bedroom side and screams out in pain. Is there pain in this perfect world to shout out about? When I shout out, am I going to swear? Is swearing a word that has got intent and emotion behind it? Are other people going to be offended that I've sworn and used the word?
It's like when you feel the need to swear, you feel anger.
Mm-hmm.
You feel anger because someone has hurt you or something.
Now I've hurt myself.
You hurt yourself.
Yeah. I still experience. Do I experience pain?
How are we supposed to know what you feel?
So what's your question?
Still trying to find out what perfect is.
Well,
the perfect
okay,
person, the perfect
so
human.
well, that's perfect, right? Like if you hurt yourself, you're gonna feel pain. So that I guess so that you know it's bad to I don't know to hit the wall with your foot or something. Be
Okay.
aware of the danger.
So perfectness can include pain.
Yeah.
Okay. What else?
Like You know, so that you are aware of danger, yeah, I guess. Protect yourself.
Okay, so to be aware of danger, so you can cause yourself harm or potentially die in this perfect world where there's a perfect human. Do perfect people
Yeah,
die?
but humans don't really like to die. Don't really want to die.
I'm trying to figure out what perfect is. So a human's limited in time, right? They are mortal.
They are mortal, yeah.
Yeah. So I'm trying to figure out when you say perfect person, does that mean mortality or immortality?
Well, if humans lived forever, I don't think that would be perfect.
Why not? There'd be no death.
Because then maybe, I don't know, you're living too long, or you don't appreciate your life.
Yeah, the idea of your perfect world is very subjective to your subjective opinions, right?
Me personally,
I think perfect
I
means
try
different
to
things to
align
different people,
myself.
dude.
Sorry, I try to always align myself to the objective truth. This is how I look at the world.
Okay.
I've been doing this for a long time.
Yeah, no, I appreciate that. So I'm trying to figure out if your perfect is objective or subjective.
I don't feel perfect right now, but I think that things are meant to be perfect.
Okay. Whatever that is.
Like, okay, like for example, this flat earth movement. If the earth is flat, isn't it like, because the way I look at it, it's, if the earth is flat, the fact that humans are catching on to that, regardless of all these lies and all this propaganda, proves the power the humans have. It proves how powerful their instincts are, their detective skills are, and the desire for truth. Right?
Yeah,
Like, it's
so
so deep, isn't it? It's so deep. That's my point, isn't it?
Yeah.
Guy, there's a reason that Earth is not flat, because if it's flat, where is the you know when the sun come, where is the darkness? Where is the night? If the Earth are flat, must be the sun and the light and the night are in the same time, because
No.
there is light.
No.
But it's when it's curved, it's make sense.
But it's not curved. It measures to be flat. You just seem to don't have a misunderstanding of why a light comes and goes, and why when it goes and doesn't give you your light, you get confused. Have you got any lights in your home, like a lamp or a flashlight or something? You're not going to illuminate everything with one light now, are you? Why is that?
This is what?
Why can't you illuminate everything with just one light?
Yeah, I don't know. I don't understand.
Okay. Well, this is going to be an awkward conversation then.
What Jed is trying to tell you, why don't you illuminate the entire house or your entire house just with one lamp instead of using multiple lamps to illuminate the entire house? That's what he was trying to explain.
I use
The
one
same
lamp in my
happened.
room. Only one lamp in my room.
Cool. Do you use that lamp to illuminate your work?
It's it's work actually. I
It's a
use one
different
lamp.
place, isn't it? Yeah, it's a different place. noticing that your one lamp isn't going to illuminate the entire portion of the surface of the Earth. There's obviously a relationship between the size of the Earth, the size of the Sun, and the distance between the two. So when the Sun travels, it only illuminates a small portion of the Earth. Understanding also that light has to penetrate the medium of the air that we breathe. So over distance, the light becomes dimmer and dimmer until eventually you can't see it anymore. So the reason why we have day and night is because of the sun's locality to the earth.
Listen, there's times I see the moon and the sun in the same time in the midnight.
At midnight? No, that wouldn't. When's that? Where's that?
Honestly, I see the moon,
Yeah.
and the midnight and the sun. So I see the moon, but it's not the dark. The time is
Okay,
maybe
so you see
12 p.m.
you see the moon during the day. Okay. Me too.
So I mean, it doesn't make sense that you have.
You see two things above your head above a flat stationary floor. Okay. Have you got two lights on your ceiling? We'll call one the sun and we'll call one the moon. Now, your flat stationary floor, does that disqualify their existence?
Try to make your voice simple because I need to understand all the words you say.
Okay, so you're confused because you can see the sun and the moon in the sky at the same time. Yes?
Yes,
Okay.
and there is a point also
Okay.
make to me to
Okay, so
understand what
if you
you
have one light on your ceiling, we'll call that the sun. Now get another light and put it on your ceiling. We'll call that the moon. Now this can represent what you see in the sky above your floor that's flat and stationary. Now, why would you be confused about seeing two things in the sky?
Yes, because the moon are in the night. We saw in the night
No,
things come.
no, no. Not even in the heliocentric model do you just and only observe the moon in the nighttime sky because of the moon's orbit around the Earth, meaning half of the time it's going to be on the daylight side of the Earth. This is when it becomes a new moon, when the moon is between the sun and the earth and we can't see it because the sun's illuminating the other side. So we see the moon either side of the sun in this period of the lunar cycle. It's described within your model.
I don't understand. Look, I thought I think I'm drained right now. You know.
Yeah. Yeah. I'm just telling you what you thought you already knew about your own model. That's fine. I'll tell you those things if you want to understand them. I knew them for 40 years. I'm 50. I've known them for 50 years. Same as you. So are you less confused about seeing two things in the sky now?
No, that's my view. I believe that Earth is not flat because one reason. Because when if it's flat, it will be will be sun all the day.
All the day? And of course the sun's visible all the day. Day is defined as when we see the sun. You mean all the time? No, not all the time. It's like, do you get confused as to why you can't see clouds like go over your head and then disappear over the horizon?
Mm.
It's because they move out of your range of sight, right?
Yes.
You understand you can't see everything from your limited vantage point on the surface?
Yes, I know this.
Good. So I don't understand why you're confused.
That's not my point. If I
What?
get a telescope, I will see
What?
I will see the cloud if they move along with my eyesight.
If you get a telescope, you can see the moon
And clouds.
Cloud,
and stars.
You're amazing. I'm gonna go buy a telescope because I want to look at stop signs.
Guys, can I say something?
Yes.
Probably
I
not.
think the Earth is actually round.
Why?
Oh, bro, listen, Fury. You
Hold on.
need to be muted in this server too.
I'm not muted.
Yeah, you was muted in in vegetarian server.
Yeah, true, because of that
Oh,
German.
you're trying to get muted then? That's
No,
cool.
I'm
No,
trying to
I'm
have a
not.
conversation about the flat Earth or the round Earth.
Okay, so why do you think
Pick
the
one.
Earth is a globe then?
Yeah, pick one.
I think it's a round Earth because if I look into the horizon and
Mm.
there's a tall building, I don't see the entire building. Like it's a little lower. It's like a little below the horizon, right?
Okay.
That must
Jedi, you're like
mean
case file
the
5331 million.
Earth is curved.
Why? Why must it be the Earth is curved?
Well, if it's flat, then I
Mm.
would see the entire building.
Why?
Because then, well, that just makes sense, right? I need to draw
No.
out for you. Like,
I
if there's a
understand it. I understand if you were to get a piece of paper, draw a horizontal line with you standing at one end and a mountain or building. You know, I understand. Understand.
yeah,
I'm asking you to think a little bit more critically. I'll help you off. When you're looking through lots and lots of distance, what are you looking through?
through my eyeballs.
Okay, so when you view from your eyeballs and receiving the light reflecting off the distant object, what's the light passing through between the object and your eyes?
Well, you're a Jedi, so you should know, right, that the Earth is round.
What? No, I'm
You have
just
a
pointing.
spaceship and you can fly to other planets and you see
Okay,
it.
I
Yeah,
obviously can't.
he's starting to fall
Can't
apart,
engage
Jedi.
your. Obviously, can't engage your critical thought. I'll do the thinking for you. So
Oh,
the
thanks,
light
man.
is okay. No problem. So the light's passing through an awful lot of air, isn't it? Now, if
Yeah,
you're
that's
very,
yes.
very low to the floor, let's say you're 6 foot and you're observing a distant skyline that's about 50 miles across a lake, for example, and you can only see, let's say, the top top two portions of the object. You can't see the bottom third. Now, this might be because the light is passing through the densest medium, right? It's also the narrowest angle of you have to see the object. You know what a horizon is, right? It's the limitation of your ability to observe across a surface. Because you understand that things with distance appear to get smaller. This would include the surface that you're looking across, right? Imagine the surface of the Earth was a giant chessboard. You notice that the squares further away from you, they were really, really tiny compared to the ones that you're standing on. They look big. You're standing on them, you can see them. So the ones that are far away look small until eventually you can't resolve the surface anymore. Now, let's say that limit's about 3 miles away. The object that you're looking at, let's say it's 50 miles away, didn't I? Now, you can't resolve the surface between 3 miles and 50 miles, right? That's 47 miles of surface that you're missing out on. That object that's a further distance along that surface, as from your point of view, angularly sunk into that area that your eye can't resolve anyway. So it looks like you can't see the bottom of the building that's 50 miles away on the
Okay, but wait
surface you
one
can't
second.
resolve 47 miles of.
Okay, yes, but let's say I take my eyes out of the equation and I have a giant laser, two
Okay.
giant lasers as a matter of fact, and I stand at point A and B, and then we point the giant lasers towards each other, then they won't be like completely parallel or like intersecting. They would be like going at an angle towards each other.
No, this is not what we get with laser tests and theodolites and total stations. What we have is two levels at either end, and we have those levels being parallel. They will also meet if they're at the same altitude, let's say above a body of water. If both lasers are 6 foot above the body of water, their laser lines will meet and will be parallel to the water below. This is what we measure when we survey the land. This is how we know the Earth is flat.
So have you personally done that?
No, I've made long distance observations, but I've observed laser tests that have been done. I understand that surveying exists.
So where do you think the square or like the flat Earth ends then?
Point in any direction that way.
What do you mean? Okay, let's say
If
you
you're
go all
within
the
a
way up north.
system, then just point in any direction that will be without the system. So you said, where would the limitation be? Well, around you somewhere, all around
So
you.
what
You're
would
probably
happen if you
standing
go all
apart
the
of it.
way to the edge?
Sorry, say that again.
What would happen if you go all the way to the edge?
I don't know, right? I've not experienced this place, so I wouldn't be able to tell you what happened when you got there.
So you don't think what happens? So what happens when if you go into an airplane and you just keep flying in the same direction the entire time?
Okay.
And then
Well,
what would
depending
happen?
what that direction is, if
You're gonna
it's east or
crash.
west, you'll come back to where you started.
Yeah. So let's say you start at the bottom.
Bottom.
Okay. There is no bottom according to you, but let's say
No.
you keep flying north.
Okay. Yep.
Would you end up at the same spot eventually?
No, I'd end up at north. North's an absolute direction. I'd end up there.
So let's say I start in Amsterdam,
Okay.
and then I keep flying north.
Okay.
Right.
Yep.
The current like people that believe in the globe system would say you would end up in Africa eventually, right? 'Cause you
No,
would go a circle around the Earth.
no. If you went north from Amsterdam, you would end up at north.
Yeah,
If
but
you're
I'm
at
saying
north,
that's
you
what the
can't
people who
travel
believe in
north
the globe
anymore.
system would say.
Hold on. We're going to have a failure to communicate. When you get to
No,
north,
you
which would be in,
misunderstood me.
okay, I'm trying to clarify.
Yeah, but
You
I need
said
to
when you
clarify
travel
because you
north, you'd end up
misunderstood
in
me.
Africa. Again, you're doing it again. You
No,
end
you
up.
were doing it.
Right,
Okay, let
dude,
me restate my
this
point.
is
You
going to be
start in
how it
Amsterdam,
goes.
right? Let's say
Right,
you
this
start
is
in Amsterdam.
right. He's
And
going to continue talking.
This is according to the globe. Like, let's say there's a globe. A lot of people believe that, right? So you start in Amsterdam, then you keep flying north. According to the globe, like you would end up in Africa because you would go around the Earth, right?
Yeah, okay. I understand what you're saying. I just want to use words correctly.
Okay.
So
Now you
I
rephrase
understand
it.
that if you were to follow one line of longitude, you would eventually end up where you started. This could
Yeah,
be
that's
traveling to the north and then traveling south and then north again.
exactly,
Understanding
yes.
that north and south are absolute directions. You
Yeah.
can't continue going in a direction and when you got there, continue going in that direction.
Yeah, no, but that only
But
works if the Earth is round.
I understand what you mean. So could you provide the evidence that that's happened then?
Well, you could hop on an airplane right now, and then
No,
that
okay,
would happen.
so I can hop on an aeroplane and follow one line of longitude around the Earth from north to south and back to north again. Can
Yes.
I? Okay,
Yes.
can you show me where I can take that flight from, please? And show me the flight plan because it obviously happens all of the time. Can you show me
Okay,
that
so
this
let's say
happens?
you don't go north, you go east, for example.
Okay,
There's
east
flight
is a
plans that go all the way
circle
around the Earth.
around north. This is why I was trying to get you on what directions are earlier. I
Yeah,
pointed
but
out
just
the
an
north's an
example. Okay, so
absolute
now you're asking
direction.
for an
Dude,
actual planned flight.
hello? I'm going to lose my patience. Right,
Hey, you
I'll
were
say
asking.
it
I said
slowly
north
for you.
first. I said
I'll say
north
it
first.
slowly. Being as north is an absolute direction, I pointed out earlier. East and wests are circles around an absolute direction. In
Okay,
this
but what's that
instance,
moon
we've
thing I
chosen
see
the
in the
North
sky then?
Pole. So please don't be surprised if you travel in a circular path around a pole. Do you know what a pole is?
Yeah, but it was just an example that you would go around the Earth. Like you're
No,
missing the entire point.
yes. So you can do east to west travel. That's
Yeah,
a
but did you
circle.
forget that?
Right,
Did you
my God.
forget that you asked me for a flight plan? So I gave you the other example. Then you just go east.
No.
Well, that's what you said. I have
Lines
a
of
recording. I can
latitude and
play it
lines
back
of
to you.
longitude are different when you're dealing with absolute directions. I'm
I
trying to
can see
point
why
this
you
out
are
to
a
you, but
believer in the
you
flat
keep
Earth.
thinking that talking through me is going to help you understand. You
Well,
keep
I'm
thinking
trying to
I'm
make
wrong.
you understand because you're
I'm,
misunderstanding
dude,
on
I'm
purpose.
2 steps ahead of you at this instance. East and
Hey,
west.
what's that round? Okay, another question. What's that round thing in the sky called the moon?
What's that round thing in the sky called the moon?
Yeah,
Is
what
the
is it
answer
according
within
to
the
you?
question?
It's cheese, dude. It's a cheese shoe. It's a
Yeah, but
shoe
what
made
is
of
it? What is it?
cheese.
How is it
Shoe
there if the
made of
Earth is
cheese,
flat?
you idiot.
How is it there if the Earth is flat?
Oh my
I
god.
I just posted a video about the shape of the moon. If you want to watch it, then and come back,
Oh, it's
then
was Earth, flat Earth. This room is about flat Earth, not moons.
Okay, but if I look through my telescope into the sky, what are all those planets?
How
They're
do
not
we
Earth.
know?
They're all round.
Okay.
Not Earth.
And
So you don't believe that NASA sends probes to all these planets and then circles around them and takes pictures of them from all
No, they
sides?
don't. That's not what NASA does. That's who told you that NASA does that stuff. They put out propaganda and TV shows.
this isn't going to be a fruitful conversation. He's already jumped off of one subject onto another one, and now we're.
I'm sorry, can you hear me? I have a question.
Yes. What's your question?
You're always talking about propaganda and lies people are telling you, but the globe Earth community has scientists, they have tests, they have calculations they do.
Oh,
But
okay.
flat Earth don't have those. They
That's
don't have a community that will
that's
provide
yes.
tests, with calculations, and so on. So
okay. That's not
y'all
true
can't
though.
even. Well, most of y'all can't
They only
agree
have
on.
amateurs.
Hold on. That's not true. Right?
Well, can
The
you
flat
provide
Earth
me
community
good
have an awful lot
calculations
of.
that use
Hello.
math and have tests?
Okay, Matt. What tests? Let's start there. What science tests do you have?
Hey, Jed, how
I
Hold on.
did you
No,
do in school back
we're
in the
gonna
day?
politely deal with this young lady.
Thank
How
you.
did you
Uh,
do in school
I
back in
personally
the day,
have
Jed?
none, but the science community, they do have tests. They always send.
What's that?
Okay. What are they?
Well, they did send people to space that explored the space.
Oh,
They
that's
measured the orbit. They calculated how big the Earth is, how big the sun is, how big the moon is, and so on and so
Okay.
on.
Okay.
We have all those calculations
Okay.
that
Okay.
have math behind them,
Okay.
data. But
Okay.
the flat community, and again, I'm not judging anyone. I'm just asking a simple question. The flat Earth community, they usually don't have this, or they argue about it.
Hey, we're
About
not
the moon.
judging you. Slow down. Why you keep going on? We're not judging you. Don't worry about it. That you don't have any of those numbers. We actually have all the numbers you're looking for. Don't freak out.
I'm not. I'm
What's your
asking a simple
question?
question, trying
Yeah. What
to
is it?
what is what?
What is your question? So far, you've made a
My
long-winded
question
statement.
is,
What's your question?
do y'all have the calculations of everything I mentioned, or at least some of them? And
Okay.
if you do, how exactly do you make those calculations? How
Okay.
exactly do you agree on them, and so on and so on and so on?
Okay. Okay. Got you. So first of all, before we go to calculations, we have measurements first, don't we? Calculations can be based upon actual empirical data. Right.
Sure,
For
yeah.
example, if you measure something, you can then, for example, if you've got a triangle and you measure one length of the triangle and you measure an interior angle of the triangle, another interior angle of the triangle, you can calculate the rest of the triangle. You can also calculate the area of the triangle. Even though you don't physically measure the area of the triangle yourself, you calculate it. But it will be based on measurements, right?
Sure,
Yes?
yeah.
Cool.
Yes.
So what we have are measurements of the surface of the Earth. So we measure the surface of the Earth. You call this surveying. So we survey over distances of land and water, lakes and seas, for example, to see if there is measurable curvature over the surface of the Earth. When we measure the surface of the Earth, we measure water to be horizontal upon its surface over the distances that we can measure and over the distances that should show curvature if we're to believe the claim that they can give us a radius value. So what we have are measurements of the surface of the Earth. Consequently, that's all we need. That would be the empirical standard, right? It looks this way, it measures that way, because it is that way.
Okay, that's interesting. Do you have a link or somewhere I can check those measurements out and calculations out and how exactly they prove that it's flat?
Yeah, sure. I'll go to my server and get you a load of laser tests and put them in the side chat for you if
Okay,
you want.
thank
Or
you.
I can send you a link to that server and you can look through them yourself. Which one do you want?
Okay, that would be
You want that one,
interesting.
yeah?
I would like the second
Who am I
one.
speaking to? Sorry, what's your name?
Uh, my?
As in your handle on here, so I can recognise who I'm going to send it.
Tamasha.
Cool.
Thank you.
Give me a couple of moments. You got any other questions in the meantime?
Yeah, and it's actually a question that have been bothering me. If I can ask it, that'll be very interesting. I know that not a lot of, some famous flat earthers, I'm not sure about their names, I can probably look them up, but they had went to Antarctica and they had this famous trip, and they actually did see and live streamed, filmed 24 hours of sun in Antarctica. That is impossible in flat Earth. I would love to hear your
Why?
opinion on this.
Why is it impossible on a flat Earth?
How is it possible on a flat Earth? On flat
What,
Earth,
for,
there's supposed to
sorry,
be no sun for
hold on.
Sure.
What, for a light to go round you? Well, you see this all the time on a flat stationary floor, let's say in a warehouse, and you can get a light with mechanics to go around you.
Sure, but we cannot compare the size of the sun and the intensity of the sunlight.
No, don't start waffling about non-relevant stuff. We're
Sure.
talking about the observation of a 24-hour sun. That's a sun rotating around an observer, right? In the Antarctic, in this instance, in the summer, where it is in the south. So that's an observation of a light going around you. That's really the observation, right? If you want to explain this observation and measure this observation, like describe the height of the sun above the horizon and its location and direction relative to your point, then you're going to require a flat earth to do so. But ultimately, it's just a light going around you.
Okay, that still doesn't why does it require a flat Earth? That's another
Because if you
question.
want to measure, let's say, the sun's elevation above the horizon, that's going to be an angle measurement, right? You know what an angle is?
No, not really.
Yes, it
Only
is.
if
Sorry.
you're supposing
Hold
that
on.
flat Earth.
Hold on. When I describe the sun above the horizon, let's say it's 23.4 degrees at a bearing of south by southeast, for example. What do you think those are?
I wouldn't agree that you measure it exactly that way if you take
Okay, 2 seconds. Do you know what a sextant is?
Again?
Sextant. Sextant.
No, I'm not sure.
Okay, so it's a nautical device that sailors use to measure, let's say, the things in the sky above the horizon. They measure these in angles. Now, I'm just trying to point out to you that the sun, if you want to describe to me, like empirically and mathematically, the observation of the sun, then you're going to tell me what direction it came from, what direction it went to relative to your position, and its height above the horizon that increments throughout the day. Now, they're going to be angle measurements. One above the horizon, that's the separation from your vantage point, an imaginary line, let's call it the hypotenuse of a triangle up to the sun, and then the adjacent of the triangle along the earth, so the horizon in this instance, or further beyond. So that's an angle measurement. And then the next one is going to be your azimuthal bearing angle. That's like a circle around you, and you've got north, south, east, and west. Understanding that east is 90 degrees to the right of north. Those are angle measurements too. So the 24-hour sun, if you want to do it empirically, mathematically, requires a flat earth for you to explain. But ultimately, it's just the sun going around you.
So you want to tell me on Antarctica there's a period of time where the sun just circles around Antarctica and leaves the rest of the world? Because
No, because conversely, when we experience summer in the north, we can experience the same thing in the Arctic Circle, the land of the midnight sun, for example, in the summer. You can stand inside the Arctic Circle and observe the sun rotate around the observer, where in Antarctica, it's in pitch blackness. It happens twice. You knew this, right?
No, I still don't quite understand how exactly this motion of the sun works on flat Earth.
It moves, creating
No,
circuits throughout the
I
year.
would hope so, yeah. It moves, but how?
How? It creates circuits throughout the year.
Yes.
You see two of them. We've just described them.
It moves in a circle on a flat Earth.
Circuits.
Circuits?
Yeah. We've just described two of them.
Okay, that's great.
Mm-hmm. But whatever the sun does doesn't disprove the measurement of the surface of the Earth. Your lights on your ceiling can be doing all kinds of things, but your floor, if laid correctly, will be level. You got any other questions?
Why do you call it a vacuum?
Well,
Why you guys call it a vacuum? Hello?
You call it a vacuum. We don't call it that. You call it that.
Oh, I see. I'm not sure actually. I don't know.
Yes, on a globe, you have a vacuum of a universe. On a globe, you have a vacuum of space. I don't know why you guys call it that.
Vacuum. Funny.
No, I would be laughing too. They screwed up by calling it that because that can be debunked. No, they shouldn't have called it that. They should have called it something else. Shouldn't have said the vacuum of. But now you guys are screwed. You have to stick with what your team says.
Oh, you guys believe in objective truth, right?
well, yeah.
I'm glad to hear.
That's why we're flat earthers.
Yeah,
What
that's a
about
weird question.
what about objective reality and objective morality? Believe in those also? Reality, I assume, yeah, probably, right? Objective reality.
What does that has to do with the flat or a globe conversation, by the way?
I felt that coming. I was just curious.
Or people trying to figure out flat earthers are all taking notes on us.
No, I was really curious to see what type of
I know
person
everybody's
you are.
curious
Maybe I'm
about us.
like you.
Everybody's curious about us like we're in a zoo.
No. It's. I feel like you're similar to me in a way. That's why. But me, I believe in objective reality. That's why I'm asking.
Give me an example of objective reality for you.
What this means is that we all perceive reality the same. Everything that happens, we see it the same. We may like it or not like it, It depends, but and that has an explanation also, but we see it the same. Because we
So you
only
know,
see it
so
for
you
what it
know
is.
you already know the Earth is flat and stationary and space is fake, then, because that's objective reality, right?
I'm talking about like things we can observe.
That's what I'm talking about. Same exact thing. It's amazing. We're talking about the same thing. Welcome to Flat Earth. How long have you been a flat earther?
Well, for example, things that we can observe. So
Yeah, so I mean, like the
it's
ocean, the flat horizon, airplanes flying and landing. They don't have a ball spinning under it. It's amazing.
yeah, I agree with you. What I'm trying to say is, for example, I told you this video someone sent me, some of you guys, with these two Hawaii islands, right? That was like super interesting to me. If I showed that to anyone, right? I showed that video to anyone and they watched it. Anyone who watches that video is gonna have the same reaction, maybe not reaction. He's gonna see it the same way like I did, you know. It's gonna be just as interesting, probably.
What's interesting about it?
What I'm trying to say is when we try to learn a subject, any evidence we see it the same way, all humans. Okay, maybe
How
if a
come everybody
child
tries
looks,
to tell me they see Earth as a ball then when we all see it as flat? How come everybody that comes in here tries to argue with me that it's a ball?
so if they were motivated and they looked at the evidence, maybe they would change their mind.
Well,
I
you
guess what I'm
need to
trying to say is
you need to go out and motivate these people then.
I should have like a better example. It's like, let me think of like a super good example, okay? And I know it's gonna be very obvious. It's kind of like ridiculous, but anyways, let's say a murder is being investigated, and we have a picture, or let's say someone no, rather someone has disappeared, and we see a picture of that guy uh, laying down dead, right, with a knife in his chest. We see a picture of that. Now, people in society are wondering, what happened to this person? They disappeared. They have their own opinions. But as soon as everyone sees this picture has the same impact for everyone. So everyone, as soon as they see this picture, they in their mind they think, yeah, this person is killed, this person is dead. So that means objective reality. Does that make sense? I'm not the best at explaining this, but it means that we see things the same. Like, you're not gonna have one person who looks at that and says, I think they're still alive. Unless the picture looks fake, in which people, I think probably all people think, I think this is fake.
A few minutes ago, I sent you the video to you about the sundial, right? And that video is from a glober, and he's telling the lies in front of the truth to you. Still, you didn't answer to that question. What did it move? The camera, or the sunlight, or I mean the sundial, or the sun, or the earth, or the moon, or whatever, right? Again, they tell you the truth in front of you, still you are not able to see it.
You're talking about the moon landing?
No, I'm talking about the sundial video that I posted a while ago to you,
Can you
and you
post it
didn't
again?
reply.
I don't know.
It is 2 minutes. Give me 1 second. I will post it again.
But just before that, I want to finish. Yeah, like if with this example I gave you guys, my point is everyone who looks at that will say, yeah, even if they don't admit it, in their mind, everyone inside them, everyone already believes that that person is dead. They have already changed their mind. So that means we see things the same. But if we see a picture of, let's say, you know, like, not sure if I can mention this. I don't have another example. You know, Hitler. There's a picture of him being dead, right? But I don't think that's actually him. It doesn't look like him at all, actually. Now, that picture, if everyone who looks at that picture and knows what he looked like, I think because of objective reality and we see things the same, I think everyone will think this is not him. But however, they think that by saying that it makes them look weird, so they're not gonna say that. Instead, they're gonna say, "Yeah, it's him. Whatever. Let's change the subject, right?" So this is something to keep in mind, guys. The reality is objective. We see things the same because we are the same. The
No,
same
you
souls.
are no, you are being fooled and you are believing in something without getting no evidence whatsoever. That is different. Again, I just posted the video to you, right? Now answer to my question again, right? What did it move? The sundial, the camera, or the earth, or the sun, or the moon, or everything? And keep in mind, this is a global video, right? Even in that video, he's telling you the truth. Let me know what you know about it. What can you see?
Do I have to listen to the sound also?
No, you don't. But it would be great for you to listen, right? Because that Glover is going to tell you the truth, and then he's going to lie to you at the same time. So if you could listen, that would be great. Because it's only 2 minutes, so it doesn't take too long to watch.
Okay, I'll watch it now.